weather the storm. Us together, nothing's ever felt more like home. No, I'll be there. You will never be alone. All I need is your love tonight. 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 In that moment when you're feeling like there's nothing at all, reach out to me, know that I'll answer the call. Us together, nothing's ever felt more like home. No, I'll be there. You will never be alone. All I need is your love tonight. Thinking about you. Thinking about you. Constantly thinking about you. High on life till the day we die. I walk a million miles just to see you smile till the day I die. High on life till the day we die.
Ladies, gentlemen, and other good friends, Please welcome your host for the morning from Bulgaria, Elena.
Hello, Amsterdam. Good morning. Good morning. And please welcome your host for the afternoon, Reza from Amsterdam.
All good?
You good? You sure?
Yes. Okay, good morning. My name is Reza. I'm a software engineer based in Amsterdam.
And I'm Elena. As we told you, I'm a software engineering manager at Progress. And
Welcome to JSWORLD. Woo! Thank you.
I am so excited to kick off what is promised to be the best JavaScript conference in Europe. Yes, that's right. Are you excited?
Yes!
Why is it going to be so awesome, Reza?
Yes, I'm happy you asked, Elena. Thank you. Today, expect a lot of good talks from the best in the community. We have Evan Yu, we have Debbie, we have Ujwel, we have Jan, we have so many good people. We have fresh coffee all day. We have delicious lunch. In the morning, expect an announcement from Progress, our sponsor. In the afternoon, we have prize giveaway. It sounds so good to me. I don't know, it's unbelievable. How is that possible?
Of course, it's possible because of our great organizers, the passionate people. Please give a shout out to our hosts and organizers.
Woo, 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 woo! Passionate people!
And of course, all the speakers and everybody of you who are here today with us. So let's give again shout out.
Yes, speakers. And you. Okay, Elena, let's go. It's time. It's getting late.
No, Reza, it's not the time. We have something important to share with you guys. So today, it's all about community, support, respect, and inclusivity. Please treat each other with respect. And if you need any help, you can contact us or any one of our crew members.
Yeah, I couldn't have said it better myself. It's important to show respect to everyone. And that's about it.
Yes, let's have fun. And I want to welcome our first speaker for today to kick off, our amazing Ujwal Sharma, who will talk about Nobody Asks How is JavaScript. By the way, the talk is about how the sausage is being made, and the sausage is JavaScript. Please welcome Ujwal.
Hi. Hello, everyone. I hope you're excited for this part of the conference. And thank you for showing up this early after the party. That means a lot to me. So welcome on stage again. Let's start. But let's go to the most important part of the presentation first. Who am I and why am I here? This, by the way, is me reading the first ECMAScript spec. I am Ujwal. On the internet, you might find me as Raizo Kukin. Whatever's easier for you might work in person. I am from New Delhi, and I'm based in Coruña, which is an amazing place. I would really recommend all of you to go there. And I'm very passionate about open source software and the web, and hopefully, through the course of this presentation, I would convince you why you should care as well. I also like to play video games that hurt me psychologically, and I work at Igalia. So, quick show of hands, like, how many of you know about Igalia in any way or have come across our work? Not many of you, but, well, that's my cue to introduce us. So a little bit about Igalia. We are an open source consultancy, which means that we work with some awesome people working on open source software and building new things and technologies. We're also worker-owned, so everybody who works at Igalia is a part of the owners. And we work across different open source projects and ecosystems, basically anywhere where we can establish our expertise and sort of provide value to different people. This includes things like Linux, a multimedia space, for example, and different areas such as web platforms and web browsers. So if you didn't know, all the major browsers and engines are open source. So this allows us to excel at them and work on them. And lastly, but not the least, we work on programming languages and compilers. And hopefully a programming language that you all love, or maybe at least know, and somewhat avoid despising or enjoy. Like, it's a love-hate relationship, right? But JavaScript is what powers a lot of us every day. But while we know what is JavaScript, or at least we seem to be interested, how is JavaScript? How is it doing? Is it on the right path? Is it going to continue to serve its millions of users, possibly? Or how does it even figure out what to do? Like, what's the next big thing? So hopefully, through the end of this presentation, I would be able to convince you that it's in the right direction and that we're doing good things. But let's talk about JavaScript. So one of the most important things about JavaScript, which conversely people tend to not know much about, did you know that JavaScript is standardized? How many of you knew that JavaScript is a standardized language? Okay, that's great. C++ is standardized. All languages that are used extensively in the same way tend to get standardized in a way. But standards are complicated, right? Because they need a lot of work to sort of give direction. Talking of standards, what even is a standards body? Like, how do standards even work? So I have a question for you all. Do you all remember this whole piece of like internet history or legend, so to say? No? So basically, Unicode is a standards body that standardizes things such as emojis. And the best part about a standard is that while it helps us sort of come together on something, it also leaves a lot of stuff up to interpretation. Like, if the cheese should be at the bottom of the burger, I would not eat a burger like this, but it's fine. Everybody likes different burgers. But that's the point of standards, right? Like, we can all agree that these are burgers, but some of us like to put the cheese in a different place. And that's fine. But yeah, talking of these standards organizations, I'm sure that even if you're not already sort of involved in a standards organization or actively sort of following a standards organization, your work on the day-to-day is affected by it. Some of these standard organizations include vuejs, who do a lot of great web stuff. There's W3C that is responsible for different standards in the web space as well. There is ISO that standardizes virtually everything, including the height of your ceilings and stuff, like country codes. There's ECMA, which we'll go into in a bit, but that's where we work. It used to stand for the European Computers Manufacturers Association, but now it's just ECMA. It's like KFC, as I've heard. And there's Unicode, as we talked about. They standardize across languages, across different tools, and a lot more. But what is this? Like, what is ECMA even doing here? Basically, there are different venues where people come together from different walks of life, from different organizations, from different sort of spaces in sometimes competing industries, and they come together on certain topics. They're venues for unifying or basically coming to sort of consensus on certain things. So together we can work on the language that we are all invested in while making sure that everybody's views are sort of taken into account. So TC39, in the history of descriptive names, may be the best one. It totally explains what it does. So I shouldn't have to go into detail. But yeah, OK. TC39 is the 39th technical committee. That's all it says. But just so you know, TC39 is the technical committee that defines the JavaScript language, which, we're going to talk about today. But who is TC39, right? Like, we can have a vague idea of what TC39 does or is, but I think there's a lot more value in who is in TC39, what's going on there. So there's a bunch of people who are delegates from various organizations. These organizations could be implementers, people who actually build browsers or JavaScript engines like Apple, Google, other companies that build different engines. There's companies that just generally maintain huge JavaScript code bases like Bloomberg. There's different students and nonprofits like different universities, the OpenJS Foundation, Mozilla. And then there's different invited experts. So there's a lot of subject matter experts and other experts that we onboard who are not necessarily already a part of committee, but we decide that their viewpoint on either something specific or generally on the evolution of the language is something that we really sort of admire, and we would like to have them on board. So this could be certain subject matter experts, like people who know how time zones actually work, and community representatives, people who are influential in the community and could help us bridge the gap between all you amazing developers and the work of the committee. And then there's this whole crew of contributors, of editors, of reviewers, and the community at large is, according to us, a part of TC39. I think your feedback always is sort of instrumental to us doing anything. So in my view, you're already a part of the committee. Let's just make sure that you are more, let's say, violently contributing. So how does it work, right? What's the process like? So quickly going through the stuff about TC39, if you had one takeaway from this whole presentation, according to me, this would be it. In TC39, every decision is based on consensus, which means that not only do we bring all the stakeholders together, we make sure that they can actually agree on a topic. Is this easy? No. Is this sometimes extremely painful and could burn you out? Maybe. But the most important thing is that because everybody is sort of coming together to agree on a certain thing, this allows us to sort of bring everybody's viewpoints in while making sure that we are doing something which is unequivocally good for the future of the language. So we make sure that we have a diverse set of people in the committee, that people from different walks of life or industries are brought in, and that there's a space to give objections, to make concerns, but at the same time that all of these objections, if any, are rational, that there's something actionable about them. So we have a direction even in rejection, right? There's different stages through which different things work in TC39. There's 4 star stages of maturity, but I'll talk about this in just a bit. And these stages are nothing but different steps in the life of a proposal. Usually it goes in a sort of increasing order, but sometimes it can go back and forth. But the stage is a very important sort of piece of information about any proposal, because it gives you an idea of how far along its journey it is, how close it is to becoming reality, and as I would explain, what kind of assumptions and inferences you can make from this. There's also different task groups that we work with. So the work of TC39 is not just the whole group coming together. There's TG1, of course, that deals with the core specification, the core language. But there's other task groups like internationalization, which I'm a part of, for example, who build specifically the Intel API. There's a security task group that deals with running JavaScript in secure environments and what the security guarantees of the language could be. Could it be more secure? There's a task group about source maps, who, by the way, recently published the source map specification. So it's a real thing now, and it's published. You can check it out. And finally, we have a new task group, which is about research on language standardization. If any of you happen to be academics, for example, or just generally interested in how you could research about this standard process, please join in or let us know. Where does everything happen? Mostly on GitHub. There's the GitHub ECMA TC39 organization where you could see that literally every single proposal is a part of. Every single proposal happens to be just a repository on this, and the different discussions and sort of decisions that happen in the life of any proposal happen on the issues and pull requests. So you could not only see live what people are arguing about, but you could also be part of the argument, whatever floats your boat. Also, there's the literal spec out there. I've heard that people like to actually read this from time to time, but yeah, it's on the website, and you can actually read through the JavaScript spec and figure out how the language is defined to work. When do things happen? We tend to have a busy schedule, but things sort of converge around 6 major meetings. So every 2 months, on average, we have in-person or online meetings where everybody kind of comes together and where real progress happens on things, although the details are sort of done in the interstitial time. These meetings generally these days tend to be 3 online and 3 in person. So 1 in the Americas, 1 in Europe, 1 in Asia. And we try to at least go to different places and talk to different stakeholders also through this. Then there's more focused calls. There's focus groups specifically. There's incubator calls about certain things. And these calls can happen more frequently. They can be monthly or bi-weekly, and in some cases even weekly, for people to converge about a very specific topic and nerd out about the details. And then there is a few official sort of meetings, like the meeting for internationalization, the meeting for different editors to talk about what the editorial shape of the spec should be. And all of these meetings happen at their different cadences. So let's talk about the stage process. What is the stage process like? It starts with 0 because we're programmers and nerds and sort of don't hate arrays. The first stage is called a straw person. This is a stage where things are quite early. Things are sort of not fleshed out at all. It could be an idea. It could be something that you scribble down on a piece of paper. But most likely, it's going to be like a README file, right? A explainer document, as we like to call it. It's something that is very open to discussion, and it's a very oversimplified version of the proposal. But most importantly, one of the things that we care about at this stage a lot is the problem statement. We seem to be not so interested at this point about what the solution would be like or what we should be doing, but rather what the fault or sort of the motivation is. Because I think that's a more foundational thing. If that is established, then you can go on to the next stages. There's a bunch of stage 0 proposals. You could check them out. Some of them you might even like. But a lot of these proposals are either very early or they're just stalled because people don't even agree that there's a problem to begin with. So that's kind of what stage 0 is all about, which takes us to stage 1. So stage 1 is when things start getting serious. You can see that like the proposal is literally called a proposal at this point. So it's a real proposal. It's starting to describe the shape of a solution. So at least we're in this space now, and we're starting to sort of, we have agreement that this is a problem. We have agreement that this is something that we should be spending time on, but in the process of spending time, we are actively litigating everything else. So at this point, we have a champion, somebody who is actually responsible for pushing this and for sort of getting everybody on board. And you could also start hacking around, making some demos, some polyfills. But the most important thing is that this is the point where major changes happen in any proposal. This is where we fight out about the details, about how things should work. And yeah, like things could very well change at this stage. An example of a great stage 1 proposal is signals. I'm not going to go into much detail because it's going to be presented later today, but yeah, it's something that's extremely popular, and we agree that it's something that should be sort of included as part of the JavaScript toolkit, and we're figuring out the details of how that should actually happen. So, example of what we suppose, keyword here being suppose, the Signals API would be like. Another stage 1 proposal is decimal. So this is also another proposal where we're quite clear on what the problem statement is. JavaScript has numbers, and numbers are, well, JavaScript numbers are not great at certain things. And we're trying to address that through adding decimals to the language. So, I don't have to explain much about decimals. I think you all understand the motivation somewhat. And there's a lot of other stage 1 proposals. These tend to be proposals that we find very popular, but are at a stage where we can't get to agree on certain details. Then we go to stage 2. So stage 2 is when things get way more serious. It's called the draft stage, and this is where real syntactic and semantic details are not only sort of finalized, that they are put down in text. So we can have an initial sort of spec text, some language around how things should be, and we are working on nitty-gritties of the proposal. They're not completed at this stage, but we finalize sort of what the shape of a solution would be like. However, the feature at this stage is still extremely experimental, but we do expect that this feature would become a reality at some point. That's why it's at stage 2. An example of stage 2 proposal is iterator chunking. This is an interesting operation that you might find yourself doing from time to time, and yeah, it's an example of something that we have some idea of how we can achieve this, and we're figuring out the rest of the details. Another great stage 2 proposal is extractors, for example. If you're a fan of destructuring arguments and all of these kind of things, extractors make you even more powerful in this regard. And then, after stage 2, comes a new stage that we added, which is stage 2.7. Great. Why is it 2.7? Well, so the problem with our existing process was that there was stage 2, right? What I just talked about. And then there's stage 3, which, spoiler alert, this is where things start actually shipping and being implemented and all of this. But there is a very small period between stage 2 and stage 3 where the proposal is kind of ready, but it's not ready to be implemented because there's no tests yet. So the implementers who are actually writing the code are not very confident about the feature because they can't actually test their code. So we added this new stage exclusively for writing tests. So at this point, the details have been finalized. It's beyond stage 2, but it's not being implemented. So it's before stage 3, stage 2.7. We are nerdy like this. But yeah. So we call this the candidate stage, and as I said, we have the full spec text, we have the details, but we are now working on conformance testing. There's 2 resources for Text262. Obviously, there's the Text262 GitHub repository. You can literally go there, add conformance tests, help out with certain things. By the way, it's one of the best projects to get started with TC39. So this is how, for example, I got started. Getting more involved in TC39, so I'd really recommend checking out. And they need a lot of help and work and love. And improving this has the side effect of making our language more consistent. So, win, win, win. There's also this dashboard by our friend Canada Hong called test262.fyi, where you can see sort of interactively what kind of tests results you get for certain features, for certain engines, and you can play around with this quite a bit. An example of a stage 2.7 proposal is deferred evaluation. So if you use modules and have some reasons to not always invoke the module all the time, we are going to add a defer keyword. So you can say import defer, and this way, everything won't be executed immediately, but on demand. So basically, deferred evaluation, right? Another stage 2.7 proposal is Shadow Realm. So Shadow Realm is adding a sort of new structure to the JavaScript language where you can create a different execution environment, a different execution context to run your code in. Think of this as sort of a iframe, but within a JavaScript environment. So you don't have to create an iframe on the web. You can create a Shadow Realm, and it can work across not just web environments, basically. This is an example of how that would look like. And then to solve the specific problem that we earlier talked about, there's math sum precise. Numbers are not very precise, which means that sometimes adding them can be a bit of a mess. But math.sum precise makes sure that when you're adding a bunch of things together, they are basically achieving the result that you would assume. Then there's stage 3, as I sort of alluded to earlier, but now talking about it more specifically. This is when we call things as recommended for implementation. This is where the tests exist. The feature is sort of finalized, and we're starting to actually implement it, put it into browsers, putting it in front of users, asking them sort of how they would use it. And this sometimes reveals new information, reveals information about certain aspects of the implementation, certain aspects of how a proposal works or interacts with other feature, which we can take into account for changing the proposal. But ideally, this is not a point where anything changes in the proposal, unless there's something that uncovers some problems. An example of a stage 3 proposal, which I hope is popular, is Tempro. And I don't have to convince you that it's popular because of the State of JS survey. So it is popular, and basically Tempro adds very strong date time capabilities to the language. Date already existed but had major pain points, so Tempro provides a very simple to use API that hopefully people would not hate as much as they hate dates, which is great. There's a lot of interesting operations you can do with Tempro, but I won't sort of belabor the point. Another great, and as you might have noticed from the last sort of slides, popular proposal is decorators. Decorators is also stage 3, and it allows you to sort of decorate things in your classes. And yeah, it's a popular feature in the TypeScript community, I know, and hopefully this would become more popular across the board in JavaScript. Then there's the fourth stage. It's sort of not a real stage. In that fourth stage is when things go, when they're finished. We conclude our work. We decide, okay, we decided what the feature would look like. We finished doing it, and now we call it a day. We have all the data we could need, and this is not going to change anymore. So we add something to the official JavaScript spec, and it becomes a part of the language that we all know and love. An example of the fourth stage proposals is array buffer transfer. This allows you to call .transfer on an array buffer, and this is something that could be optimized further on the sort of engine side, but it adds an important sort of operation. Another example is set methods. So as you might know, JavaScript has sets, but these sets are unusable without the most important set operations. So we added the set operations. We realized that it was missing, and we can now have intersection and difference. So you can use sets like you would assume you could use sets. There's a lot more stage 4 proposals, and these are kind of the success cases. I think it goes without saying that this is a very small, this is a point where a very small fraction of things reach, but everything that reaches to this point is finalized, and hopefully something that's very strongly motivated, because there's a lot of, all of these stages are basically where things are getting filtered out, right? And everything beyond that is sort of part of the ecosystem. It's added to Babel, to SWC, features land also in TypeScript. But yeah, everything else is part of the ES Next, so to say, edition. And like every year, we publish a new version of the specification. So this June, we're going to publish ECMAScript 2025, which has been finalized already. But most importantly, how do you get involved, right? I hope that by this presentation, I managed to sort of demystify all of this to you a little bit. I hope that you're motivated to actually get involved, but how do you do this? So there's a few different ways. I already mentioned writing test262 tests. That's a great way to get involved, and people are always like willing to help you out with this. But there's also like all these issues that I talked about. Every proposal has all of its problems laid out bare in the issues. You can interact to different people there, present your opinions. You can help us write documentation. We write MDN documentation, for example, for a lot of our features, and educational materials. You could go to different conferences like this and talk about the different features that we're working on. And generally, you can make yourself heard on GitHub. Remember to be respectful, but yes, like the average developer's opinion is very valuable in this because, you know, there's different stakeholders, as I talked about, but the core user of JavaScript needs to be better represented. But that's it for me. Thank you.
Thank you very much, Ujjwal. What an amazing opening today for the first talk. Next up on stage, I want to present you Ben Holmes, who will share us about how to put your database in the browser. Really? Can we do that, Ben? Let's give him a shout out.
All right. Wow, what a extreme intro with that EDM music. I don't know if I can follow that up. But hey everyone, I'm Ben Holmes, and today we're here to talk about putting the database in the browser. So first we're going to talk about what the heck that means and what I'm talking about. We're also going to be getting into some fun live coding and diagramming so we can see why you might explore an architecture like this and what it means for the types of web apps that you build. So I wanted to start by diagramming the journey that you go on building a website for the first time. Usually, you start by creating some sort of web server that all of your clients are going to talk to. You add some sort of database storage mechanism, maybe Postgres, MySQL, whatever flavor you prefer. And then all of your clients connect to those servers, being able to perform writes and read data back down over an HTTP connection. That's how it's worked since the dawn of time and the first C server was invented. And it works pretty well as long as you're near enough to your data. But if you're like me, you're from the East Coast and you travel to Amsterdam, suddenly the latency can get very, very long. And that's true for any globally scaling web app. So what do you do in those situations? Well, commonly, if you're working with a read-intensive application, which is most of them, from documentation all the way to social media sites, you'll usually start to create some database replicas. This could be just a caching system based on Redis, for example. It could be a full-on SQLite clone that you're going to duplicate all of your writes to. And whenever a client wants to connect, they might submit all of their writes to a centralized server, and then all of the reads come from the nearest cache that they have in their region. So maybe we keep our web server where it's close to us, the developer, and all of the database caches are near the users in Amsterdam or wherever else that might be. And this works really well because there's only one source of truth that all of the writes come through. And you'll often hear this called something called single leader replication, single leader. That means there's only one person that all of your rights go to. Whenever I want to submit a post to Twitter, it will always go to the single leader, and it will distribute out to all of the caches. And, that works pretty well if reads are the most important thing. But there is still that bottleneck of writes being pretty slow. And if you're building an app that is highly interactive and has a lot of write requests, like say you're building a calendar, for example, and you're dragging events around, you're increasing and decreasing the length of an event, you don't want to see a loading spinner every time you make those edits that last for a few seconds. You want everything to be snappy and local and working on your device. And you can do that in memory, but if you've ever set up Redux in React, you know how painful that is. It's very hard to keep track of client state and match it back to your server. So ideally, there's some sort of way, when you're building a very interactive application, to move your writes as close to the data as possible. Maybe you can have a distributed system using something like DynamoDB and Amazon or Cloudflare D1. And you can distribute all sorts of little data centers around the globe where all of your writes can travel through. And if you're using a good set of infrastructure, it'll help with all the duplication and merge conflicts to get that data to all of the other caches with eventual consistency. And you'll usually hear that called something like multi-leader replication, where there are multiple leaders or places that you can write data, and it'll handle the rest of actually telling everyone else about it whenever you update a calendar event, for example. But we're still dealing with some pretty intense technology here. Now we've had to set up data center replication. We've had to couple ourselves to Cloudflare D1. And if something goes wrong or the docs are inaccurate, then we're kind of out of luck. We're coupled to whatever provider is setting this up for us. Love to Cloudflare, by the way. I absolutely love their services. But ideally, when we're working with something like this, what we want to do is move the data as close to the client as possible. And in the perfect world, the database wouldn't even be in a data center that we have to manage and replicate ourselves. It would ideally just overlap the circle right here, the database directly inside of every client. That way, we're not managing the infrastructure of replicating the data everywhere. We just ship an app. The app bundles all the logic to write to a local database. And it also bundles all the logic to sync to some sort of source of truth that's able to say, all these writes occurred in this order, and will replicate it to all of the other clients that are connected. And this setup might be referred to as a local first application. If you've heard that phrase floating around, this is one example of that. It can go as extreme as decentralized servers that can work offline, or it could be as simple as writing to a local data store and fetching whenever you're online. If you've used Google Docs, if you've used Linear for task management, Superhuman for emails, all of them are using a similar setup, where we write to a database store in the client itself, and we bundle all the logic to sync that to all the other clients around the globe. And that's what we're going to be talking about today. Now, normally, when you're setting this up in the browser, you need to rely on browser-based utilities. So IndexedDB, you may have heard of, local storage, of course. But up until recently, you haven't had options that feel like the database you use on the server. Until now. There is a way to put SQLite directly into the browser. And it's not perfect. It's not like putting Postgres in the browser, though that is also happening. But it does let you use SQL-like syntax to write data directly into your browser. And it's all possible not through an in-memory mock. It's actually writing to a file that we can interact with. You can see some examples here. I'm kind of foreshadowing what we're going to do. But we're going to connect to a SQLite store directly in the browser to show you how powerful it is. There is an official WebAssembly build if you go to the official SQLite documentation, which means it's literally assembled for the web or anywhere else that you might be deploying to. And there are already wrapper libraries that make it easy to interact with that SQLite file in the browser. SQL Local is a favorite of mine, since it manages creating the database file and gives you a nice template syntax to insert data with some serialization to make sure there's no bad or malicious data getting into your data store. And if you want to talk to it, it is as simple as creating a new database and calling it from the browser. I put it on the window object so that we can play around with it in here. So if I click DB, there's our SQL database. It's directly in the browser. It's in our DevTools. And you'll notice there's a way to get the root file if we wanted to. So if I just said db get database file, that will give you a browser standard file object. So you could write this to local disk if you wanted to, put it in your downloads folder, or interact with it directly in here. You can see it's an application SQLite file. And this is all possible because of a special technology called the Origin Private File System, which is a very complicated way of saying there's a private place for your browser to store data. When I'm creating a SQLite database, I don't have to ask the user for permission to access their documents folder. The browser now gives you a sandbox where you can write files and manage them. So if you wanted to build like the perfect image editor in the browser, you could do that. You could just put a bunch of image files inside of a local bucket, and it'll read just like a file. Similarly, we could do that with SQLite. I have a set of dev tools pulled up here created by the Chrome team that lets you inspect all of the database files, or any files really, that this particular website has access to. So here I've created 2 database files, and if I ever need to download them, I can just click on this and it'll download straight to my device. So if I wanted to use like the CLI tools for SQLite and debug what the heck is going on, I could do that as well. If you're curious more about it, there actually is an official spec for it. On Can I Use, it works everywhere, including Safari and Firefox. Very rare to say that these days with new things, but it does work in every single browser. And the Google Chrome team has written some really nice guides, including those dev tools I just showed off, in order to play with it. And to show you how effective it is, let's go ahead and run some SQLite queries directly in the browser, see what's going on. So we could insert a value, for example. That just inserted some data. We could select those values back out. So now we have a nice list in here with some key value pairs of all of the data. I also have this migrations file that's running on startup, so you can see we can create a table and query it if we want to. We can also spin down the table if we want to. We can delete data out of the table if we want. Go ahead and select again. Now the data's gone. It's a file. It really is a file. So if you close the tab and reopen it, it's not going to reset in memory or something. It is durable, and it'll live for the life cycle of your website. And it's not prone to being like killed if you try to clear cache, which I'll do here. Even if I select now. Oh, we deleted, didn't we? Yeah, let me actually demo that. So if we go ahead and do that, select, you can see it's there. I'll refresh a few times. Maybe close a tab, reopen it, inspect again. Don't do that. SQL. I almost did it again. From issue, you can see right there, still there. There you go. So yeah, if you wanted to put SQLite in the browser, it's totally possible. But that's not the most interesting part. It works on my machine, and if you're trying to build a local first to-do app, that's totally fine. But it is nicer if we can make it a little bit collaborative and actually sync it back to a server so other clients can see the data that I'm writing. And we're going to do that by using some local first technologies. So I have an Astro site pulled up here. I am biased as someone who works on Astro, but it is the best way to demo this concept, I think. And we're going to build out our own little sync server to see how this works. And we're going to be using a model that was popularized by Replicache, which is a really great batteries-included framework for building these sorts of apps. And if you know Git, you know how it works. There are 2 major endpoints that you need to implement. It's going to be a push and a pull. When you pull, as you can imagine, that's going to pull down all of the data from the server into the client. And when you push, that's going to push up data from your local SQLite file into the cloud or wherever your server is deployed. And with these methods, we're going to actually sync it to a real database. So the demo app that we're working with is a version of Linear that I've lovingly called Minier, because it's a miniature version of Linear. I'll go ahead and demo that here. So if we do like first task, that deploys right away. We can make a second task if you want to. I went too hard on the keyboard shortcuts. They actually work. And you can see it's all very snappy. I'm awaiting the SQLite queries, but you can see it's updating throughout the entire app if I just invalidate with React, for example, or use whatever runtime I want to. Because it's writing to disk, and devices are really fast now with SSDs, you can rely on SQLite storage and just await the result, and it'll feel just as snappy as an in-memory database. It's really, really cool. But let's go ahead and try to connect this to a server, just to see how it works. So what we spun up here is a Node.js app, and I have a client folder right here, where I've done some scaffolding to hook into where we write data and where we read data. So we have mutate that gets called for any SQLite action we want to perform. And this is going to be talking to a queries object that just wraps our SQL queries into a readable function. So create issue accepts these arguments and runs this query. That's also true for other queries in our application. And if I wanted to push up these updates, for example, we could do something as simple as fetching. So if we wanted to push up data, we could call the push endpoint that we're about to implement. We could run a post request, and we can pass in a body with the function that we just ran and the arguments that it accepts. So in this example, whenever I hit the create issue button, it would tell the server, I just ran create issue with these arguments. Can you do the exact same thing on your end? That way we're in sync. And then the server can come along and say, yeah, sure, I'll go ahead and run that query. First, let me validate it to make sure that you're not giving me bad data. I wrote out a ready-made schema here. So this would check that you're calling a function that actually exists. Also, please add authentication checks so random people aren't writing to your database. That should go without saying, but it is a REST API, so make sure you implement all of that. And we can parse out whatever that client request was to say, all right, the client said to create an issue with these arguments, so I'll go ahead and do that. So I'm going to get the SQL statement out. I'm going to go to that mutation object that I just mentioned. And I'm going to call whatever function the client told me about with those arguments. And that's the beauty of full-stack JavaScript, where you can have an isomorphic file. The client knows what queries exist. The server knows what queries exist. You don't need any code generation. Just import the file in both places. It truly is a JS world out there. Terrible pun. I'm sorry. All right. Now we can just run that statement inside of our server database, little utility I made. And now it should be pushed. So let's go ahead and demo that to see if everything's working. So I'll create a third task, for example. That should create it on the client. And if I pull up my terminal, you can see now we've made a request to the server to push some data. And this is just a little SQLite connection that I have to a server-side SQLite database. And you can see right here, we have also persisted that third task on the server. Very cool. So now we're able to tell the server about the changes we make, but how do we get them back down? For example, let's say just as a client, I'm going to make a curl request to the push endpoint that we just made. So some other anonymous client wants to make an example task. You can see that pushed successfully. I can select out. Now we have 2 tasks in here. But if I refresh my client, it doesn't know anything about that example task. It's not connected to pull things back down. So we need to implement some way to pull data. And I've set this up with a polling mechanism. But if you're fancy, you could, of course, use a WebSocket to get instant updates whenever a write occurs. Just to show you what I mean, there's this pull endpoint in the client, and that's going to be connected to a little use effect up here on an interval. So let's go ahead and implement pull to see how that might work. So we're going to be doing this using an event logging system. There are many ways to approach this. Sometimes you might want to pull down a literal snapshot of the data in the database, or you could pull down the latest events that have run on that database. So you keep a big log since the start of your server of every function call that has occurred. So whenever someone asks, what's the latest status, it can say, yeah, client 1 just ran the create issue query. You should do that as well. So we can update that log by saying add a mutation log entry. This is just backing up to a SQLite table. So I'm going to pass in the arguments whenever we push. And then on pull, we can read that log back down. So I can say, here are the mutations. We're going to read everything out of the log. And we'll just go ahead and return that as a response. So this is going to return all of the logs that have occurred since the dawn of time, which is useful if you're scaffolding a client for the first time. They've just signed up for the service. Here's the big list of events to run to make sure that you match the server. So I'm going to go ahead and say fetch. This is going to fetch all of those mutations with a little bit of type safety from the pull endpoint. And we're just going to run all of them against our database. So I'm going to say entry of mutations, and I'm going to run those against the client-side database. So the same thing the server did when we push data, the client's going to do whenever we pull data. It's going to run all of the statements. It's going to invalidate all of the React queries. And we're also just going to do something simple here to make sure it's all working. I'm just going to blow away all of my local data and refresh it against whatever the server has. And as long as the server's up to date, that should be a faithful rendition of everything that all of the clients have sent. OK, so if we go ahead and run this in our browser now, and I'll just go ahead and reset our database so we can get it fresh. I'm going to create another task in here. And we should see that appears. And we also do get some duplicates because of how we've set this whole thing up. I think I've also missed something whenever we pull. I believe this is, is this actually resetting our database? I think I'm resetting the wrong one. There we go. OK, there we go. Yeah. OK, so it is resetting the data and hooking it up to the server snapshot. And most importantly, it should sync up with other clients that are trying to make changes. So now, boom, there's our example task. Now it knows about other clients. Very cool. But I'm sure you're thinking, isn't that pretty wasteful to delete your entire database and recreate it every time? You would be right. That's probably a bad idea, because we're basically running a bootstrap of the whole system whenever a new update comes through every 2 seconds. So you can imagine that could be a lot of invalidation and bad states. So we need some way to not get all the events, but just the latest ones that the client doesn't know about. So let's go ahead and comment that out and implement something like that. And we can do that just using a cookie mechanism. This is the approach that Replicache uses, but a more simplified version. So we're going to store in the cookie the last log that the client knows about. So let's say it knows about the first 10 events. This log ID should be set to number 10. And then we're going to get all of the logs that are after that point. So maybe from logs 10 to 14, because there's only 4 new logs. That would get passed down instead. And once it's passed everything down, we'll update to the end of the list. So now we've bumped the log ID to the end of the list, and on the next request, we'll keep moving that sliding window of all of the events the client doesn't know about yet. OK, so now we've set up a nice cookie mechanism, and we have dropped our delete query. So now it's just going to push whatever the latest logs are. If I go back to our client, we can see some crazy stuff happening while we were in the middle of it. We can see it pulls down everything from the server. We should still get our example task, like before, but we will hit one problem for local updates. If I go ahead and add this, you'll notice we're going to get a duplicate, because we've pushed up the data to the server, and then we pulled the exact same data back down. So we have our client replica, and then we have the one the server knows about. So this is an optimization, since now we're only getting the latest logs in the system. Like, as it's polling, it's going to be polling empty objects instead of huge events. But we need some way to tell what client events the server has acknowledged and which ones it has not. So we know in this case, it should know that there's a duplicate for the 5th task. So how are we going to do that? Well, I'm going to bring back Git as an analogy here. Whenever you're working with branches in Git, you know that you usually have like a local copy of the main branch. So that's going to be whatever is existing in our server database, for example. And then when you need to make some updates that the main branch doesn't know about yet, you go ahead and branch off. You make a feature branch, you make all of your changes there, and then as soon as you're ready to push it into main, you would go ahead and merge that branch into main. And then if the main has updates, you would rebase your branch back on top of main. So we're going to implement that same sort of flow by having 2 separate databases. So we're going to have our regular DB, which is our copy of all the data that the server has told us about. And then we're going to have our optimistic database. And that's where all of our client-side writes will go. And we can implement that sort of rebase strategy by just kind of overriding the database file. So you can see here, we're going to sync all of the latest changes into our server-side database. Then we're going to update our client-side database to match the server. And then we'll just invalidate all the queries again and make sure everything looks as expected. So if I head back to the browser, we should see everything is reset. We get all of our tasks. And now, if I add another issue, we should no longer see a duplicate come through, because now we're rebasing onto the server states. We're blowing away our optimistic updates. So this is almost perfect. Well, OK, we're pretty far away from perfect. But it is almost good enough to ship as a demo. But there is one more edge case to consider. And that is when your push takes a lot longer than your pull. So I'm simulating that by adding like a 5-second delay every time you try to write data. And in this case, if we try to add 7th task, for example, we'll see that pops into view, then it disappears because the server doesn't know about it. We just rebased onto the server, and then it pops back in later because finally the server has resolved and we're able to pull that back down. So you end up in a state where it might flash some content that wasn't updated in the server yet. So we also need to handle that case. And we're going to do so with a pretty naive solution, but on GitHub, I've created a more robust solution that you can go check out. So first, I'm going to introduce a client-side log of events. This is how we're going to keep track of, oop, I changed my, oh no, come back. I'm just going to keep typing. It's going to come back. Give it a moment. Yes. There it is. All right, perfect. You didn't have to watch me typing out functions by accident. All right, so you can see here, now we're going to update a client-side list of events so that we know, OK, we've optimistically created a task. I'm going to write that down and say, I created an issue with this title. And then when the server sync comes along, I'm going to go back to that list. And I'm going to say, what updates in this list has the server acknowledged, and which ones has it not acknowledged? So I'm going to say flush as a setup here. And we're going to grab the length of the mutations. Caveat, this only works if you have one client connected. You need a bit more sophistication to make sure this number is correct. But here's the principle we're trying to do. Let's say we pushed up a set of 4 events. And then when we pull from the server says, I only have 3 events that you told me about. The 4th one I haven't seen. In this case, we're going to say, all right, I'm going to flush out the first 3 events from my local log, since it looks like you acknowledge those. But for the 4th event, it looks like I should run that against my local copy. That way I don't lose the changes that I made locally when I try to pull your changes. So I'm going to say for entry out of this log that I've created, so get mutation log. Instead of this being all of the events I've run, this is just going to be the events that the server did not acknowledge. So now I can go ahead and run those statements against my local copy. And now this is going to replay the client events that the server hasn't told us about on top of the other state. So if I go ahead and add a 8th task, how do you spell 8th? That looks weird. 8th task. Live coding's hard, OK? Stop. OK, so now you can see it no longer disappears, because now we're replaying client updates that the server hasn't told us about. OK, that is the full demo that I wanted to get through. I'm running out of time, but I'm going to do something very chaotic. Everyone on your devices, go here. Go to this URL, wood.dev/SQL. If you go to this website, this is a very dangerous choice. This is a live website with no authentication. You are allowed to hit the add button and create tasks. It is read-only. You're not allowed to write anything. It should generate it for you. I'm not sure if it's going to work. OK, we've got it. People are doing it. OK, I want to see this board light up with people just adding tasks. And you can update status as well if you want to just like click on these buttons and change the status. This is live data, people. YouTube, people watching on YouTube. Add things. There we go. This is a local first app, people. All of you are updating on a SQLite file, and I'm streaming in the updates just fine. There we go. Very cool. OK. I think it deserves some applause. Come on. There we go. OK. Well, if you enjoyed the talk, you can set this up yourself. If you go to my profile, I'm bholmesdev everywhere, including Twitter and YouTube, if you want to follow me there. But also on GitHub, you can find Simple Sync Engine. This has a full breakdown of how the project works and all sorts of caveats, important things to consider. So if you want to pull this down and build a robust sync engine of your own, I'm hoping it's a springboard for you to learn more about these technologies. With that, it's the end of my talk. I hope you enjoy the rest of JS World, everyone. Thank you.
Thank you, Ben. Thank you. And next up on stage, I've got the awesome Jan Braga, who will share us how to elevate our component testing by using Storybook and Vitest. Welcome, Jan.
Good morning. Hey, everyone. Really nice to see you all here. I wanted to ask just a very simple question. Can you raise a hand if you are a person? A real human being? All right. I knew there would be AI in this conference, but I didn't know it would be actually in the audience over there. I'm here to talk about Storybook and component testing with vtest. My name is Jan Braga. I work for Storybook and Chromatic. I'm part of the maintainers of Storybook team. And now that I know half of the audience is human, out of the humans, who knows about Storybook and vtest here? OK, that's really good to know. I'm sure the AI knows everything, so I'm not even going to bother. You know, building UI in 2025 is incredibly complex nowadays. Before, you just throw some HTML, everything's great. But now, even a simple component like this chart can have multiple states. So you might have a warning state, an error state. You might have something completely personalized for different use cases. And what about modes? Maybe you have dark mode. Maybe you have internationalization. Maybe you have responsiveness. There's like so much stuff that you need to account for. And it becomes super overwhelming when you actually get to put all of these pieces together in building an app. And it's just the tip of the iceberg, You have to care about performance. You have to care about other kinds of things like security, bundle size, state management, accessibility, of course. And it's just really tough. So keeping track of UI has become kind of like a chore. I'm sure many of you have worked on a team, maybe building a component like a timeline, and then turns out another team has already built it, but you just didn't know. It happened to me. So if keeping track of UI is really hard, let alone testing. Testing front-end has kind of evolved over time. We started out with unit testing tools like Jest and vtest or Mocha, Chai, and whatnot, and people wanted to test their components. So people are leveraging tools like testing library to basically mount their components with React, Svelte, Vue, and other tools, and then use testing library tools to interact with the components and test them out. The thing is, a lot of these solutions, they were using JS DOM or Happy DOM, which are environments that simulate a browser, but they're actually not a real browser. And although you get really fast test results, you actually don't get the fidelity that you want. So if anything fails in one of those tests, turns out that they just give you this blob of HTML, and it's really hard to parse. I know maybe the AI doesn't care about it, but for me, it's really hard. So you go for something more visual then. You might be looking for end-to-end testing solution. Maybe you're using Cypress or Playwright or others. And the thing is, end-to-end tests are really great, but sometimes they might feel like overkill. You're not going to really write 1,000 tests to basically test something really small. It almost feels like you're using a bazooka to kill a fly. Ooh. So end-to-end test solutions are great, but sometimes they can get really expensive, and you don't want to feel like that. So what do? If you really care about your components and your front end, your pages, your features, and you want to be confident that you're shipping the best UI out there, how do you do? So we start by looking to unit tests because we want speed and control, and tools like vtest are incredibly fast, or blazingly fast, if that triggers anyone here. And then you want also the fidelity from end-to-end test tools. However, you want to have a space where you can put all of your components and test them in the browser. So tools like Storybook allow you to catalog those components and get them easily into the browser state. But now you actually want to benefit from all the three of them. So what if you could have it all? So Storybook, for the ones that don't know, is basically the best component workshop tool out there. You can easily build your components in isolation. So when you think of an example like this restaurant card, which has so many different states and modes, they all get streamlined into Storybook. And you can easily, now that you catalog them, you can easily go through them and see if they behave as expected. So the thing is, later on, when other teams are using Storybook, they actually get to see that the timeline component already exists. So they don't have to spend like a whole cycle of their work for nothing. And Storybook can also be extended with add-ons for extra capabilities, such as a theming add-on that allows you to render light mode and dark mode, or even put them side by side and see an entire page and how it behaves right there. And vtest is basically the best test runner out there. It's incredibly fast, it's really great, and it integrates really well with a lot of things. And it has improved over time, and vtest actually has recently released a browser mode, which basically gets the perspective from the previous slides, but now actually allowing you to run and mount those tests directly in a browser. And that is possible because of Playwright. Because vtest browser mode uses tools like Playwright, also a WebDriver I/O, to basically get you to this browser automation environment. So Playwright is the best tool for browser automation, and it provides you with an environment that has high fidelity tests, which is great. So when we go back to all of them, and when we basically get the best place to develop your components in isolation, the best place to test your components, and the best environment to test your components in, if you put them all together, what you get is Storybook Test. So I'm happy to introduce you to Storybook Test. It's a new feature we just released and we're actively working on. And it's basically a batteries included solution that is going to allow you to get everything you want in the best place together. So we have ways to quickly create different stories, write new tests, run them with vtest and browser mode, and accessibility, and so much more. But you know, show, don't tell. I'm just going to give you a quick demo of that. So let's go. Where am I? All right. So right here, what I have is my code editor, and on the left side, I have the browser. And as I mentioned, I have this restaurant card component, which has different states. And maybe when I put it in Storybook, I don't have a lot of variants yet. So how do I do that? First of all, Storybook runs outside of your app. So I actually have that running in the terminal right here. And then similar to how you write tests, where you need a test file alongside of your component file, I also have a stories file alongside my restaurant card. So I'm here developing my components, and then I have my stories file along with what we call a story. So the restaurant card has a default story, but then I know for a fact, because Storybook is telling me in the add-on panel here, in controls panel, that my component has a lot of metadata. And I can actually play around with that because the isClosed flag could be set to true, and now I see my component behaving differently. So if you see here at the very bottom, hopefully it's readable, there is a button called New. So I can actually click on that button and then create a new story. So let's say this is the closed story, and bada bim, you actually get the code right there written for you. So now I have a new story, which is all great. And the thing is, Storybook is great because you can manually see all of these variants. But now what I want is actually a way to test them with an automated environment. So at the very bottom here, we have a new feature called the testing module UI. And this is all set up with a single command. And then once you get it, what you can do is basically click on this button. And then what this button is doing is essentially transforming all of your stories, in my case 74, and it's running all of them in a vtest browser environment incredibly fast. Actually, it's already done. So if I take a look into my stories and I expand them, I see all of these check marks, and that means that they rendered correctly and the tests were passing. So, you know, I can create newer cases. So let's just say I want to create a few more for the restaurant card. but I don't want to be running my tests all the time. Well, I can actually enable watch mode and then start from there. So let's say I just want to get a new variant right here. If the restaurant card is new, and I say new, once I click it, the tests rerun. And because it's using watch mode, it's actually going through the dependency graph and only running the necessary things. So now the tests are incredibly fast. There are also ways to run tests directly from a specific group of stories or components. So if you hover over the elements and then you click here, there is a way to just click on this button, start test run, and then before you even think, the tests are done. So you get the best of VTest, the super incredible speed, and it's all integrated with Storybook. So I've been showing you something simple in a way because this is a component that's essentially just rendering. I can also actually get to something a little more complex. I have a restaurant detail page component right here. So let me go into Storybook and then go to that detail page story. And that is actually an entire page. So this is, Storybook allows me to basically test everything I want over here. I can render my entire page here. I can have different states, for example, the not found state, where I mock the fetch requests which are happening in this page, and then I get different states, so like the error state, the loading state, and therefore I actually don't need to keep refreshing the browser to try and show the loading state for my colleagues or throttle the internet connection. So that's great. And over here, you see that the success state of my component is just a page, but I also have a story called with modo open. So when I click there, I actually have this interaction going automatically for me, and that's essentially basically going to the success scenario and then clicking on this guy. So this is happening because Storybook has a concept of a play function. The play function is essentially a way where you can write tests and they get executed directly in the browser. That also means that if you share your Storybook, because it can also be deployed online, the tests are going to execute in any environment you want, including the phones. So you can write the play function yourself, but we are in an era where we also want to automate everything, right? There's actually a community add-on called Interaction Recorder from Igor Lushenkov that allows you to basically click over here. Let me just make things a little smaller. Just give me 1 second. Give you a bit of breathing space. So if you click over here, you get this kind of code gen like scenario where if you hover over the elements, not only it will give you the right kind of selectors, but if you click on them, let's say click on the cheeseburger, and then click on add, and maybe I will open the sidebar. So after I stop recording, what is happening here is it's giving me the necessary code which I need to import and the necessary play function which I need to write, and that has to be attached to my story. Let me go to the story file of the restaurant detail page. And the thing is, I also don't want to write the code myself. I actually have a button called Save to Story. So if I click there, and then I say, interactive, and then I save it, it does all of that for me. It visits my new story, and on the right side, as you can see, it actually has written the code for me. So this code, as I keep on changing it, will keep getting re-executed. And I can get test results right there because I'm also running my tests in watch mode. So let's just say something goes wrong with my code because the name of the element which is being trying to be found doesn't work. On the left side, I very quickly see that I have a failure. So the restaurant detail page has a red dot right here. If I click on it, it gives me an overview of what is happening. And then I can click on component tests, and then it will open the component tests panel in Storybook. So the component tests panel essentially reads all of the code you've written in the play function, and it actually instruments it and provides that visually in the panel in the browser. So what happens is not only you get to see, you quickly catch bugs or failures in your tests, but you can also debug them directly here. So you can go back to the initial state of that component, and then you can go back and forth through the steps which are happening in the play function, which is basically related to the test you wrote. And then once something is happening that doesn't work, you get the failure right here. And because you're in the browser environment, that means you can just debug with the tools you like. So once I fix the test, everything reruns, and it's all good. It's perfect. So this is one of the aspects of the testing module from Storybook. And the testing module was built to be extensible. So that means, you have components which might not have such tests, and the Storybook testing module is going to test them anyway, basically checking whether they're mounting correctly. Oh, why is that useful? Well, maybe you're replacing a library, and maybe you're upgrading something like Tailwind or whatnot, and maybe your components actually break. Maybe they don't render correctly. And all of that is caught automatically with Storybook test. And because we want to make things extensible, you can actually increase the exploration of your tests to different things. Not only you can create your own testing pieces to the testing module, in case you want to create your own testing solution, but we also provide an accessibility add-on. So we actually have an accessibility mode, which I'm going to enable right now. And the European Accessibility Act is coming. Everybody needs to really care for accessibility. Not that they didn't have to care before, but now they're forced. And in a way, it's really great, because now that I have the accessibility testing bit, I can run all of my tests. And the first time you ever do that, it's going to be like a Christmas tree, because everything is going to light up. You're going to get all sorts of like red and green effects. But let's see, all of my accessibility tests are passing. So let's just get an example right here, for instance. I have a small component, then maybe it actually has a different color. Maybe it's not that accessible. And I didn't realize that. So what happens is I get 10 error messages, 10 failed tests over here. I can click on this button, and then it will filter out to the failing tests. And I can see that my component tests are passing, but the accessibility tests are not. So when looking into the results, and like I said, sometimes it can be quite overwhelming. You might have a lot of accessibility issues. The pro tip here is to take a look into what's going on. So the restaurant card is failing for accessibility. I can click on this button, and it opens the accessibility panel that shows me what's going on. It explains what the problem is, and I can also highlight the elements that are actually failing. I can see that this is barely readable, and that makes sense, so I should fix that. And if I take a look into the other stories, like, for instance, this home page, sometimes the page is too much. But now that I know that this component is failing, and then I see the same component right here, and also I see that I have a review component, it's all connected. That means if I fix the review component, which is the most atomic one in this formula, all of the tests are going to rerun, and therefore I just have many less errors. So that's the thing about accessibility. It's something that we need to care a lot about. There are automated tools out there that allow you to get quick test results, like what we are using here, which is based on Axe. But at the same time, you also need to care a lot more, and there's things you need to account that are not automated. However, this will get you so far, and it will also put everybody in your team to essentially start thinking more and more of accessibility every single time they're building components. And basically, you get now component tests, you get interaction testing, and you also get accessibility testing. And another thing from Storybook Test, which we also love to show, is essentially code coverage. So let me go here and enable code coverage. And because code coverage is something that a lot of people want to track whether they're covering their states. Storybook is a great way to do that, but it doesn't also show you exactly the missing states. It only shows you the ones you have written. So if I run all of my tests with code coverage enabled, what is going to happen is we're using vtest browser mode, which also uses v8 for coverage collection. And then once the results are done, I actually here at the bottom have a coverage item. So once I click on it, it opens the code coverage report right in my browser, and then I can take a look into what's going on over there. I see that this badge component has like 40% coverage on branches, so I can go inside and see the code. So it turns out I don't execute this code, I don't execute this, and I don't execute this. So, let's take a look into the badge component. The badge component doesn't have a story file. So I think the easiest way to cover my states is to easily write tests. And Storybook allows you to do that very quickly. So we actually have a button right here where you can create a new story file from a component. So let me just write badge, click on it, and turns out now I have a new file. So look at that. Storybook wrote that for me, and I didn't have to do much. Now I am already having that component to be tested. I already have accessibility testing, all that stuff. And if I go to the controls panel, not only I have my basic story, but I can create a new one, like Hey JSWORLD. And then I can save the story, and then it will update my file. Everything reruns with hot module reloading. Now, let's just very quickly create another set of examples. Let's say this is a squared icon button, so square icon. And then I also want to make it uppercase, you know, just because shout to the world. And now my story has been written for me. I can also, of course, update it manually, but I don't want to spend time on that. So now I can basically rerun my tests. I had about 83% code coverage, and the coverage is going to be recalculated. So once the report is back, I can go back to my badge, and for whatever reason, the code coverage is the same. But you know, that's basically what happens when you're not, when you're doing a live demo. Just give me 1 second. Let me just enable the code coverage again. Oh, I forgot to mention one thing. This is all experimental. So it's I'm allowed to get in this scenario. So, you know, I'm just feeling like AI. Oh, it's not working. Let me try again. It's not working. OK, let me try again. Oh, look at that. Works. So I have increased 1% of my code coverage. And when I look into the component badge, all of the code is covered. So that, in essence, is Storybook Test, what I wanted to show you. And I'm really excited to have you guys testing it out. So what I've showed you is pretty interesting, but like, how does it actually work? You know, Storybook Test is not a magical thing. It's actually just a simple vtest plugin. So if you're using vtest in your projects and you are already running, let's say, I don't know, 200 tests or 300 tests, all you have to do is to create a new testing configuration. But it turns out you don't need to do that because we do it for you. So if you run a single command, you can essentially get all of your testing set up for you by Storybook. We are increasingly doing a lot of code mods and auto migrations, so Storybook is getting more and more evolved in that sense. So once you run that code, you get everything set up, you run Storybook, and you get all of the experience, which I just showed you. And the thing is, because this is essentially a vtest plugin, that means your vtest commands, which run in CI, they're just going to actually get the stories integrated. So, you know, maybe I don't want to run Storybook at all. You don't have to, because now it is integrated, and it's mounting your components in a vtest browser environment, even if Storybook is not running. So you get all of the speed and convenience that you like. And because vtest is one of the best tools out there, there are so many integrations for it. So basically, you get all of those benefits put together. So for instance, if you're using VS Code or any VS Code-like editor, you get a test extension on the sidebar. Basically, all of your tests and story files are now listed there. And then you can click on a button to very quickly run tests of all of your components without even leaving the editor. And you know, if things go wrong, you can actually let AI fix it for you. There's a few AI here that can just go there and fix them. So you get the failures. You can click on a button from VS Code that essentially tells Copilot, I don't care about this, just fix it for me. And then it does it for you. Like, how cool is that? So you get all of these integrations out of the box for free, mostly because everything is just so nicely and tightly integrated. And that's essentially Storybook Test. So we basically have a batteries-included solution that integrates with the tools you like and love. And it allows you to quickly run your tests, to run them in watch mode, to run all of them, to get code coverage, accessibility, and whatnot. And if you're interested in that, like I mentioned, it is experimental, but we already have a lot of content out there to help you understand how to use it, how to set it up. We have a Storybook Test Bootcamp that we want to share with you. You can scan the QR code to get more information about it. And it's got interactive tutorials, videos, and guides, and we also have a very interesting community out there, so you can join us. And you might be wondering, Storybook 8 has been released last year. What's going on with Storybook 9? Well, like I said, the Storybook test is experimental, but turns out we actually have been working on it a lot, and it's much more improved for Storybook 9. It's going to be the release where it's going to be stable. It's going to be easier to install than ever. And we actually have, a lot of people have been mentioning, oh, Storybook's such a bloated tool, but those people are using like Storybook 6. Get with the new times. So basically in Storybook 9, things are going to get so much more smaller. And I mean it. Like, Storybook 8 had this dependency graph, and then you can see Storybook 9 right there. We have decreased in 48% the bundle size, and the amount of dependencies has decreased enormously. We also have collaborated with the E18E, the ecosystem performance group, to basically get all of that stuff sorted out, which is amazing. So yeah, thank you so much. I hope you appreciate it. And if you don't mind, I just want to take a picture with all of you so I can share in the socials. Thank you so much.
Thank you, Jan. Thank you. And now it's time for a coffee break, so grab a cup of coffee and stretch your legs. See you soon, in a bit.
like an arrow, just to be where you lie. Meet my quest, do my shambling best to be near you, where you lie. I found peace in your arms, gentle storm, rage my way. Fall in love with me. Fall in love with me. Fall in love with me. Every day. Counting down, now the clock's reset. When I met you, do we start a new line? Yours and my speech on restless hearts, they were meant to beat one time, share one fate. From this day, gentle storm, rage away, and fall in love with me. Fall in love with me. Fall in love with me. Every day.
I weigh the water, I feel it all. I ask myself a million questions in the dark. I lay in silence, but silence talks. It tells me heaven is no closer than it was. My heart keeps pulling in the wrong direction. I'm about to cross that line, looking for the wrong affection night after night. Trying to find a new distraction, wanna make it last all night. Everything that I've been mixing, all mixed up inside. When I get to call ya, and I'm gonna call ya, with late night feelings. When I get to call ya, and I'm gonna call ya, with late night feelings. On and on and on, feel it on and on. On and on, on and on, late night feelings. Make me psychotic, you pull away. You take the same in me and tear it like a page. I write you erotic, and I know you wait before you answer, just to make me go insane. My heart keeps pulling in the wrong direction. I'm about to cross that line, looking for the wrong affection night after night. I'm trying to find a new distraction, wanna make it last all night. Everything that I've been mixing, to cross that line. Looking for the wrong affection night after night. Trying to find a new distraction. Wanna make it last all night. Everything that I've been mixed, all mixed up inside. Wanna get to know ya, and I wanna call ya with late night feelings. Wanna get to know ya, and I wanna call ya with late night feelings. On and on and on, feeling on and on, on and on, on and on. With late night feelings. On and on and on, feeling on and on, on and on, on and on. With late night feelings.
Hello, hello, and welcome back after the coffee break. I have Catherine here with me. Hi, Catherine.
Hello, thank you so much for having me. I'm super excited to be here. My name is Catherine Grayson Nans. I'm the Senior Developer Advocate at Progress, and I have some very exciting news. that I
Oh
get to
boy,
share
is it
today.
time for that news?
It's time.
Okay, woo, so I'm super excited. I've been waiting for this news, guys, for a long time, so thank you, Catherine, for being here.
Absolutely. So, as you can see above me, we are very excited to be here in Amsterdam to introduce our brand new free React UI component library. For those of you who may not know us, Kendo React has been around for about 7 years now, but previously we were an entirely commercial library.
Yes,
We
that's right.
are changing things up big time. Yeah, I heard that, boo.
And where is the woohoo? We are not going free.
So Kendo React is highly customizable. You can get in super quick, apply any of our pre-made themes. If you don't feel super comfortable choosing colors, you're not into that, apply anything that we've created, have it look super fantastic and professional right out of the box. Or if you like to get in and do that design work yourself, you absolutely can. We have Figma UI kits. So if you're working with a designer, they will love that. They can design with exactly the same components, export it from Figma into our theme builder program, and then automatically export Sass and CSS that will work perfectly with these components. We're also highly accessible.
Super accessible.
Kind of a big thing right now, right? With
Yes,
this-
of course. So, of course, accessibility is super important. We have to include all of our users and yes.
The European Accessibility Act is coming very soon, and we are already compliant. Same for the United States Section 508 and WCAG 2.2. So that means keyboard navigation, Y-ARIA attributes, high contrast color palettes, and we've manually tested those with JAWS and NVIDIA screen readers. Finally, Kendo React is professionally maintained. Because we have this split commercial approach, it means that we get to support a team of developers who are super talented and really dedicated. That means you'll always get day one releases, a regular release cadence, new components, new features, new integrations, bug fixes, and a constantly evolving roadmap based on what we hear from you, our users. So what about you? What do you think is your favorite part of Kendo React?
To be honest, my favorite part of Can React free now, because it's free.
Your favorite part is that it's free now?
I have to be honest with you, Catherine. I have a crush on the React data grid, on the canned React data grid. Yes, because I like my grids performant with small bundle size. I don't want to focus on that. I just want to keep my focus on my business logic, and I want the state just to work out of the box for me and everything to be built in so I can focus on my business needs when I'm building an application. So yeah, the canned React data grid is all I need for that.
That's a really good choice. I've had to build a data grid from scratch, and I would not like to do it again.
Yes, that's the point.
If you want to learn a little bit more, I highly encourage you to check out our documentation. We have getting started guides with all of your favorite frameworks. We also have a great project tracker page template. So if you want to get in, explore the code a little bit, check out our implementation examples, you can do so super easily right here. But perhaps the biggest news is that there's $3,000 on the line for whichever of you can create the best application using 10 of our brand new free Kendo React components. You have 2 weeks to do so. We're hosting this big hackathon. The best one will get that $3 grand. But we also have 2 fantastic runner-up prizes of $1,000 each. So if you think...
So you heard her, people. Let's go and build something beautiful and take our money.
You think you're going to enter the hackathon?
Can I? Of course, I would love to. So yeah, thank you everyone thank you, Catherine, for this announcement. And
Absolutely.
Now I will leave you to Reza and in his company.
Okay, thank you, ladies. That was very interesting. That was awesome. Hi, I'm back. Thank you. For the ones who were not here in the morning, my name is Reza. I'm going to be your MC for the next few hours before Elena comes back again for the end of the day. How was the coffee break? I guess you have not recovered from the party last night. How was the coffee break? Yes, that's more like it. Our next speaker comes from Germany. At the moment, he lives here in the Netherlands. He knows everything about debugging apps. Please put your hands together for Luca!
Hey everyone, wow, this is bright, so many people. So how many of you have struggled with debugging your servers in production? Just a quick show of hands. That's pretty good. It's a pretty large number of people. When I debug my apps in production, this is a representation of what that looks like. I stare at AWS and complain. I hope by the end of this talk, it'll look more something like this. Looking and knowing immediately what is wrong because your observability is great. But first, let me quickly introduce myself. I'm Luca. I'm a software engineer at Dino. This is some of my colleagues. How many of you know what Dino is? Let's do another show of hands. Wow, that's, yeah, nearly everyone. For those of you who don't know what Dino is a server-side runtime like Node. It can run your Node.js apps out of the box. But it comes with a bunch of interesting things built in, like a formatter and a linter, and it runs TypeScript out of the box, and it uses ESM by default, and a whole bunch of other cool things. I'm also a delegate at TC39, so you heard Ujwal talk about TC39 this morning. He's there. Dan's there too, who you're going to be hearing a talk from in an hour. And I work on Winter's TC as well, which is a standards body dedicated to, or sorry, not a standards body, standards group inside of ECMA dedicated to making server-side runtimes more compatible. So making your code from Node work well in Dino or in Bun or the other way around. And I contribute to a bunch of web specs as well. So, how do you have a good debugging experience? Well, you start out with having all the data, because if you don't have any data, there's nothing that you can debug in production. And the data that you really want is like, what happened, who triggered it, how long did it take to be able to analyze for performance problems, when did it start, to be able to pinpoint when something went wrong, and what request is it part of. I'll talk more about the last one in a second. Most applications already create logs. How many of you use console log? OK, anybody that didn't raise your hand, you're lying. There's unfortunately a bit of a problem with logs in the case of servers, which is that if you have a bunch of logs for requests that are coming in at the same time, so parallel requests, which is very common in servers, you can often not associate which requests belong to what logs. And this then ends up with situations like this. So I have a server here that logged something out, 2 HTTP incoming requests, it made 2 database queries, and then there was an error that some column null is undefined, or some column name is null. Does book 1 or book 2 have a null name field? Who can tell me? Nobody, exactly, because you don't have the data. This is one problem with logs. Logs can be really useful, but they can also really be very tricky to work with if there's not enough data attached to them. So let's spice up our logs a little bit. This is something any of you can do in your applications today. What if we associate a request ID with every log, and actually with every request? So when you get an incoming request, we assign it an ID. For simplicity's sake, let's say 1 and 2. And then every time you log something out, you print out that ID with it. And now it's really easy to tell it was book 1, because the request ID for that error is the same one as for the log line for the first GET request. So this can be a bit cumbersome, though. I mean, you could write code like this. I'm sorry, this is a bit small, but you could generate a random request ID and then pass it in through your entire application. In every single function, you take the current request ID and print it out in your logs. Who of you thinks that this is a maintainable way to do this? Nobody. Good. Such smart people here in the audience. This is going to get really repetitive, so let's not do this. Let's do something else. And I'm going to show you a demo real quick and then explain what's going on. So I have a little application here that I've written for Dino in TypeScript, but it's actually using Express. You can see I'm using Express here, actually using the new Express 5. And this is all the application does. So creating an app here, I have a handler that handles API calls to API book with an ID, and then it makes a database call, and we're just serving that on port 8000. And I'm not actually connecting to a database. I just have a little fake database in this function that takes 300 milliseconds. So what I can do now is start this up with Dino. And it's now serving on localhost 8000. And let me curl this. Can you all see this? Yeah. And that works. Cool. So I don't see any logs. Oh, right. I forgot to add the logs. Let's do the logs. So let's add some logs over here. And I'm not going to associate them with any request ID. I'm just going to print out the same logs that you saw in my slides. So yeah, Copilot. Good, good. Why write code yourself if you can have someone else do it? Console log. And here we're going to print out database get book from database. And let's print out the book ID as well. And let's restart the server and curl this. And you can see it didn't print out any request IDs, but I have a trick up my sleeve, which is that actually this is exporting logs to my telemetry system, to Grafana right now. So if I switch over here to Chrome and open up Grafana, and hopefully you can all see this, and query my logs, I will see the logs here that I just created. So here's my HTTP call, and let me make another couple HTTP calls, and maybe also an error, and query that. And you can see all the logs here. And you still don't see any trace IDs or any request IDs. But if I click on one of these logs, there is this ID associated with that log. And if I filter down by this trace ID, you can now see that I'm only seeing logs for that specific request. So Dino has somehow automatically added an ID to each of my logs that associates it with the request that it came from. And this is particularly useful for the error, right? I have an error here, don't know where it came from. Let me filter it by the trace ID. And I can see it was book 2. So, yay. So what's happening here? This is not magic. I know it looks like magic. It's not. It's called async context propagation. And what's really going on here is that the system is essentially has some state that it passes down every time a promise is created. Every time you call await or you call a new function, there's this state that we implicitly propagate with your call. And that way, you can, at some point, sort of create this request ID, and Dino does that automatically, without you having to do anything. And then it propagates it into all of the functions that are ultimately going to be called from that request. And actually, under the hood, this uses a TC39 proposal that's not quite released yet, but we already have internal access in Dino, called async context. So if you want to check this out, this is the thing that backs this. We'll be able to use it in the browser at some point. This is actually also what makes React server components work in XJS. Completely different reason it uses that, but OK. So what else can we use this for? We can use this to track who triggered something. So we know which request triggered it, but if I have an error, I may want to answer questions like, why did a specific operation get started? Like who, maybe I have multiple call sites that are both doing a database query. I want to know which one of the 2 call sites called my database query. And that's really useful because let's say one of the call sites passes incorrect arguments all the time. I would like to figure out which one that is. We can use the same context propagation system for this by making it figure out what the parent operation is. So an operation here is like anything that you want to track, so maybe like an HTTP request, or a database call, or like deleting something from disk, or really anything that's interesting to you. And you want to track what the parent is. This gets us traces. Traces are what? Traces are this, are the ability for you to see who triggered what, when, and how long did it take. So looking at this graph, there's a lot of information in this graph. This is one request. You can see that it was a GET request to the books endpoint. It then did an authorization check, which under the hood made a call to, I don't know, Redis, for example. That took 10.2 milliseconds, didn't fail. It then did another call to Redis. It did 2 database queries. It did a set to Redis. You can tell immediately, like, maybe if there's a performance problem, like, what are you going to start working on? You're not going to work on Redis, and you're not going to work on the authorization handler. You're going to work on making your database query faster, right? This is something that you can get with traces. And you can also see, maybe you could have parallelized these 2 queries. They're currently running back to back. Maybe they could have been running in parallel. So traces are made of spans. That's the technical term in OpenTelemetry. A span is really just an operation that records like what the operation is, so the name, maybe some attributes like what the query was, what parameters, how long it took, when it started, who triggered it, the parent span, and then what trace ID is part of. And which trace ID it's part of is that thing we were looking at before with the context propagation. So you can know like which request triggered what. If you're more visual, this is what that looks like. I have 2 spans here, the HTTP request and the database call. They both have some attributes. The HTTP request, for example, tracks what path the user hit, and it tracks like how long it took. It has the trace ID. It has a span ID. A span ID is within the trace, like the order of operations of the operations. And then the database call looks very similar, has some different attributes on it, and it has a parent span ID. And the parent span ID says, like, this operation was started by this other operation. So here, the parent span ID is 1. The HTTP request is span 1, so we know that the database call was triggered by the HTTP request. Yeah, so as I said before, this helps you answer like why questions about specific requests. Like, why did the request take long? Why did it error? What query did it fail in? Why is the wrong thing happening? You like don't even know what, you know something is up, but you don't know what. This can really help you figure that out. So let's do a demo for that as well. I don't have to do anything. Let's start by just opening Grafana. And instead of looking at logs, let's look at traces. And let me send a request. And, oh. query that. And here is our latest request. And, oh, is that the latest one? No, that's not the latest one. There we go. So this is the latest request. And you can see there's currently only a single span here, this root span from the HTTP server. And it has some attributes on it, like it responded with a 200 status code. This is the path that I hit. This is how long it took. But we probably also want to instrument our database query. So how do we do that? Well, it's really easy. You just write some code that does this. And I have a little helper utility called withSpan that I can just wrap any function with, give it a name. Let's call this get book from database. Sorry, this is sort of like scrolling off the screen here. And parentheses. And this is going to pass in the span that it creates, and I can use that to record some attributes onto the span. So maybe I want to record the book ID. So book ID is the book ID. And now if I restart my server and curl this again, and I'm also going to create an error, and then give it a couple seconds. Ah, there it is. We now have two spans. So we can see that there was the incoming HTTP span, the one that was automatically created by Dino. And then we have the one that I just created with my book1 attribute on it. And actually, let's also look at an error span. This is what it looks like in the error case. So here, I can very quickly, just by looking at this, tell that the reason this request failed is because the database request failed. So I could look in this more, and I can see, oh, the message is book is missing author. Cool. I now know book 2 is missing an author, immediately know where to fix the problem. So that's traces and spans. Who of you here uses microservices or runs more than one service in production? Okay, maybe 25%? So you're all going to find this really cool. Traces don't just have to stay within one process, they can span processes. So they can go from one service into a different service. So a quick reminder, spans need to know their parent, right? But what if each of the spans is in a different service? Well, what we have to do for the other span to know its parent is to send along the information of what its parent is. And we can do that, for example, through HTTP headers. This is called propagation. There's a spec from the W3C called trace context that specifies this trace parent header that essentially just contains the current trace ID and span ID. And when you send a request from one service to a different service, if you include this header and the other service understands it, it will just continue the trace, the same one that the first service started. I'll demo that in a second. So the DIY approach to implement this looks something like this. You get the current span, and you then get the span context from it. You build this header, put in the trace ID, put in the span ID, add the trace parent header, call fetch. Again, this is really annoying. Who wants to write code like this all the time? You don't, so don't do this. And this just, again, works out of the box. So let's create a new file here that I'm going to call, I don't know, main.ts, I guess. And we're just going to do a fetch call from this one service to the other service, just getting the first book, like this. Okay, and we're going to log out the book. And I still have the server running, the original one. I'm going to start up a second server. And this requested the book. That worked. I see the database query and the HTTP log. And if I head back to Grafana, you can see that I have a new trace. And if you look carefully here, you can see that the service is not the book API anymore, but it's the fetcher, because that's where the trace started. And if I click on this, and I have 3 spans, 1 green and 2 purple. This is the outbound fetch span from my first process, and it automatically propagated into the second Dino process, where I can continue. So you can imagine that if you have a lot of microservices, this could be really deep, right? You could even instrument your database and have your database query planner output spans that you can see in here. Cool. So we can now debug things if they go wrong. If we know what request failed, we can go look at it and figure out why. But this still leaves us with a problem. How do you even know that your website is down or that there's some other problem that needs to be investigated? So the first approach is you wait until your users tell you. How many of you operate on that principle? Good. Brave man over there. Yeah, this is probably not the best idea, though. You want to be ahead of your users, right? You want to know when something is wrong before your users tell you. And the way to do this is through metrics. Metrics are like aggregate information about the health of your service that you can set alerts up for. So for example, here I have a metric chart that just tracks the number of requests per second with a given status code. I could set up an alert here that says if more than 5% of my requests end in a 500, I want to be wrung out of bed at 3 in the morning. Probably you don't want to have this be set at 5%. Probably you want to have this set at like 0.5%. But yeah, you create metrics in your application, and then you can alert on them. And Dino also does this out of the box. So actually, I don't even have to do anything else here. I can just, again, open Grafana and look at metrics this time. We're going to look at duration seconds count. I know this is a bit confusing of a name for what I'm going to show you. This is the number of HTTP requests processed in any given minute over the past, well, I don't know, whenever this graph started. And actually, I'm going to close this to have some more space. And, sorry. I'm not used to working on such a zoomed-in Grafana. OK, so here's what we're going to do. We're going to send like a quintillion requests to my API here and see if we can see them in the metrics. The metrics only update once a minute, which is fine. But that means we may have to wait for a second. Oh, there we go. Cool. So you can see there was a bunch of requests. And actually, if I want to see this by status code, I can do that. I now have the number of requests by status code. So over the last however many minutes, I got 3,000 requests with a 200 status code and 1 request with a 500. And every time I make another request that would result in a 500, that would obviously show up here too. OK, so that's metrics. Those are the 3 pillars of OpenTelemetry. So I've showed you this in the context of Dino, but this is applicable not just to Dino, but it's also applicable to Node, to any other programming language you may want to learn or already know. Java, Go, Rust, they all have this. Logs. What happened? When did it happen? And maybe you know which request it's part of if you have the trace ID stuff. Traces. What happened? Who triggered it? When did it happen? How long did it take? And which request it's a part of? Traces are like the thing that you use to debug things if you already know there's a problem and you want to figure out what the problem is. And metrics, if you want to get woken up at 3 in the morning because your app is down. So yeah, that's in Dino 2.2. Telemetry is built right in. So for those of you who haven't tried, I would urge you to try. I'll show you in a second how. You can run any existing app, any existing Node app. In Dino, we have Node compatibility. Or you can run a new app with some framework for Dino, or yeah, whatever you want. As you saw, there's like not really much setup. Out of the box, you'll get the log correlation, so the console logs with a trace ID. You'll get traces for incoming HTTP requests and outgoing HTTP requests. You're going to get metrics for request count and request latency. You're going to get this automatic propagation across services. And there's a lot more stuff coming soon. Like we just shipped this in 2.2, which was like, I don't know, a month ago. Yeah, and if you need more, you can really easily add your own log spans and metrics to your application. You just import at OpenTelemetry/API from NPM and create your own metrics. Count them, whatever you want. So if you want to try it out, this is a slide you want to take a picture of. Install Dino. I suggest you just start by setting up a Grafana locally. It's really easy. There's the instructions in our docs. And then you run Dino run on your entry point, go to Grafana, and you'll have logs. But if you're already using an existing observability stack like Datadog or Honeycomb, New Relic, Google Cloud Monitoring, AWS, anybody that supports Sentry, anybody that supports OTLP, you can ingest metrics, spans, and traces from Dino into. So yeah, that's my talk. Thank you all.
Luca Casonato, that was awesome. Thank you very much. Now, it's very interesting to see some diversity up here on the stage. For example, Luca is probably the only one using Light theme for his code editor. That is some diversity I had never seen before. Next up, we have a duo. That's very interesting. They are all about trying new experiments, so keep an eye out, see if you see anything that's interesting or different as an experiment. I want to call them up. I say Natalia, you say Igor. Natalia! Igor. Natalia! Igor. Natalia! Igor. Come on up!
Here. Thank you for having us.
Hello, Amsterdam. How are you doing? That's very quiet. Is it before lunch mood? Like the energy is very low here. What's going on?
Okay, we're going to feed you some microfrontends. I'm sure you like that. All right, so we're going to talk to you about a problem, a problem that we have in the front end that we're trying to solve. And as you can see, well, I'm Natalia. I work for Microsoft. I do developer tools and experiences, and this is...
Hey, I'm Igor. I love working with web. I'm very much into open source. I'm one of the co-creators of Angular, and I'm a Cloudflare, doing a lot of stuff with web platform, developer infrastructure. So even though we're working at two different companies, we actually have something in common.
Like being barefoot.
Yeah, being barefoot is one of them. The other one, we actually like to push web forward and just try to find ways how we can help developers build successful web front ends and how to push the web developer experience as well as user experience forward. And on this journey, we often interact with customers. And during these conversations with customers, especially enterprise customers, we see some common themes reappear.
Absolutely.
What is it that you see?
Yeah, they have some common challenges, and they face these challenges when they're trying to modernize their platforms because they want to introduce new technologies, they want to adopt whatever is out there in innovation. And we also see that.
Yeah, and keep in mind, in enterprise, you know, many of these front ends have been around for 7, 10 years,
15,
and
20.
the web has changed so much in the last 10 years. You know.
Absolutely. And they also face some common problems when they're trying to scale. When you have a platform that's been growing for 10, 5, whatever amount of years, it becomes a huge, typically monolith. And when you're trying to make it, to add new features, to scale it, you are going to face some constraints. Besides the constraints of trying to modernize and scale, our customers don't want to go through big bang migrations.
It's often that they don't want to, they just can't afford it. The applications are too big, they're often business critical, mission critical, and it's just impossible to rewrite the application from scratch. It's just a non-starter. The other thing that I often hear from our customers is that when looking at new technologies, they're very concerned about vendor locking. They are looking for technologies where they have freedom to move and freedom to experiment and not be locked into just one choice forever. So as we've been looking at solving these problems, how to help enterprises modernize their applications and scale within these constraints, we looked at various solutions and start to narrow down the solution space. And what we realized is that to modernize this web front ends, we need to enable enterprises to gain mobility. What does this mean?
Well, it means that they can start migrating incrementally, so to avoid those big bang migrations that they cannot afford.
Including architectural changes.
Absolutely.
Like going from, for example, client-side rendering to full stack should be an incremental migration. It shouldn't be, require a rewrite of the entire application.
Absolutely. The other thing is, of course, they want to stay low risk, and they want to as well have high ROI, ROI,
Return on
return on
investment.
investment, because there are certain parts of the application that are, of course, more mission critical, and that's also
Or more broken.
or more broken.
need immediate fixing. So the enterprises should be able to target, which parts of the application should be modernized and rebuilt, so that they get as much value or more value than rebuilding part of the application that doesn't matter as much. Additionally, when it comes to scaling, the problem space that we are narrowing down to is we realize that we need to prevent enterprises from doing mono releases, especially in the web front-end space. If you have a big monolithic application, you have lots of developers contributing to it, it can be very scary to push these big releases where something often breaks and then you need to roll back and have massive rollbacks. It's much better if we could enable enterprises to break up their big monolithic application into smaller chunks that can be independently developed and released.
And that's not only a technological decision, it's also an organizational decision. You have a broken up monolith, then you have independent teams, you have independent releases, and finally, you have...
Freedom sounds good, but it shouldn't be free for all. Like, you still want to have some governance and some oversight. You want to ensure that there are some security standards or some accessibility standards that are adhered to. So governance is a big part of the solution. So we looked at various things, consulted with various people in the industry, and what we realized is that wouldn't it be great if we could take a big enterprise application, identify a part, some module, some functional module that we could carve out, rebuild in an isolated way, deploy independently, rebuild it with possibly new architecture, new framework, full stack as opposed to client-side rendered, and then embed it back into the old legacy application, because we cannot rebuild everything at once, but we can rebuild one functional module. So as long as we can embed it back into the application, we have this cohesive user experience. User doesn't understand that now they're interacting with two applications rather than one. And developers can start iterating much more quickly on this newly rebuilt application. They can start shipping independently.
Actually, we can. We can.
Do you want to introduce the solution?
Yeah, there is this web standard technology, super battle tested. It's like, I don't know, 20 plus years old. I have no idea. iframes.
iframes, okay. How many people here like iframes? Okay, I see lots of, what's wrong with you people? Seriously, why would you like iframes?
Well, actually, iframes, Igor, they have some pros. They have some benefits.
Okay.
You can compose them back, or, I don't know, enable composability. You can encapsulate your JavaScript, your CSS. It gives you no lock-in, because it's a web standard.
Yeah.
And is the OG microfrontend tech for a decade or more.
Okay, I have to give you that. Those are like very nice properties, and I like a lot of them. But there are some drawbacks. Some of them are around design constraints. As soon as you start using iframes, you have this box within which you can render the new UI, but you cannot expand out of it. So if you want to do modal dialog or some full page overlay, you just can't. There are also usability issues. If you want to do navigation, for example, back button works in a weird way with iframes. Doing kind of window the location update within the iframe is not reflected in the address bar, so you cannot have bookmarkable URLs. All kinds of issues like
accessibility,
performance.
Have you ever tried to make an iframe responsive? Whoa.
Oh my gosh. let's not try. Okay, but what if there was a technology that had all of the benefits of iframes without all the drawbacks?
Okay. I have another suggestion.
So we have a thing that we would like to share with you today. We call it
web fragments.
We call it web fragments. Yeah. It's a very lightweight approach that combines many of the benefits of iframes without the drawbacks. And we'd like to show you what it looks like. So let's jump into a demo, because there's nothing better than just showing you the real code and how it works, and then we can discuss. What do we have here?
So here we have a monolithic React frontend. We have a catalog. We can navigate into each of the detail pages.
Okay, so this is an e-store.
Yeah, absolutely.
We
An
can
e-commerce
navigate,
store.
we can see different items for sale.
We can add them to the cart, and
Awesome.
yeah.
Can we buy some?
Yeah, we can buy some.
Oh, okay, cool. And just to simulate the enterprise experience, if you reload, we injected this like 2-second delay. You can imagine that this is where Google Tag Manager is downloading all the marketing scripts.
We were very
just
generous.
to make the user experience better. So it loads in not the fastest way, and it's kind of annoying that we have this monolithic application. It's mission critical. Imagine that it's much bigger, so we cannot rewrite it in one step. But what could we do?
Okay, so we thought about carving out pieces and
What can we carve out?
compose it. We can carve out the catalog, for example. It could be its own application. And this is what we have done. And this is built in Nuxt because we know there are many Vue people here, and we wanted you to be happy about it. Look.
Yeah, so we're using Nuxt. It's a full-stack Nuxt application with routing. You don't have to use Nuxt. You can use. We have versions of this application with Angular Analog, with Remix, with a whole bunch of other technologies. But we thought it would be cool to show off Nuxt. So standalone application developed with Nuxt, vanilla. There's nothing special about it, and it's deployed. Right now, it's running locally, but you can deploy it anywhere you want. Nothing special about it.
To an HTTPS endpoint. Right?
HTTPS, yeah, don't use HTTP.
No.
Yes, secure is good. Okay, but now we would like to bring it back to our original application because we don't want users to go here and to do what? This doesn't make sense, right? But we can take our original application, the shell that is client-side rendered, and we can bring our fragment back into it, just like you would with the iframe. But there are some significant differences. So in this case, you see this part of the screen rendered, and it's really this application, and it's actually served from this endpoint. All the HTTP requests eventually make it to this server, and that's what generates the HTML, serves all the assets. If you have data requests, they all go to this endpoint that is the Nuxt application.
So what happens is that Web Fragments has a middleware, what we call the fragment gateway, that intercepts all the requests that the shell application or legacy application is making and reroutes them to the right endpoint to fetch the assets, to fetch all that you need to compose this fragment.
And the reason for this gateway, why this middleware exists, and it's the only thing, one of two things you need to add to the legacy application is because we want the composed application to be a single origin application. We don't want to deal with coarse requests. We don't want to deal with additional domains and SSL handshakes and stuff like that. So everything is single origin. Everything hits the original application. The request is intercepted by the middleware, and the middleware then routes the request to either the legacy application or these new endpoints. In addition to the catalog, we also rewrote the shopping cart application, and that's additional fragment, as you can see. What does the DOM look like? Let me zoom in so that you can see. And if we go up, okay, we see that where there used to be two React components, now we have two, or we have three. We are going to talk about the third one in a bit.
Parties for later.
Parties for later. Let me just delete it. So we have two web fragment components. One is the store, one is the cart. And if we open them up, what we'll see is that there's a shadow root right under this component. Why do we use shadow root?
Well, because it allows us to encapsulate CSS, for example. Then we don't have to worry about our CSS and the CSS of the fragment interacting, colliding, etc.
Yeah. Keep in mind that these are like two applications. We have the React shell application that is the legacy shell, and Nuxt is bringing its own styles. We don't want them to collide. So shadow root allows us to isolate the styles so that we don't have any collisions. But CSS is not sufficient thing to worry about when it comes to collisions. We also need to worry about JavaScript.
And this is where iframes are helpful, right? If you scroll down a little bit, Igor, maybe?
Well, we can jump here. I think this is easier to see it. So if we look at the sources of this application, what we'll see is that we have the top frame that loads, and this is these are the scripts for the legacy React application. But then we have additional windows here. We have this catalog window that we can't really see on the page, but it's there, and it contains the next scripts, client-side scripts. And then we have this cart window that, if you look at it, actually contains quick JavaScript. So the interesting thing about it is that if we look at in console and explore what does the global look like, and we switch to this catalog window, then we see that it's a next application. It has its own global window. It has its own JavaScript context. But if we switch over to the cart context, I can explore what that looks like. There's no more next, but there's going to be some quick stuff in here. So in this page, we actually now have 3 frameworks running side by side. We have the legacy React application, we have the Next that is providing the catalog, and we have the quick application that is doing the cart.
And none of the frameworks know about the other, right? They are not interacting, they're not colliding,
but they can communicate.
They can communicate.
And to show that, you can hit an add button, and you see that there are items that have been added to the cart. The way this works is through events. There is a broadcast channel API that is a platform native API that is used for communication between fragments. So fragments still can communicate. They don't really know who's on the other side. They can send messages and respond to the messages. And that's how you can get fragments to collaborate.
So we describe one of the benefits of iframes, that we can encapsulate the JavaScript. There's another one. We spoke about
how long it takes to load the legacy application.
We spoke about that, but also about the restrictions of having a clipped.
Okay.
Can you go to the party now?
I can. I will have to reload this page. And one thing that you'll see, we'll get to it. Remember, the legacy application, this is the experience. It takes 2 seconds to load anything, and then the client-side render application actually starts showing the UI. With web fragments, this part is server-side rendered. It's next. Isn't it a shame that we would have to delay the server-side rendered UI until the client-side rendered legacy application is started? This is why we developed this feature we call piercing. Piercing allows you to combine the server-side response from a fragment with the legacy application in a way where you can actually show the fragment before the legacy application is started. And this is what the experience looks like. You reload the page, you see that the legacy application is starting, but the fragment is already loaded. That's because during the initial hard navigation, we're actually making 2 requests. We're making a request to the legacy application and to the fragment, combining those responses. We show the fragment as soon as we can, and the legacy application is bootstrapping in the meantime.
Yeah, we show, and it's interactive. It's fully interactive even before the shell application is loaded.
In this case, yeah. We haven't polished this application as much as we should have. Ideally, you would have a skeleton shell around, and I'll show you a production version of this, what it looks like in production in a bit. But yeah, you can now get not only developer experience benefits of being able to build these fragments much more quickly and independently, but also user benefits, because you can show the most valuable content very early. So if you are hunting for improved large contentful paint, you can use web fragments and this piercing technology to actually get the largest content paint very quickly, even in a big, massive legacy application.
So the party button.
Okay.
We mentioned the constraints of iframes in terms of clipping, right? If you have a box and you have the iframe there, nothing can overflow it, let's say. But that's not the case with web fragments.
So we built this component. It's just HTML button. It loads some third-party JavaScripts that renders this funfetti. And it's deployed at some independent HTTP endpoint. Now, This is not just a component. It's a component as a service. You can actually take this endpoint, and using web fragments, you can embed it back into the application. So just like we had, I showed you that we had the 2 fragments before, there is a third fragment right here, party button. And when you click it, you see Funfetti scrolling all across the page. Now, this Funfetti is being rendered through Canvas, and it's doing like web worker, and it's not like a trivial thing. But in addition, not being a trivial thing, the interesting thing is that it has access to the full viewport. So if you want to render special effects or model dialogues or full page overlays, you can do that, even though your application is decoupled.
But there's something else.
Okay.
Can you kill the party? Can you just delete it and remove it from the DOM? I think that this is one great advantage of web fragments also. If you remove a fragment at any point in time in the life cycle of the application, it's gone and the memory is released. The memory leaks or potential memory leaks you may have are released, and you have no consequences.
So this can help you visualize it better. So with the console, I can see that I can switch over to the context of the card because it's here. This is where the JavaScript context of the entire card is. If I delete the button, the context is gone. And with that, all of the memory that was consumed by the card, any kind of code that was loaded, typically it's impossible to unload code in the browser. But with fragments, we can unload code. So if you have a massive application, an enterprise application, where users have long-running sessions where the tab is open for weeks, and you download megabytes of JavaScript, eventually the tab will crash because you will just keep on downloading more and more code until the tab crashes. But if you can unload code, you can actually manage memory much better.
All right. So let's recap very quickly, because that was a lot of information.
I'm dropping the link to GitHub so you can explore the application on your own time. But yeah, let's recap.
So we have explored the benefits of shared capabilities and isolated JavaScript, CSS. But the most important, we can share the origin, the DOM, the browser location and history, the viewport sizing, and yeah, even the event loop is shared.
But at the same time, the important things that we want to isolate in these scenarios, we can isolate, whether it's CSS, whether it's JavaScript, ES module registry, all of that stuff can be completely isolated. How do you get started with web fragments? Is it hard?
No, you install web fragment, then, well, actually, you build and deploy your new application that you have identified, and then
you add the fragment gateway,
yeah,
which is just a middleware. We have a Node version and also web-compatible version. So if you're using Web Standard Request Response on your platform, you can use that. If you're using Express or Connect, you can use that as well. You register your fragments with the gateway, and then in your legacy application, you start deleting parts of the application and replacing them with this web fragment tags. And that's where the new parts will be.
Yeah, but the most important is that to build that fragment, you use whatever you want, you build it with whatever you want, deploy it wherever you want, and redeploy at your own pace and schedule, and it's going to work.
Really, it's, as I said, component as a service, that's a good mental model to think about it. Instead of publishing libraries, you're publishing an endpoint that can serve UI. And it's not just the HTML, it's the data, it's the CSS, all of that stuff. There are only 2 hard requirements. You need to namespace all of your static assets to avoid collisions, and you must trust the code. This is just like module federation or other microfrontend approaches, where there's the implicit trust that the code that you're loading from these different endpoints will be trusted. What is the current status? We've been working on web fragments. So research has been going on for on and off for a few years, but really it's been in production at Cloudflare since September. I can actually quickly show you.
Yeah, show them that because it's very impressive. This is in production today. So
at Cloudflare, we have Cloudflare Dashboard, which is the interface through all of our customers interact with our services. It's an old legacy React application, massive. The entire company contributes to it. A lot of technical debt, client-side rendered, very bad user experience, but it's also mission critical. We cannot rewrite it in one go. So that's why we're identifying pieces of this dash and rewriting them. So in this case, there are these user preferences. This is the old UI. If I reload it, this is the experience you get today. We rebuilt this component with like all of the model dialogues and everything you need to control the profile. And then here is the version that is rebuilt. If I reload, you'll see that we're actually able to show the user preferences very quickly while the legacy application is starting. I have very good internet here, so actually it's not as painful as it normally is. But notice, again, we have model dialogues that have full control of the viewport, and you have full flexibility. Now we can redeploy this application whenever we want to. We can use whatever stack. We're using React Router and Quick for different fragments in production, and we're just super excited about how well this is working for us.
So we are over time, but quickly, we are open source. You can join us. Our roadmap looks something like this. Short term, we're going to be improving web fragment communication, client-side dependency sharing between fragments. And long term, one important improvement is we're going to be replacing parts of web fragments with actual web standards that are, even one was integrated yesterday.
Yeah, a few days ago, atomic DOM move operations were made part of the HTML standard. So web fragments is 3,000 lines of code. It's very lightweight, but we're hoping to cut back on the code even more and really just use more and more of the platform as these new standards are landing. So with that, we want to thank you so much for your attention. We hope that web fragments can help you modernize and scale front ends.
The next slide. Thank you very much. Gracias. Let's keep pushing the web forward. Huh?
Yep.
Thank you.
Thank you so much.
Awesome, 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 awesome. That was such a cool talk. Well, the topic of microfrontends is very interesting. Good job, guys. I heard there was a very interesting talk yesterday as well about microfrontends. Some guy talked about Vue and Nox with microfrontends, but not as good as this talk. Thank you for dipping your toes into stages of microfrontend, pun intended. Before calling up the next speaker, I have some interesting stuff to share, which is about lunch. I heard today for lunch there is going to be a lot of cool stuff, a lot of delicious food. That's what I talked about in the morning. We will have falafel, there is Indian curry, there is banh mi, and something else I'm forgetting, I think. There was a fourth one. Maybe it's a surprise one. Pasta! Thank you, Nikki. There is also going to be pasta. There is going to be a lot of food. That's why I'm saying this. There is going to be enough for everyone. So stick around for Daniel's talk. Afterwards, we can all go together for lunch. There is a lot of food backstage or outside. Having said that, our next speaker is Daniel. He is the president of ECMA International, and he has such a cool talk ready. Please, Daniel, welcome.
Hi, everybody. Great to be here. So to introduce myself, I'm Daniel, or I go by Little Dan on the internet. I'm a developer at Bloomberg, working on the JavaScript infrastructure and tools team. So I've been involved in TC39 since 2016, or maybe it was 2015, working on features like BigInt, where you can have arbitrary size integers, hash private, where you can have elements in a class that aren't visible externally, and a bunch of other things. ECMA is an organization that helps standardize many things, including JavaScript, and I'm president in the sense of just helping with some of the administrative stuff. Bloomberg Terminal is what I work on. It's a piece of software. It's like a desktop program that runs Chromium inside, so it's kind of like Electron, but our own version of it. And so it's all based on web technologies, and it's used to help financial professionals understand markets, do trading, various different kinds of information. So we use UI frameworks like everybody else, like Vue or React, or actually several of them are in use. And what's the purpose of these UI frameworks? It's to change the model from the old thing of PHP plus jQuery, where you initially render your application, and then later maybe you make fix-ups to it, and those are separate pieces of code. The new way is that you have a same template for initial and subsequent renders. And instead of having the data and then applying fix-ups, you have centralized data with one-way data flow, ideally with state management, at least for bigger applications. And that helps make your applications more declarative and consistent. So to give an example from Vue, if you have a simple counter, then you can store the state in the DOM, like here. You can make a button, and the text content just is the value. The code is a little bit longer, and it adds a dependency on Vue on the right, when you instead say there's a separate ref, and then, sorry, there's a separate ref where you hold the data, you have a template that refers to that, and then when you click the button, it just increments the ref. Then the framework in the background keeps that consistent and updates the screen. So in simple cases, it doesn't really save code, but it really helps you scale up to more complicated applications where you are using the state in multiple ways. Maybe you log it when it changes, maybe you save it to the server. Putting all that in the event handler becomes really unwieldy. And that's why most of us migrated away from jQuery and towards React or Vue or similar things. So the key job of UI frameworks is to keep the DOM up to date with the data. Or in other words, you could say the view is a pure function of the model, to use terms that maybe people find outdated. Model view controller. It's still the same concepts, except the controller is now lowered into the framework. The framework kind of handles that, keeping them in sync with each other. So what's interesting is that several different frameworks going at this same goal, but from different angles, arrived at what I would call, or what Solid has kind of inspired people to call signals. Kind of first-class cells that help efficiently recalculate only what's needed. So fine-grained reactivity. And even though React has a different programming model and not using signals, it's still going for this one-way data flow, Vue being a function of the model thing. So I think of it as just different algorithms for the same thing. Here's an analogy from game development, using some also old terms. Immediate mode is when on every frame you recalculate all the pixels, you send it to the screen, and that can be an easier way to program. Retained mode is more efficient maybe, where you figure out only which parts really need to change and then modify those in place. So the goal for signal-based reactivity is to get immediate mode behavior with retained mode performance. So the programming model, you describe how the model is converted into the view, but the execution model, you only update what's needed, and you only even recalculate what's needed, and only do that, in that case where it's used. So signals represent a cell of data that could change over time. They represent kind of a current value. There are two basic kinds of signals, which in the proposed standard we call state and computed signals. We were just trying to go for what's the rough consensus among usages. So in a state signal, you can create it, initialize with a value, and you can get or set it. And a computed signal is derived from others. It's just a calculation that could be rerun. So this is a cache. It can be considered like use memo. So what's interesting is that although these frameworks started from various different approaches to reactivity, the behavior has been converging to something common. One feature is auto-tracking. When you have a computed signal, it automatically subscribes to the things that it accesses in the course of its execution. That way, you only have to recalculate it when one of the things that it uses changes. Another feature is lazy evaluation. Computed signals are only accessed when they're read. So not eagerly when a dependency is updated, but only when they're actually used. And these together with the use of pure functions, provides from-scratch consistency. That's kind of a technical term, meaning you get the same result as if you were to recalculate it from the beginning. So even though you're only trying to do the incremental calculations, you're still kind of logically starting from the beginning, assuming that your functions are pure. So when people hear about signals, the first thing that people, with me working on the signal proposal for TC39, a lot of people have gotten excited about implementing signals. And so the first thing people will do when they think about how to implement a computed signal and effects is say, when you change the state, then go notify the computeds, recalculate them, notify any effects that reaches. But this algorithm in its naive form is actually buggy. So in this example, where we have these A, B, and C nodes, B and C are two different computed signals. This is called a diamond dependency graph. So when you change A, if we were going to just do a depth-first search to A, to B, to the effect, then the effect would initially see B being 12 after we set, sorry, this should say seconds.set 6. After we set seconds to 6, B would become 12, and then C would say 10. Then the effect would run. Then we would rerun with C, and then it would become true again. So you're with this naive algorithm where you just push through to reevaluate, you get the wrong results. To solve the glitch problem, again, seconds.set should be 6 here rather than 1. You want to do what's called a topological sort. You want to only run things once all the things they depend on have actually been updated already. So you could run A, then B, then C, and only run the effect after they've both run. So this only logs true, the effect only runs once. There are a few different algorithms to solve this. Different kinds of data structures. The first thing you have to do, because this is fine-grained reactivity, and we're not rerunning the whole graph, only the parts that change, is to figure out which parts actually change. So one algorithm for this is sometimes referred to as the push-pull algorithm, where initially we have this graph on the left. When we set A to 6, which is what the earlier slide should have said, then we immediately mark the nodes that are directly dependent on it as they must recalculate. And we also recursively push forward to the subsequent nodes to mark them as they may need to recalculate. It's may because with these computed signals, if they end up evaluating to the same value as they were before, even if their inputs were different, then we actually don't want to run the subsequent nodes. We only run the subsequent nodes if one of their dependencies actually changed. And at that point, we can recolor it from yellow to red. So, we only are able to run the things once their dependencies are all kind of white, once they're reset, and then after running, it becomes updated. Another algorithm is based on version numbers, or you could call this generation numbers, where you have a global clock, and whenever updating a state, you increment that clock. And then dependencies can notice what's dirty based on that. So in this example, with the version number after the colon, when you read the effect, so the system will kind of schedule pulling the value of the effect to recalculate it, to rerun it. So when you do that, you recurse all the way to the root, and you see, oh, this number 1 is higher than 0. So I will, rerun the things along the path that were outdated, like these intermediate nodes B and C, and then those can be updated. So there are multiple algorithms, but they have the same observable behavior. Observable is this semi-technical word that we use sometimes in programming languages to mean, any program that you run from the outside against these algorithms will get the same result. You won't be able to notice any difference. So I think of this convergent evolution as kind of like carnicization, where apparently lots of different types of crustaceans that were from different parts of the family tree convergently evolved to all be pretty similar to each other. If you look at the history of the different frameworks, it's not like just one of them had the bright innovation and everybody copied it. They each noticed actual bugs, these kinds of glitches and similar problems in real programs, and in debugging them, arrived at this kind of consistent goal. I mean, there has been cross-pollination, but there's also been real discovery of the same issues. So I mentioned that I work at Bloomberg. Why am I talking about signals? Because it's not like I'm going to sell you a signal. The Bloomberg terminal's built on standards. I mentioned that it's sort of like a big Electron app. It's built on web standards, but also through various different parts of the stack. For example, for supply chain security, we use OWASP CycloneDX SBOMs, which are just a way of representing the various components of software that are put together into the package. So we can invent our own technologies for these things, or we can adopt, and we have adopted frameworks that have technologies, but we really want a unifying standard that will make sure that the technology is long-lived. It would be a shame if everything is rewritten in some framework and then it becomes outdated. I think frameworks are long-lived, but overall, when you have big applications, you end up having multiple of them. Having a common thing that everybody can use, and everyone standard for this is really, really advantageous. So that's why we work together in ECMA and TC39. So ECMA being the broader committee, the broader standards development organization with several different things, including, for example, CycloneDX. That's also an ECMA standard, ECMA 425 now, developed in TC54. We made a new technical committee for that alongside TC39. And of course, we're also developing JavaScript in TC39, as Ujwal explained earlier today. So in April 2024, with some colleagues from working on other frameworks, after 6 months of development, we presented at TC39 a signals proposal, and it reached stage 1, meaning that the committee agrees that this is something for us to investigate and collectively look into. TC39 has not agreed that we should do this, but we agreed to consider it. There's an interesting problem there. So as part of this, we developed an implementation of this proposed API in JavaScript. Actually, it was just based on the Angular signals, and my coworkers at Bloomberg and I put kind of a shell around it that looked like this common interface. So from here, something that's very useful is to try out signals in development branches to see whether it works. We're staying at stage 1 for a long time as we continue to develop it, because we really want to prove out that this works. So in particular, signals in this sense should be possible for all the other frameworks to build on top of. And so you can use this via NPM. I don't recommend it for production. You'll see it's very slow, and so the hope is that standard signals mean that we can share code across frameworks. So for example, we could factor out our model into a separate module, this counter, and then we can create that and refer to it in the template, including the update operations. So this can help us with kind of model view separation or state management. The ideal would be that we can actually use the same model in different frameworks. So for example, if we were going to embed it in React, it could look the same, assuming that both integrate with the same signal system. What that means is that they have to understand that when one of these signals gets changed or becomes dirty, that it must recalculate, then the framework has to remember to query that and put it through. But ultimately, with standard signals, if the project works, applications should not need changes to adopt them. So there's the empty set symbol on the slide. Existing framework APIs would use signals. So for example, vue refs could be implemented in terms of signals. And in fact, Evan Yu has done this in a branch. So he's been involved in discussions, and for an earlier version, he has implemented this, at least for the purposes of a demo. It's not like rebased. So I think there's more work to be done to see whether signals would work for Vue, but that's really my hope, that we can demonstrate it this way. But as I mentioned, the signal polyfill is very slow. So I was very happy to see that Alien Signals the author, Johnson, has created a new version of the signals, proposed standard interface on top of Alien Signals. So Alien Signals uses this push-pull algorithm and combines a number of very good algorithmic choices to efficiently implement the signal algorithm. And we can see here that the Alien Signals being used to build the TC39 interface is much faster. Still, it's slower in a bunch of cases. So this points to work that we still have to do, because it's not acceptable for it to have a regression just because we're using this interface. So we'll need to investigate that some more. But this is still in advance to allowing prototyping. So we still have a lot of work to do. Can we use this in practice? Can we port existing libraries? Approaches to async are also very important, improving tests and documentation. So yeah, as a crab, I'm kind of feel cooked into a curry here. There's just a lot to do, and we've been going a little bit slowly, a little bit cautiously, and we could really use your help if you want to participate in the Signal project. So we have chat rooms, bug trackers, experimental integrations would be really useful. It's also possible to join ECMA and join TC39. So that's done typically on a company or organization basis, but also individuals can join as invited experts. So I'll be really interested in your feedback and issues. So please come talk to me if you want to get involved. So here's my contact information. And just, by the way, Bloomberg is hiring, so please check out the website if you're interested. Yeah, thank you, everybody. Oops.
That was so good. Thank you, Dan. Ready for lunch? Yeah? Awesome. So in a moment, we can go for lunch. Just please make sure that you're back in about, around 2, I think, is the time. Well, you hear the bells going on. Around 2, we'll be back. Enjoy your lunch.
Welcome back, everyone. Welcome
Thank
back.
you.
For those of you who are joining right now, I'm Elena, one of your MCs for the day, and this is
Reza. Yes, I'm the other MC. I'll be here part of the afternoon, and then Elena covers the rest for me, or for us, for you.
So I hope you had an amazing lunch, and we be ready because we have another great speaker for today.
Yeah, so the next speaker needs no introduction. He's the founder of Void0, the creator of Vite and Vue. But
You all know him.
Yeah, the one and only, exactly. I have a fun fact.
Oh, really?
So the next speaker is the creator of Vue, right?
Yes.
The good thing is, Vue is so easy, even you can do it. Thank you. Now, the joke is not mine. Yes, the joke is reused from the years before. But anyway, should we call him on the stage together?
Yes.
Yeah?
Let's go for Evan together, guys.
Evan, 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 Evan.
Okay, hello everyone. So we've been having some Vue talks in the past 2 days, but today I assume not everyone uses Vue. But can I get a raise of hands how many of you used Vite in some way? Okay, great. A lot of you, that's awesome. So today's the topic is front-end tooling in general, past and future. But for those of you who don't know that much about me, I taught myself JavaScript like 15 years ago when I was in grad school. My first programming language was ActionScript because I grew up playing around with Flash. And I only properly started to learn JavaScript in 2010 because at that time, we were working on some interactive projects in school projects, and some of those were using processing, some of those were using C++. And you have to compile and distribute these things as actual files. And I found that so annoying until I discovered I can actually do all of these things directly in the browser with JavaScript. And I can just ship a URL, and anyone can see it. So that's how I got into front-end development and started teaching myself JavaScript. So over time, I worked at different companies, and then I became a full-time independent open source developer in 2016. I created Vue in 2014 when I was still at Google, actually, as a side project. Kept working on it as a side project, doing some other work, and eventually decided to do it full-time. So the point of all this, I guess, the point of all this is I essentially started learning JavaScript shortly after Node.js was created in 2009. And I think that was also pretty much the beginning of what we, in general, define as front-end tooling, right? Because if we think about the really, really old days, like, how many of you started working in the front-end space before 2009? A few of you. So for those of you who started after that, you probably already got exposed to tooling in one way or another. But before that, there wasn't really any great tooling per se. jQuery and a script tag is really all you need. And we would manually put multiple script tags in the HTML file and just hope they work together, sharing the same global namespace. And the build that we called back then is really just concatenating a bunch of JavaScript files. So to prevent, say, variables defined in one file leaking into another, you have to wrap everything with this like function wrapper, what we call the immediately invoked function expression, short for IIFE. And if you omit this semicolon at the beginning here, because sometimes people omit semicolon here, and you concatenate everything together, it just blows up because two files concatenated this way would be considered you're trying to call this whole thing as a function using the next file. So those were the fun days. Oftentimes you have to like manually concatenate things, debug these weird problems. And then in 2009, Node.js unlocked JS developers' ability to write their own tools, right? So before that, JavaScript was really this scripting language in the browser. No one treated it as a serious engineering language. But with Node.js, people realize, OK, like I can actually write something in JavaScript and run it through the command line. And now I can use it to solve my own problems. So you see a lot of these tools like that you probably have remote memories of were created in around that period. Like Sass was written in Ruby, which is why it appeared before 2009. But after 2009, we saw less CoffeeScript. Closure compiler is not written in JavaScript. It's actually written in Java. But then there's Stylus, Uclify.js, PostCSS, right? So the fact that people are starting to write these tools for themselves with the goal of better development experience, right? So CoffeeScript was trying to address the syntax preference. Some developers liked Ruby over JavaScript, so they created CoffeeScript. And there are different CSS preprocessors. There are tools that minifies your JavaScript. There are tools that transforms your CSS. And then with React coming onto the scene in 2013, it actually required you to use the build step because it uses JSX. So you'd always have to first transform JSX into something the browser can understand, which means practically the whole code base, everything in your code base, will now need to go through a build step in some way, right? So that gives rise to the need to coordinate these different tasks. We suddenly realize, OK, when you're working in the front end, you can no longer just YOLO with JavaScript CSS files, upload to through FTP, and call it a day. Now you have to think about, how do I, say, convert my Jade template, Mustache template, Handlebars template into HTML? How do I transpile my CoffeeScript into JavaScript? How do I concatenate them, combine them, and maybe minify them for better performance? How do I pre-process my CSS files and optimize my images? So people started writing custom scripts. Again, thanks to Node.js, you can now write your own scripts to automate these things, right? So before that, you probably people actually built like GUI tools that allows you to like manage these tasks. But I guess developers just prefer to have things more in their own control, so they started coming up with task runners like Grunt, Gulp, right? How many of you have used these things? A lot of you, great. How many of you still use it today? No, really? I don't believe you. Yeah, so this is like how a grunt file looked like. So you kind of like scripting NPM scripts almost. Like it just allows you to express things in JavaScript a bit more. And then there's like, oh wait, this is actually a gulp file. I forgot to edit this. So gulp actually is interesting because it allows you to define tasks as sort of a pipe. Like you take some input and then pipe it through a tool like Babel, and then you put it into some destination. But the problem with this approach is that it did not handle modularization, right? When people are building bigger and bigger apps with JavaScript, we realize, OK, you can no longer just put your JavaScript in this like 10,000 lines file. It just doesn't scale. We got to break them into modules. But before ES 2015, there were no standard for JavaScript modules. So people came up with their own definitions. Node.js was using something called CommonJS, right? And there's also a competing proposal called AMD, Asynchronous Module Definition. And there was a tool called reactjs that actually is able to load modules defined as AMD at runtime, almost like an unbundled development that Vue is doing now in some way. And there are plugins that allows you to like transpile things on the fly, which and then it had a like production-oriented optimizer that is able to actually bundle and concatenate all those things. So pretty ahead of its time, I would say. And then there's CommonJS. Based around CommonJS, people were writing code for Node.js, and someone was like, I want to also run this code in the browser. Right? So, but Node.js was using CommonJS, so you need a way to essentially combine all these CommonJS modules into something that can run in the browser, and that was Browserify. And that's kind of like the first bundler that we had for JavaScript. And with 2015, ES 2015, things started to accelerate even more because ES 2015 was probably the addition of ECMAScript that shipped the biggest chunk of improvements to JavaScript ever, right? But with all these new syntax and new language features, not every browser was ready to support it yet, but developers want to use it as soon as possible. So people start writing transpilers, things that convert future syntax of JavaScript into something that can run in browsers today. How many of you remember that Babel actually started as a project named 625? Yeah? So it was called 625 when it was first created, and then shortly afterwards it was renamed to Babel, and really allowed people to start using future syntax today. But again, this further normalized requiring a build step in order to ship anything, right? And with ES 2015, we also finally have a module definition that is part of the language standard, the ES module standard. So then rollup was created because the bundlers back then, Browserify and Webpack, in the beginning, in the early days, they were both CommonJS centric. The main purpose is to take a bunch of CommonJS modules and combine them. But rollup was the first one that was ESM first. It only supported ESM out of the box, and you actually need to use a plugin to support CommonJS. So with the need of modularization, we see different bundlers appearing to sort of handle this need, right? So there's Browserify, there's Webpack, there's rollup, there's Parcel, and quickly we realize, okay, like bundlers are not only useful for combining files, because when you're combining these files, you also have the opportunity to transform them, right? So how about plugins, right? So we realize, okay, we can actually register a plugin in the bundler, and when the bundler is, before they combine these files, they can apply the plugins to each file to transform them, right? So you can essentially apply Babel transformations to your files before you before the bundler actually combines them into the final bundle. So we realize this also is more ergonomic compared to a task runner-based mental model like Grunt and Gulp. So very quickly, the community shifted towards just everything as a bundler plugin, right? So we have tens of thousands of different like Webpack loaders, or probably not many of you have written Browserify plugins, but when I worked on Vue, the first version of Vue single file components was implemented as a Browserify plugin. We only implemented a Webpack loader version later on. So quickly we shifted towards this bundler-centric sort of tooling structure. Like everyone kind of just started using Webpack in a way, right? But then we realized a problem. Bundling a lot of modules can be slow. Let's say you start with just one module, it's relatively fast, but you don't want to keep rebundling the whole thing every time you change a single file, right? We want incremental builds. But even better, like what if when we're working on a web page, we can only reload the part that actually changed without reloading the rest of the page? That's hot module replacement, right? The concept that's pioneered by Webpack, and everyone today kind of almost take it for granted if you're doing web dev, right? There are actually quite a few, UI development paradigms like in the native world where they don't have hot module replacement, and it's really, really painful to work in once you get used to HMR, right? And then there's this whole world of assertion libraries and test runners. We have like Jasmine, Chai, Tape, Mocha, Ava, Jest. And we have linting and static analysis. JS Linked, surprisingly, was created in 2002. It was created by Douglas Crockford, and it was really, really opinionated. So JS Hint was created in 2011, which was basically a configurable JS Linked. And then there's ES Linked, which is now the standard that almost everyone uses. So the whole point of going through all of this history is to kind of help us provide a context, like why did we arrive at what we have today? Like, right? Because we, as JavaScript developers, are putting JavaScript up to tasks that it was not originally designed for, really, right? It's a language that was created in 10 days. It was meant to be a scripting language in the browser, but today it's the biggest language that we use for application development. So because of that mismatch, right, all of this engineering requirements for a serious application programming language was not part of the design goal of the original language. And we, the community, kind of had to just invent things, create things to solve those problems for ourselves. And there's no central guidance, right? There's TC39, but it's only about the language. It's not about how you handle, say, how do you transpile files for those future things. So this kind of community-driven development is, I would say it's a blessing, and it's also a curse, right? The blessing is anyone can just step up and create something cool, share with the community, and there's a good chance it can become a community standard, right? We've converged on a lot of things that's just created by someone who was trying to solve their own problems. The downside of this is all of these different solutions were created without a central sort of thing to say, let's make sure we use the same AST format, for example. Let's use the same parser, right? Let's make it reusable, or let's share the same configuration. No, like a lot of these tools were created by individuals without being aware of other people working in a different problem domain. So that's a problem. That leads to incompatibilities, that leads to duplicate configurations, that leads to all the time you have probably spent on figuring out why tool A doesn't work with tool B. Or when you're trying to upgrade one tool, you realize, okay, it breaks the other one. So this is happening a lot, right? So at one point in time, we kind of converged on something. I think at one point in time, most of the mainstream CLIs or wrappers or frameworks were using this combination: Webpack, Babel, Jest, ESLint, right? So when we did Vue CLI, can't remember the exact year we did it, but Vue CLI was essentially a wrapper around Webpack, right? So it's a very complicated Webpack wrapper. We actually had an abstraction on top of it called, we used a library called Webpack Chain. So every plugin in the Vue CLI system would hook into the main Webpack config and modify it, mutate it a little bit. And then we used provided plugins allow you to hook the whole system into test runners or linters and things like that. And then let's create React app, right? It was kind of the default standard for people getting into React for a very long time until its recent deprecation. It's also based on Webpack, ESLint, Jest, Next.js, Webpack, Babel, ESLint, right? Obviously, they've been working on trying to convert internal things to Rust, but in the initial version of it was including the initial version of Nuxt. Like all of these things, meta frameworks or like CLI wrappers, they're just wrappers of these lower level things. So we kind of have a convergence, but is it really, right? So if we look at this stack, and I've looked at every single one of them and look at their dependencies too. So Webpack uses a parser called Acorn. Babel has its own parser, which is, I believe, is a forked version of Acorn, but slightly different. It's now called Babel parser. Jest by default, I don't think it uses a parser. But the way Jest handles things is it runs everything in Node.js as CommonJS by default. So ES modules to it is kind of like a foreign concept. You have to like transpile ES module to CommonJS to make it runnable in Jest. And then ESLint has its own parser called ESPre, which I think is a next iteration of ESPrima, which is an even older parser. So like I said, like it's a standardized stack for a very long time. But internally, these tools were using different parsers, different AST formats. Like Jest had different opinions on how to handle module resolution, or how do you register plugins to transpile files. And Webpack had its own way of doing things. And then you need to make Babel work with both Webpack and Jest, which is why you see, like, when you think about, like, you're just starting a simple create React app, why does it download so many dependencies? And where does all the complexity come from? It really comes from this sort of, the root cause is these tools were created without awareness of one another. And now we're just trying to glue it together to make them work. So I was more or less frustrated with this. to be honest, right? I worked on Vue CLI myself. And at one point, I think one day I was creating a Vue CLI app myself, and it took like 5 minutes to do the npm install. I was really frustrated. I just want something that's really quick, that allow me to spin up something instantly. So I started experimenting with the idea of a non-bundled dev server. It was originally only designed for Vue, but in February 2021, I got it to a point where I realized, OK, this thing is really good, and it doesn't have to be Vue only. I can actually make it work for React too. So I quickly tried to make React hot module replacement work with Vite, and it worked perfectly. So we decided to make it framework agnostic. And that kind of started this very rapid process of meta frameworks deciding to use Vite as the foundation. There's also this very obvious trend of people getting tired of creating React app, and they just prefer Vite as the starting point for their new React apps, which I really didn't expect to happen. So in 2022, we had like different new frameworks, Nux 3, SvelteKit, Astro, all built on top of Vite. And in 2023, we had a Remix, which is the second largest React meta framework migrated over to Vite. And then now we have JAMstack Start, we have One, we have Ember, which is a really, really old framework, also moved over to Vite. Quite amazing. And in the recent deprecation of Create React app, we're seeing a lot of users actually advocating to just let the documentation point to Vite as the replacement for CRA. So, and we have crossed like 22 million weekly NPM downloads. And in State of JS 2024 survey, we're getting really, really overwhelmingly positive feedback from the users. So all of this is not really what I'm trying to do is not bragging about like how good Vite is. But the point is, we're seeing a trend that like from this pre-gen sort of status quo, which is Webpack, ESLint, Jest, and all that, people are looking at Vite as the sort of this new default, and a lot of people really liking it. So we're seeing this vast ecosystem, fast growth, and a lot of companies actually using Vite in production as well. The ChatGPT web client actually migrated from Next.js to Remix, and we have big companies migrating their big internal Webpack applications over to Vite, like Shopify, Reddit. And then there are newer companies started using Vite, for example, Linear started using Vite during Vite's own beta stage, and essentially grew the product in the company alongside with Vite. So at this point, it is, to some extent, I think Vite has become a shared infrastructure layer for the next generation web applications, right? Sadly, we have one part of the ecosystem, Next.js, which is not on board the hype train, but almost everything else is now on Vite. But I would be the first one to admit that Vite is not perfect, right? So there are problems internally that we're still working on. So despite Vite providing you a very streamlined out-of-the-box experience, right, internally it still uses a bunch of third-party dependencies to handle these difficult things, like how do we bundle things extremely fast? How do we transform TypeScript, JSX? You know, how do we, for example, do the target lowering syntax transforms that Babel was created to solve? And then, so we actually rely on multiple different things. We rely on ESBuild, we rely on Rollup, and some React users, when they use Vite, they also use SWC through a plugin. And ironically, these three dependencies are all written in different languages. ESBuild is written in Go, Rollup is written in JS, and SWC is written in Rust. So the problem with this architecture, again, it's very similar to the problem when we put together different tools that were not created in awareness of one another, right? ESBuild were used for certain characteristics. For example, it's extremely fast, right? And it has a very rich feature set, but it just lacks certain things that you want if you're bundling an application for production. It doesn't give you the fine-grained chunk control. It would sometimes split out really many, many small chunks, and there's no way for you to kind of change that behavior. And its plugin ecosystem is relatively small, and the plugging mechanism is less flexible compared to rollups. It also doesn't have hot module replacement. And then we have rollup. Rollup is a very mature and great bundler, and we actually rely heavily on rollup's plugging ecosystem. But the downside is it's written in JavaScript. It's really, really slow compared to ESBuild, right? Like, in terms of JavaScript bundler performance, rollup is actually great. But when we compare it to something written in Go or Rust, it just starts to fall short. And then there's SWC, which it's really, really heavy. It has a really heavy boundary, almost 40 megabytes. That's like twice the size of Vite plus ESBuild together. And originally, the scope of SWC included bundler, but it ended up not completing it. So sadly, each of these tools, these are great tools. They are created to solve very specific problems. And some of the problems they solve really, really well, which is why we use them in Vite. Sadly, none of them actually covers all the things we need. They have overlapping duties, but like they all each have some shortcomings that we just have no control over. And we can't some of them are really hard to fix. For example, it's very impractical to say incrementally port rollup to native to make it faster. Actually, the current maintainer of rollup have tried to move the parser to Rust, but that did not really show significant gains. Right? You kind of have to rethink the problem from the ground up. And then there's the consistency problem. Like, there are subtle consistencies on how rollup and ESBuild decide to handle things like ESM and CJS interop. And finally, the pipeline inefficiency. So when we have all these different dependencies, you're building an app with Vite, your source code, the same source code, actually gets parsed, transformed, and generated as strings and then passed between native and JS engines back and forth multiple times. ESBuild does it in Go, right? Rollup does it in Node.js main thread, SWC does it in Rust. So a lot of computing just wasted on this repeated parse, cogen, and then passing the data around. And finally, Vite itself, the unbundled development model, it was really, really nice to be able to leverage something that's native in the browser. And it felt like it was going to be the future, right? Unfortunately, we noticed that when you have a really, really huge app, like thousands of modules loaded up front, the browser network layer actually becomes the bottleneck. And that's something that Vite itself really has little control over. Again, like, we can't really change that behavior. So we're forced to kind of look for a way to maybe go full bundle again. So our conclusion is, okay, like, we need to build our own bundler that's just designed for Vite. Like, we want to cover all the things Vite needs in one single tool and avoid all of the problem that we mentioned before. So we started working on something called Rowdown. Rowdown is a Rust-based bundler. It's written in Rust. It has a rollup-compatible API, and it has a feature scope that's similar to ESBuild. And it's already in beta and usable. But as we were working on Rowdown, we started thinking a bit deeper, because the bundler is also kind of like sits in between, say, the build tool and the lower level pieces. Inside the bundler, we still need the parser, we still need the transformer. Like, we have a lot of built-in features like minification, so we need a minifier. A lot of these things also share the same sort of, we need the consistent AST format, for example. So what parser do we use, right? That's another question. And then we looked deeper and we realized, okay, like, even all the way down, if we keep using third-party dependencies, we'll keep running into the same problem, because the JS ecosystem was built from the ground up by different people. So this fragmentation is like so deeply rooted in the entire ecosystem. And if you really want to unify everything, you kind of have to just rebuild everything from the ground up. And that's a very, very ambitious thing to do, right? But it's the challenge we're facing. So there are companies that have attempted this before, right? Actually, Biome is the result of the company called Rome that tried to tackle this. And most people would think, okay, like, it's a lost cause. Like, it's too hard. Why would you even try to do that? Well, like, if we don't address this problem, we'll be essentially troubled by these problems forever. So there's got to be someone I personally have always hoped that someone would step up and try to actually build something like that. So I was quite excited when Rome decided to do that. But unfortunately, that didn't pan out. And we are kind of realizing, like, oh, in the process of trying to fix the problems Vite is facing, we're like going deeper down in the rabbit hole and realize, okay, like maybe it's time to actually seriously challenge the status quo and try to build something that can unify all these things. Okay, so, but why now, right? My conclusion is that in order to build something that unifies a very fragmented ecosystem, you need consensus. You need momentum, people agreeing on a certain thing that this is the way to go. And Vite actually gives us that leverage. Vite is showing a level of convergence that I've personally never seen before in the JS ecosystem. I myself am very surprised that Vite is able to get where it is today in a short span of 5 years. So I think it's about time. So this is why I started the company called vuejs to essentially make this a more serious effort. My realization is I've been working independently in open source on a volunteer and sponsor-based model for a very long time. And we were able to achieve some amazing things. I think it's kind of a miracle that Vue is actually become able to be sustainable on this sort of very loose, independent model. But building a unified toolchain is not something that's achievable with this model that I've been using for the past 10 years. So a company with proper funding, with the team of full-time employees working on this goal with full dedication is something that's needed. So we've been working really hard on this, and here is kind of like this big picture overview of what we're trying to build, and some of them we have already built. So at the very bottom, we're building a language toolchain called OXC. OXC is short for Oxidation Compiler. So you see the logo is an anchor that's rustified. It's rusted, so that's where the oxidation comes from. Right, so let's oxidize JavaScript with Rust. So OXC is this language toolchain that includes the parser, the semantic analysis, transformer, resolver, linter, formatter, minifier, right? All the things that you think about that has to do with the language itself. On top of OXC, we are building Rollodown, which is the bundler that, like I said, rollup compatible, ES build feature scope, and essentially guided by the need of Vite. It is designed to support Vite, and we're very close of getting Rollodown into Vite properly. On top of Vite, we have vtest, which is the Vite native test runner. Many of you probably already use as well. And these tools together will support the higher level ecosystem of tools and frameworks that's building on top of Vite. And on top of all of this, we have something called Vite Plus, which I'll talk a bit more about in a later slide. So, why Rust, right? First and foremost, we have to agree that tooling written in JavaScript has reached the performance bottleneck, right? You can write a really fast bundler in JavaScript, like with very painstaking manual optimizations. Like you can make single-thread JavaScript really fast, but JavaScript does not have proper parallelization, and that is the biggest problem. Like, in the recent news, the TypeScript team decided to rewrite TypeScript in Go, right? And the biggest gain from this rewrite, so the rewrite gets a 10x speed up compared to the TypeScript that's written in JavaScript itself. And half the gain actually comes from the fact that native language is able to utilize all the cores on in your CPU, right? And half it is just the raw performance difference between native languages and JavaScript. So tooling written in native languages for JavaScript is necessary to reach the level of performance to handle the scale that we're dealing with today. Like probably not all of you are building huge apps, but some of those companies, they have projects with millions of lines of JavaScript code. And at that scale, tooling written in JavaScript is really not going to hold up. So Rust also gives you this balance between performance seeding and memory safety. The thing about this is that you do have to essentially do proper memory management in Rust to get the best possible performance. And in Go, it's probably much easier. Go is garbage collected. Go also has a closer mental model compared to to JavaScript itself. So porting something that exists in JavaScript over to Go is much easier than porting something from JavaScript to Rust, which is why the TS team decided to go with Go, right? But the thing about Rust, however, is that it already has a very, very active ecosystem around JS tooling. There is SWC, which has existed for quite a long time. There are people at ByteDance building the RS stack. So RSPack is a direct Rust port of Webpack. So there are success stories that people have successfully built very performant tooling using Rust for JavaScript. And there is already a community of developers who are proficient in Rust and familiar with JS tooling. So the talent pool is actually bigger. And the more important, two more important point is Rust has very mature JS interop. So when we are calling Rust code from Node.js and we're passing data back and forth, this interop is necessary if you want to build tooling that still is able to interface with, say, userland JavaScript plugins, right? Rollout is a Rust bundler, but it actually supports JavaScript plugins. So all your rollup plugins actually just works in Rollout because we're able to provide that level of interop. And this is based on projects like NAPI-RS, whose author we work closely with to ensure that all our tooling can interface with your JavaScript code nicely. And then Rust has mature WebAssembly support. This is another big consideration because a lot of the tooling that we want, it should be able to run in the browser. Like for the use cases where you just want, say, an IDE or a playground that's directly in the browser. You don't want to have to download tons of things onto your computer to be able to just play around with a new framework, right? A lot of these frameworks just provide you with this like get started directly in the browser experience. And that's actually really useful and important for beginners to learn. So we want a language that gives us, mature WebAssembly support and performant WebAssembly build. So this is something actually Go kind of lacks in. And it's quite of a concern for the TypeScript rewrite as well. We're not trying to Rustify everything. Our goal is to essentially convert the parts in the toolchain that is more well-defined problems, like how do you parse JavaScript? That's a pretty well-defined problem, and it should be as fast as possible, so let's rewrite it in Rust, right? So with OXC, we have completed the parser, the linter, the resolver, the transformer. The linter is, actually, this number has to be updated. We just crossed the 500 ESLint rules threshold, so we implement 100% compatible ESLint rules, and we are constantly adding more and more rules, and it just works out of the box. We have the resolver that is Webpack compliant, does all the node modules resolution, spec compliant. We have the parser, which is 100% ECMA 262 spec compliant. And the minifier, we just did the alpha release of OXC minifier a short while ago. We're able to achieve better compression ratio than ESBuild and also runs quite a bit faster. So Rollout, we released 1.0 beta a while ago, actually at the end of last year. So it is already quite usable. Many people are starting to actually migrate to Rollout if they're currently using Rollup. And our current focus is Vite integration. We're trying to get a version of Vite that's fully powered by Rollout and OXC released around the end of this month. And we are passing 95% of our ecosystem CI, which means we put the version of Vite that's based on Rollout into frameworks that depend on Vite, and we run their tests to test the compatibility and stability of our integration. And finally, we are trying to get Rollout to support Vite in full bundle mode to address some of the performance issues at extreme scale. So let's see the performance. This is a benchmark that we run. Close to 20,000 modules. Half of them are JSX components, half of them are just plain JS files. And Rollout is able to bundle all of that in 0.75, like 750 milliseconds. Quite a bit faster than ESBuild, and quite a bit faster than other bundler that's written in Rust as well, and about 40 times faster than Rollup. And like I mentioned, the WebAssembly performance is also quite important, right? We were previously relying on ESBuild, and actually ESBuild's performance, its WebAssembly performance in browser environments has becoming a bottleneck, because Go's WebAssembly is very under-optimized. It has some fundamental issues that causing the WebAssembly compiled from Go to be actually performing even worse than JavaScript bundlers. So thanks to Rust, we're able to keep the same level of performance when we compile to WebAssembly. OK, so what's next? This is what Vite looks like now. So we have Vite itself, the JavaScript core, then we have ES-build, rollup, and some users use SWC. This is what Vite will look like very soon. So we essentially unify all the lower level dependencies, all the way from the parser to the bundler, and with OXE and Rowdown. And these projects are directly maintained by vuejs. So we essentially have full control over the vertical stack all the way from the parser to the build tool you're directly using. And in the future, we will expand the Rust layer a further bit more so that Rowdown will take over as the full bundler that's used in both development and production, whereas Vite's JavaScript core will be mostly dealing with the dev server, the preview server, and environment API, essentially the layer that interfaces our underlying capabilities with higher-level meta frameworks. And finally, this is kind of the long-term vision that we have for vuejs, is we're going to build the unified toolchain that we talked about, kind of like what Rome set out to do, but we are codenaming it Vite+, and the concept here is we want to make it feel like the cargo for JavaScript. If you've worked with Rust, you know when you start learning Rust, the thing you'd use to build, test, bench, and all that stuff, they all use cargo. It's just one tool for all your development cycle needs. And we want that, we've never had that kind of experience for JavaScript, and our hope is we can build something to actually do exactly that for the JavaScript ecosystem. So we already have a significant part of the pieces that we need to make this happen. So Vite+ is aimed at putting these pieces together, providing a more streamlined, integrate, out-of-the-box experience. It will be a bit more opinionated, but as the upside, you can stop worrying about what do I use for this, what do I use for that, and are they compatible with one another? That will be just one single entry point for most of the things you need to do with JavaScript. And we're hoping to ship a usable version of this in 2025. OK, so that's it. Thank you very much. Hello? Hello? Can you hear me? Yeah? OK. So there's one more thing we want to announce. So I'd like to invite Matthias, who is a Vite core team member, to the stage to announce something that we're really excited about.
Yeah. Thank you. Amazing to be here again. And Josh is also here. Yeah, I'm Patak. I work at StackBlitz. And one of the things that we have been doing in these past 3 years at StackBlitz is organizing ViteConf, an online conference for the Vite ecosystem that has been really great in the past 3 years. And just as an example, Evan announced vuejs in the past edition. StackBlitz announced Bolt in the past edition. And a lot of other projects announced a lot of really interesting stuff. And at the same time, this conference in particular, JSWORLD, has been great for Vite. 2 years ago, here we had 10 Vite team members doing a panel. It was the first time all the Vite team meet up, and it was great that you managed to do that. And yeah, last year I think we were with paper and thinking about how we're going to do environment API here also in the venue. So it means a lot for Vite, this conference. So a lot of people have been telling us every time that we did ViteConf, will there ever be an in-person conference? And there will be. This year, ViteConf is going to be in person, and it's going to be here. So yeah, that's a big news. I think, Josh, you...
Yeah? Well, absolutely. First, big applause for Evan and Matthias. Well, obviously we've been doing conference here since 2018, and it's actually all thanks to the person that is standing next to me, and also giving us the support and giving us the trust for coming on an annual basis. And obviously, without you, none of this would be possible either. So we're really honored for this opportunity. They approached us if we would be interested in organizing a VEED conference in person. Obviously, that was a full yes from our end. So yeah, we hope to welcome you back in October. But really, the persons or the people behind this are from StackBlitz and Evan himself and the VEED core team. So yeah, for us, amazing news. We hope to welcome you in October, and otherwise, who knows, perhaps next year. So please, big applause for them.
Okay, so in addition to looking forward to the in-person conference, we also want to show you something that we've been working on since last year. And yeah, it's going to be the first reveal of the teaser for the VEED documentary.
This is the part that I've never actually publicly talked about. It's also a quite complicated story, actually.
JavaScript has kind of always been seen as a little bit flawed.
The speed at which the complexity of JavaScript apps grew was not something anyone was prepared for.
More and more you build and you just kind of dump it on the browser. People were starting to realize that they needed another layer to bring all the pieces together.
Webpack was really the only player at that time.
Webpack was this idea of let's just pipe everything through JavaScript.
Webpack is quite a mess. It's good technology, but it's quite a mess. It's the biggest choose-your-own-adventure of all time.
If you have a very large application, then you could be talking about having to wait over a minute for their application to start. It didn't make sense to me.
How can we make web faster?
I think at that point, people were ready for something else.
This is kind of the world we were entering into in 2020.
I still remember seeing the tweet from Evan Yu.
Super awesome, super awesome. Good job, guys. VEEDConf October, wow. Did you scan the QR codes? Did you join the waiting list? Thank you, yes. Next up, we have another duo who are going to talk about a lightweight JavaScript library called Hono. Please put your hands together for Nell and Harshal.
Okay. All right. Welcome everyone to the talk, Write Once, Deploy Anywhere, Building Apps with Hono. In this talk, we're going to talk about Hono. If you have been at our booth, you might have heard about a lot about Hono from us. But if you haven't, don't worry. In this talk, we will help you understand what is Hono and how you can use Hono for building serverless apps. Now, the idea for the talk is to basically create a fun little application called the Goose Adventures. So we have an app where you can see that we have a friend Goose over here who is traveling with us to Amsterdam. Goose loves to take pictures. Unfortunately, it cannot do it itself. So we have created an app where you can enter a name. You can select what kind of activity the Goose wants to do. You can also select an art style. Because we are in Amsterdam, let's do Van Gogh. And then you can also select a color scheme. And when you click on Generate Image, it's going to use Workers AI, which is an offering from Cloudflare behind the scenes to generate a beautiful image. So the idea of the talk is to build something similar, not the whole thing, but something similar so that you also get an idea of what is Hono. All right. Now, before we do that, we have the slides already on, so you can scan the QR code, and I would encourage you to do that because, as you see, we have some emojis down there with which you can give us some live feedback during the talk. So I'm going to wait for a couple of seconds for folks to open up, and I see a thumbs up going on. Thank you. All right, a heart. Thank you. All right, this is interesting. So we have people now with the slides. I'm going to move on. We're going to test it again in the next couple of slides. So how many of you? Oh, wow. OK, that's interesting. Wasn't expecting this, but it's working now. Yeah, OK. So how many of you create or maintain APIs? And when you talk about APIs, it's not only in production, but maybe it can be like, in your hobby project as well. Again, you can do with the eye emojis where, like, I don't use APIs at all, to the mind-blown emoji where it is like, I do use APIs all the time. All right, I see a lot of interaction going on. This is pretty cool. The next question is, have you heard about Hono?
Again, like use the eye emojis if you never heard about it, especially if you haven't heard about it before talking to us. And if you heard about it before, use the heart emojis. I see more eye emojis now. I think so a lot of people are new to Hono, which is great.
Which is great, exactly.
It makes sense that we are here and talk about it.
But for the folks who have heard about Hono, I have a next question for you. Do you use Hono in production? Again, can be a hobby project or can be something that you do at your day-to-day job. What about you? Do you use Hono?
Well, at Fiberplane, we really love Hono. And for example, the Goose has a private website called honk.dev, and it's also built on Hono. But we also have different services that we build on Hono and have deployed.
Amazing.
What about you and Cloudflare?
At Cloudflare, we are a huge fan of Hono. We love using Hono, and I am fortunate enough that the creator of Hono is my colleague, so I get to interact with him, learn more about Hono in depth as well. And I feel it's a bit unfair that we know about the audience, but they don't know about us. So let's move on and do a quick introduction. So my name is Herschel. I live in Berlin, Germany. I work as a developer educator at Cloudflare, and I love to build silly projects. I can say this emoji thing is also like a silly project that I created. But apart from that, I have created this game called Quick Flex. It's a mobile game that you can play on your phone. You can play it by yourself or with your friends. Over to you.
Thank you, Arshel. So my name is Nele. I work for a company called Fiberplane as developer advocate. And when it comes to software, I was always obsessed with finding the right glue between services to compose an overall system. And that also includes APIs. And yeah, by the way, I'm also the Goose travel companion. So wherever the Goose goes, I also go. And let's move back to Hono. So Hono is a lightweight JavaScript framework, mainly to build APIs and to build out your backend logic. And if you have used any API framework before, you will find familiar concepts in that. If you haven't, Hono also makes it very easy to get started and to understand the way to build out your backend application. It provides middleware and helper functions and RPCs, so you can, or it provides a lot of things out of the box that you can use. And the really special thing is it's runtime agnostic. So let's dive a little bit deeper into the point, what makes it runtime agnostic. It is built around web standards or on web standards, and mainly Hono is built around the Fetch API. And the Fetch API can run in your browser, it can run on a node server, but it can also run serverless, for example, on a Cloudflare worker. So you can really imagine Hono as a universal travel adapter that you can plug and play into multiple frameworks. And one design concept that comes with it is the idea of having context. That is unique to Hono. And the idea of context is that it maintains the lifecycle from request to response. And you can access, for example, in the context object, the request headers, but you can also return parameters as a response. Also, in the context, you have access to your environment. So you would also access environment variables over context. And yeah, I said that it's a unified object where you have that information. Then the other concept part, before we finally go into the code, is Hono middleware. So Hono comes with a bunch of middleware that you can use, and the idea is that before the handler, so the handler is a part where you define what your application is doing, and before and after the handler, you can use middleware to modify the context. And there is built-in middleware that Hono provides. There is third-party middleware that you can use, and if you're not happy with whatever exists already, you can also build your custom middleware. And with that, I would say let's go to some code. Let's move to your CLI first.
All right, so now that we are on the CLI and we want to create a new Hono project, what should we do first?
npm create Hono, simply like that. And you see, you want to give it a name, the directory where you want to store it, and now you see already all the different templates that you can use on the runtimes. I would say let's go with Node.js, but also we don't have to go through the whole setup. We don't know how good the conference Wi-Fi is. Let's go directly to the IDE. We have already prepared a project, and this will be something you will also get if you run through the CLI setup. We have a few things more included here throughout the demo that we are going to use, but the idea is if you start the project and if you go to the index file, you will see something very similar, maybe without all the imports, but the idea is you have a simple endpoint at line 18 that returns hello Hono, and then from line 22 we see there are some configurations for the node server. And maybe now it's time to move to the package.json. That's also something that we have included here for the talk. We have included different scripts, so we can really run on different runtimes. And I would say with that, let's start the application on Node. So if you can run the dev node command, that would be handy. Nice. And here we are with hello Hono. We return text. Perfect. So I think now we can start building the application that we have seen in the beginning that you showed us, so the backend for that application. So we saw that we have some input fields where the user provides input to decide where the goose goes, what the color schema will look like, and so on. So let's create an endpoint that we name start, a get endpoint. And besides text, that's what we rendered in the initial endpoint, we can also render HTML. And not only HTML, but we can also render JSX components or TSX components, and that's what we have prepared already. So that's also why our file is an index TSX already. So we are going to use and render TSX here. And then let's do another endpoint because we want to generate an image afterwards. Let's do a post endpoint where we take the information from our input form and provide it to the endpoint. And maybe for now, just return some JSON. And I think you can also copy paste if you want. I think.
You know me so well. I am a lazy developer, just like most of the folks in the room. So I'm just going to copy and paste the code from here. I mean, I also use AI a lot to do this, but it's not working really well right now. So I'm just going to copy paste the code.
I mean, it's working, but it's doing mistakes, and we don't have time here to fix it. No, but it's OK. But yeah, cool. That's the endpoint. And instead of HTML or text, now we return JSON. So also, if you build a data API, you can return plain JSON as well. Cool. And we've been on Node so far. I would say let's switch it up. Let's run this on Bun. And for that, the only thing we want to do is we don't need the specifica for the Node server anymore in our application, so we can comment that out. We only need to export the default app now, and then we can run the script that we've prepared for dev Bun. And I mean, it runs now on 3000, but actually look and feel should be the same of the application. If we go now to the start endpoint, we have the form here. We can start providing input for our goose. So I think we are in a pretty good shape to build more.
We are, but we are not, because I don't know if you noticed people were playing around with the slides. Someone got the access to it. They were moving the slides around. It might happen with this app as well, where people can access the start page. They can generate the image. And then I might end up with getting a huge bill from the AI providers.
OK.
So that's one thing. I want to make sure that my endpoint is safe. It's secure. There's some kind of an authentication, basically. And we just tested out the start endpoint, but we did not really test out the generate endpoint. I know we cannot run post endpoints on the browser, which is not really practical. So how do we do that as well?
OK, let's move to the Hono documentation side for a moment, and let's look what we can use from middleware or which middleware exists. And I mean, that's the first one. Handy here is basic authentication, but you can see we can choose from a bunch of things that are here. There's also validation with Zord. There's logging, different stuff that is built in already. For your authentication problem, why are we not using this basic authentication here and put it on our start endpoint? And I encourage you to be watching this carefully, because the password and the username gives you later on access to our application. So if you want to generate goose images and also print them later at our booth, that will be possible with the username and the password. That's fine. And then the next thing is, I'm glad you asked about the post stuff. I work at Fiberplane, and we build an integration for Hono. So we build an API playground, and the only thing you need for it is an open API spec from your application, and we have a helper function that helps you to generate one if you don't want to rewrite the application to use Zord validation and that, or turn that then into open API spec. We use now the helper function in the Fiberplane package to get an open API spec. We put that on the endpoint open API.json, and then we can mount Fiberplane's middleware on a FP endpoint and point it towards our open API spec. And then I would say this has been running on Bun now really successfully. I know you don't want to run forever on Bun. Let's go to your favorite environment. Let's use a Cloudflare worker.
Awesome.
So
I'm going to do npm run dev workers. It should now have it running on port 8787. I can refresh this. Don't get an error, which is good. Let's do a start endpoint. It now is asking for a username and a password, which is good.
So we have the basic authentication. Nice. And now you can also use the FP endpoint if you want to outline the playground. So you have the post endpoint there. You can provide a body. I think you want to change that from JSON to form because we use form. You can provide some input parameters and send this. If you have a more fine-grained open API spec, the body will be also pre-filled with the example data from your application. And this is more to come. We will soon announce tracing, so then you also get an idea of the call chain of a single request call. And there will be also workflows chaining up multiple requests together soon. But yeah, you use the simple post endpoint that works. And I think now we can do what every application needs nowadays. We need to make this an AI application. Because
Let's do it. Let's do it. Let's add some AI to it. So right till now, we saw that we have an index endpoint, which is basically just saying hello Hono. We have a start endpoint, which renders out a form. And we have a generate endpoint, which should basically generate an AI image for us. So let's go ahead and do that. It's already running on Cloudflare Workers. So we're going to use services from Cloudflare itself to make it easy for us to build this application. So you want to open up the Wrangler file. Now the Wrangler file is very specific to Cloudflare Workers. It tells the Cloudflare Workers what kind of application you are running, where is the main file that it should be executing, and you can also add bindings, which are basically telling workers like, hey, you should use this particular product for doing a certain task. So we are going to use Workers AI, which is an AI inference as a service. To do that, it's like just 2 lines of code. You add the AI bindings, and then we want to go back to our index file. Now, this is a TypeScript project, so we already have created the Cloudflare binding types for this. And the only thing we want to do is just pass it on to Hono.
Yes, and that's your machine.
All right, while we do that, you don't really need it if it's not a TypeScript project, if it's like a simple JavaScript project. But we found that during the practice of our talk, it was super helpful for us because it gave us a lot of autocomplete out of the box, help us save the time that is shouting at us right now. So let's go to the documentation, because again, I love copy pasting the code from the internet. So let's do this. So over here, you can see we have a list of models from Workers AI. We're going to do text to image, and we want to use the Flux one Chanel, because I think that was like the best model with our use case.
It worked out well, but you mean like because I included the binding, I can now access this Cloudflare service and like only call it from my code? That's,
exactly.
Okay,
You
cool.
don't need to pass on any kind of credentials to it.
Nice.
You just can now copy and paste this code, and we should be good to go. All right, let's go to the generate endpoint. We already have getting the input. We just want to like use those inputs to return the output. So let's do that. Now, if you see over here, we get an error for the env variable. Now, if you remember, we talked about Hono context. Using the context, you get these values out of from Hono, and this gets this is made available on every request. So if even you are passing any kind of secrets, they are not exposed or are stored anywhere. It only gets those secrets when the request is being made. So now that we have AI, we don't want to create a cyberpunk lizard, I think.
No.
We want to create like an image for our goose. So let's go ahead and do that. Again, we created the prompt beforehand because I don't really like typing, as you can now tell by now. So we're going to use the prompt that we already have. And just save this, and let's go back to our form and test it. There are a couple of TS errors that the code editor is shouting, but I think that's nothing major. It does not break the application, and we don't want to waste some time to fix that, so we're going to skip it for now.
Okay,
any preference on the location? Where do we want our friend Goose to be? I'm bad with pronunciation. I'm not going to try to attempt that. What kind of activity we wanted to do?
I feel it's time for beer already, so I think it can drink a
Let's do that. Let's do that.
And the art style. Oh, we have some stuff we should fix on the front end. We can go for whiteboard drawing this time, and then we do. Well, let's try black-white. Let's see what it does.
Let's generate the image. It's making a call to workers AI, and in a few milliseconds, you see we have a goose enjoying a beer.
It's not a Heineken.
Near the windmills.
Well, but it's
it's AI.
Okay, yeah, fair enough. But it's doing it. It's also not completely black and white, but I'm happy. So, but Harshal, we have this image now. In the first application, we saw galleries. So now we are not storing this, and we are not putting it on our gallery view at the endpoint.
It's true.
Can we fix that?
We can. So let's do this. Let's add a feature where it uploads the image somewhere. But because we have not so much time, we can share later on the wrapper with the folks where they can just get the code. So to do this, you can again use different things to store it. We are going to use R2, which is an S3 compatible object storage, again from Cloudflare. All you have to do is create a bucket. I already have a bucket, and just add the bindings for it. Now that we have it in place, we want to give a name to our object. So let's do that first.
How do you want to name it?
Let's use a timestamp because if someone has the same name, it would help us differentiate that. So let's do a timestamp. I love Copilot. Thank you. And
then we'll create
let's just do a file name.
Are you happy with that?
I love this. And then it's like just one line of code, r2.put. So you just want to do yes and exactly, and then yeah, we don't need to pass any of the parameters. This is good. You can save it. And the next time a request is being made, it's going to generate the image, and then it's going to upload to R2. So if you want to add a gallery to our index route, all we have to do is get these images from the R2 bucket.
Okay, cool. And that's only, I mean, it's possible if we bind it in Wrangler with one line of code. That's really handy. Yeah, but time is running up. So I would say we sum up. We have the full code where we also use the bucket, where we also use some validation with Zord for you folks ready. But yeah, to your slides.
All right, I will do a quick recap now. So we saw that Hono is runtime agnostic. We started the application running on Node.js. We then moved on to running the same application on Bun, and then we ended up using Cloudflare Workers. You can do it with Dino as well, but we thought it would be better to just show a couple of those runtime environments. And if you want to build the same application using Workers AI and R2 bucket, you can still do it on different environments, but if you're not using Cloudflare Workers, you would have to use the APIs and the SDKs that we provide. We also saw that using Hono, you can render text, you can render JSON, you can render HTML using JSX or just pure HTML, and Hono also has full stack framework called Hono X, but that's not just a limitation with that. If you already are using a Vue-based framework that can be just Vue or Nuxt, or if you are a React developer using a React-based framework, maybe it's Next.js or React Router. Hono has adapters for all these frameworks, so you can still build your APIs with Hono and have your favorite front-end framework with it. And it also comes with built-in middlewares, third-party middlewares. We saw 2 of those. We did not have time to build custom middlewares. But if you follow the documentation, it's quite straightforward to build your custom middlewares as well. But how do we again create an Hono app?
I mean, we saw that in the beginning. It's one command line in your CLI away, npm create Hono latest. And if you want to create an application that maybe has already a database component to it and an ORM, the Goose has its own stack. It's called JAMstack. It's npm create hong -app at latest. And that gives you a Hono application with a Cloudflare worker, an ORM that is Drizzle, and you can choose between a database. It's basically name your favorite database template. At the moment, we have D1, we have Neon and Supabase for that. And yeah, that gives you already a structure to get started. If you know, if you want to store, for example, data, then you have those components wired up already. Yeah, with that, we have some resources where you can read more. It's the Hono documentation, which is a great starting point. Then there are Hono examples out there, and the Hono Discord is a super friendly community. If you start building with Hono and if you have questions, I encourage you to go there to ask your questions. It's very likely that someone will answer them straight away. There is a super cool video by Syntax that helped me a lot when getting started. It's building a type-safe API, not only using Hono, but also Zod and a logger and other technologies, and it really gives you a good overview how you can start with Hono. And the Cloudflare developer YouTube channel also has specific videos and resources specifically on Hono. And with that, there is a QR code where you can generate your Goose Traveler image. We have a label printer at our booth, so we can print a sticker of your created image if you visit us at the booth. The full code is at that link available. If you have the slides, you can also check that out later. And with that, Harshal, I'd like to say thank you to you.
Thank you to you, and thank you to you all.
Thank you to all. And that's it.
Thank you very much. I do have one very important question. What is the goose called?
That's a very philosophic question as well. There has been discussions in the office. Few people think it's called Sir Honks a lot, but another part of the company is not satisfied with the name. So if someone has a good suggestion, find us at the booth as well.
How about Goosey Lucy?
Ooh, Goosey Lucy.
You can think about it.
Yeah.
Think about it. Goosey Lucy.
I always thought it's a female goose, so I think I agree.
Female goose.
Yeah, like
what do you have to say for yourself? Goosey Lucy. Awesome. Thank you, guys. Please give another round of applause for Goosey Lucy, Nelly, and Harshal. Thank you. Another thing I want to say is that I want to apologize for a small mix-up on the screen. Daniel Perry is not our last talk before the break. We have another talk as well. We have Daniel Nachu coming up for an experience talk of how he did a JavaScript application from a startup from ground up to a big beast of a big company, a successful one. So please join me in welcoming Dan for his talk, please.
So I've attended JSWORLD and Vue Amsterdam 4 times now, but I guess this is the first time I'm actually sitting on the stage. And I want to take the time to actually give you some advice. I don't know if you know, but this part right here, it's actually the best spot that you can be at this conference, because you have the perfect view of the stage, you can take perfect pictures, but once the screens open up, you're also first in line at the beer. But last time I was here, it was 2 years ago, and I couldn't focus on the talks. I was staring at my phone every two minutes because I had a really big decision to make. I decided to change my job. And I had 2 offers on the table. I was either a high-paying senior software engineer at a public company, or I can be a tech co-founder with little to no pay, but with equity in the company and the opportunity to build something from scratch. And I realized that I really love building things and getting my hands dirty, but, and this is a big but, I always leave projects with just the windows and doors that are missing. So I decided, okay, this is the perfect opportunity to experience something from 0 to 1. So what did I agree to? What was the idea that made me turn down a lucrative salary and the comfort of a nice, stable job? And the basic premise was we were going to war with the apply button for jobs. Now, this product is for universities only. I'm not trying to sell you right now. Unless you're the dean of a university, find me afterwards. So we say don't bother applying to jobs, actually network and build lasting relationships so you can get recommended for an open position in the future. And the original founders, Max and Marcus, were students themselves, and they wanted to build something for students by students. So they met up one night over beers, like this thing happened, and drew up the Career OS, that's the name of our startup, on a piece of paper. They collected the emails of around 30 deans or career advisors and people who had buying power, and then they sent them cold emails, like in this example right here. At this point, there was no startup, no money, no product. They just wanted to validate their idea. If nobody answered this cold email that they sent, the idea was a bust. Instead, even though it was the Christmas holidays, they got around 10 responses. Then and only then did they decided, okay, this idea is worth pursuing, and they went full steam ahead and finding technical co-founders, me and another person, Oleksiy, and then raising money to build a startup. Now, the biggest mistake I notice tech entrepreneurs make is this. They get an idea for an app. Who here has an app idea or had an app idea? And who here has actually managed to build an MVP? As you can see, there's a really huge drop-off from this person, because usually, even if you build the MVP, they go ahead and validate the idea with the wrong people, friends, work colleagues, even their parents. Then, with their MVP and their mother's blessing, they try to raise money. Now, being technical, they go to the one place they have heard of, which is Y Combinator, and then they promptly get rejected and give up. And when they say that 95% of startups fail, they usually mean the startup that followed this process. But in reality, these pillars have to go hand in hand from start to finish, like we did with Career OS. We validated the idea without any money spent, just an email. Then when we got responses, we actually started sending emails to investors, potential investors in the ecosphere. But we didn't ask them for money, we just asked them for feedback. And a pro tip, investors love to give feedback. So every month, we kept potential investors and clients informed about our work, again, without no transactional intention behind. So in this email, we were mentioning that we send this to friends, family, mentors. We were lying. We were just sending it to potential investors. And after 6 weeks of doing this, we had our first MVP. This is how it looked like 2 years ago. We had like a basic joke where you learn how to throw axes. You had like some action points that you had to do, the onboarding process. There was no backend at this point in this part. This page didn't even work. Then you had a place where you saved your companies that you want to work at, so it had a historical value. And if you clicked on it, you saw a little bit of the company information, their LinkedIn. And this was the only thing that actually worked, was a Kanban of your companies. And you can drag and drop them basically to reflect in what stage you are with that current company if you're looking for a job. Now, with this MVP, we got 4 paying customers, and we raised $800K in our pre-seed round. So then we can hire a team, and just by doing everything at the same time. Now, it might seem impossible, but this is me 13 years ago, at my first job as a programmer. Now, looking at this, you might think, what went wrong? Well, I had to start working with Angular 1. Then I worked with Angular 2 from alpha to all the way up to 18 or 19, upgrading every couple of months. With React, when it had classes components, if you remember that era. In my previous company, we were working with Vue 2 and Nux 2, and we had to upgrade that to Nux 3, which was practically impossible. We gave up. And in my first job, I was actually coding everything in Laravel 3 or PHP 5, which was a mess. So I can tell you, when building a product and choosing a framework, your biggest enemy is time. In our industry and ecosystem, every week something new appears, and you don't want to be left behind. And it's practically impossible, if you have now an old framework like Angular 1, to actually hire Angular 1 developers. Oh, I'm sure you can find people that can code in Angular 1, but would they want to? No. And in choosing the tech stack for my project, my biggest fear, of course, was being left behind. So I had some rules to make sure this never happened. We were never going to use framework-specific UI libraries. We're going to build our own. Never going to use framework-specific third-party libraries. And we're never going to use no-code tools. And I was also deeply impressed by NASA and how they build the International Space Station. So they built each module on Earth, and then they launched the module separately over 30 international missions. And you can see in this video how each module was connected, removed, connected in another place. And this was made possible because each module had the same set of docking ports and adapters, basically a common interface. So when designing my app, I wanted to work the same way. Using terms from domain-driven design, I wanted to create like multiple modules, and each module can be connected with other parts of the app through ports and adapters. Now, each module had its own guidelines, folder structure, and interface. But for all of them to work correctly, we also needed a design system and component library. I didn't want to make the UI mistakes of my past, and everything we built had to be reusable. Actually, the first files I wrote in the repo were the CSS variables and Sass mixins and typography to make sure everything is well structured. And of course, each component had to have accessibility test, a storybook, and unit tests. Now, I had so many rules in place when I started, I forgot this famous quote by Mike Tyson that says, "Everyone has a plan until they get punched in the mouth." So the first punch was more of a slap, but I realized I showed you the Kanban board. I tried to get it better, to make it more seamless, more beautiful, and I just couldn't do it. So after 2 or 3 days of frustrating coding, which is the opposite of vibe coding, I gave up and installed React Beautiful DND. And then the second library, we had to use Firebase because we were never going to build a chat system without Firebase. We needed analytics, so we had to add chart.js. We needed a way to handle rich text in our chat system, so we added React Quill. Then we needed analytics monitoring, so Mixpanel, React Analytics, Customer I/O, React Lodi for videos, React PDF when we built a resume builder. As you can see, it got out of hand. They can't even fit in the image. It was 60 third-party libraries we have currently, and with each library we added, our ability to migrate and keep the app up to date decreased, which is something I dreaded. So what did we do? For each party that we added, first we created a wrapper component or a proxy that exposed an interface that we used in different parts of the app. This way, if we ever need to replace Mixpanel here, we can just replace it with another library, first in this file, and then make that library act as the one before, using the same interface. So we don't have to change it all over the app. And then we went a step further, and because we have so many analytics library, we group everything that can be grouped into an analytics module. And this encapsulated all of our analytics logic here. So for example, if we ever needed to remove a library, we just remove it from this file. And if we ever needed to add the library, we needed recently to add Algolia, for example, events, we just added in this file, and all the events are sent where we have the normal events. Another punch we received was with our component library and design system. Now, a year in our startup, we needed to start another app, and it had the same design. So we thought, OK, it's time to move our components folder into an NPM package and reuse it across both of our products. And we thought it's going to be easy, but we were dead wrong. At this point, we had around 50 to 60 components, and we decided to start small and just with the button. But after moving the button and using the button in both projects, our library, we thought, OK, the hard part is over. We have 49 more components to go. It's an easy adventure. Let's go. Reality was another punch. We thought we kept all our components dumb, but unfortunately, a lot of project-related logic kept into our components, like router-based navigation, state-related values, or in some extreme cases, we are making API calls in our dumb components. We also had a race condition. By the time we moved one package from the main project, we copied it in the library. When was the time to use it and replace it into the main project, we found out that it was already changed. Someone made a change there. So the team velocity was so fast that our technical debt was hitting us hard. This is Coco. We name our component library Coco after our office dog. So we tackled this into 3 stages. First, Figma as a source of truth and correcting the components to be exactly as Figma down to the prop names. Then moving the components by one, but assigning a project lead to delegate the task to other developers, but also be a mandatory code reviewer for the components folder. So if someone wanted to change something inside of a component folder, the project lead will say, no, first you move this component inside the component library, and you change it there. And finally, Storybook, CI/CD that kept both projects and library in sync. So if there's one thing I would change, if I could go back in time, I would do this. I would not put all my components inside the component folder, and I would start the NPM package from the start. Now, another punch I personally received was a serious implementation mistake I made. So a year again in our startup, we noticed our dev tools getting slower and slower and slower to the point that it was not usable anymore. It was fine when you build for production, but in dev mode, where it mattered, where you actually need dev tools, it was no longer working because it was importing all of our SCSS files into every time for each module that we're exporting. So it was duplicating all of our styling. So now I assumed that the issue was how I was doing the imports here in the global Vite plugin. So here I was using the import keyword. So then I changed it to use, and then it became a little clearer what the problem was. It was actually importing the CSS root variables 9,000 times. So of course, I digged a little bit more, and I found that someone had the same issue on GitHub and said a universal truth that I didn't know. So inside additional data for your SAS files, you can only have SAS-related variables, mixins, or functions. Now, I'm being pretty stupid myself. I decided to also add CSS variables inside of that. So because I did it, it added for each component, it duplicated the CSS variables. And to make matters worse, I did the same in our component library, so it was being duplicated quite again. So then I moved all the CSS into a global CSS file, imported it in the index.html, and the problem went away. Now, to make matters even more embarrassing, once I fixed it, it also saved us 200 kilo of JavaScript for the final bundle. So speaking about bundle size, as we kept adding up features, our bundle kept increasing. So we decided to split our main routes using React Lazy like so. Now, this made sure that when someone was on the website and they clicked on a link and they went to that page, this is the moment we loaded that chunk of the application. Pretty standard practice. And it worked great until we noticed a lot of errors, namely a failed to import dynamic module error. And this was happening as soon as we were deploying. So what was happening? When Vite builds a chunk file, it adds a random hash at the end of the chunk for cache busting purposes. We want our users to have the latest version of app as possible. But when we were deploying and someone was actually on the website using it, and we have people all the time using the app, when they click a link in their source map, they had the old chunk. So when they click it, it couldn't be loaded because we added the new hash in the production server. Now, Vite has a preload error that you can use, that you can add it to listen globally for when this happens. And if you can add the location reload, and it reloads the page. But we thought, OK, this is not really good UX to reload the page when you go on a link. And of course, there was also a pesky issue on Safari Mobile where some users got stuck into an infinite loop. So we explored different solutions. The safe one was to not delete the old chunks from the server and keep multiple versions of the app in the this folder. And this, again, worked great. It solved some issues, but the problem was when we had breaking changes in our API, the old chunks will create multiple errors, which we didn't want. So eventually, we landed on our final solution where we kept both versions of the hash, but instead of a random hash for the chunks, we used our app version number. And in the background, we had a service worker listen to an API call, and when this happens, it checks for the recent version number. And when it finds a new version that it has in the background, it updates the source map of the given user, so it always has the new version. So all in all, it's been over 2 years. We're using the latest React, the latest Vite, the latest JAMstack, and we're pretty happy that we kept technical debt now as close to 0 as possible. But our app is good now, but a year ago, if I'm honest, we were flooded with bugs, either visual functionality. Our app was breaking every day. During sales calls, we were holding our breath for it not to break, and sadly, it mostly did. It got so bad, there was a running joke that our app, for 60% of the time, was working every time. So what did we do? Well, first we implemented like a no broken windows policy. So if you don't know the broken window theory, it states that if a neighborhood has broken windows, it normalizes crime and it raises crime rates. And it's the same with app as well. If you already have bugs in the app, if a new bug appears, you're just going to pile it up in the backlog and you make it normal to have bugs. So we said enough is enough, and we decided during the summer to create a bug squashing competition where we took all of our bugs from the backlog, we added points to them, and we created a nice competition for people to solve them. So being the summer of the Olympics, we actually made it a competition with medals and even awarded Amazon gift cards to the winners. It actually took me 2 weeks to find a screenshot where I am first. It got so competitive, people were fighting for him. So that was just half the battle. We want to make sure that functionalities don't creep their way to prod after we fix all the bugs. So we implemented the new ways of working. So we're using Netlify for our hosting, but I'm sure every hosting provider has the same thing where they have deploy previews. So with these previews on the branch level, when you create a branch, a PR, we do their design acceptance, QA testing, and product acceptance in the branch, in the pull request, before anything is actually merged to main. Then we created a pretty sweet release process where every time you merge something, we have GitHub actions that check the PR title, and then it verifies if this PR is a minor build, it's a major build, or has breaking changes. And it puts, once you merge it, it puts it in the GitHub draft release automatically. Because we're not doing continuous deployment to production, we push a button. So we want to see, okay, what am I deploying now? Has everything been tested? And once we do this, GitHub automatically, once you publish the release, it automatically sends a Slack notification so all of our company can quickly check out if what we released is good for the users. If you want to read more about this, I have a complete tutorial on my blog, netudan.dev. Now, finally, we made it a strong recommendation for every team member to use Cursor. That way, we can create Cursor rules that contain how to write our Sass, our HTML. We are using BEM syntax, how to write our types, how to write our React. This made it easier for backend developers to enter the code base using Cursor agent and actually make changes to the app if needed. And of course, for new joiners to be onboarded easier. Then in the PR itself, everyone has to put what was changed. We have a quality checklist. We have to add 2 videos, for example, what was before, what was after, so anybody can test it. So fast forward 2 years, we removed the green. If you remember from my previous video, this is how the app looks like now. We suggest contacts. We have a dual inbox where you can generate messages and reach out to your networking possibilities. You can send emails or LinkedIn connections. We have another Kanban for contacts where you keep track of where you are. This is all automated, so it moves while you're sending messages. This is the previous Kanban board I show you. Now it's way more slick, it looks way better. Again, everything is automated. We have some nice emojis here and there. When you open it, we tell you what you need to do, like next steps in the job process. Have some AI, some jobs. You can keep notes, stuff like that. But I guess the biggest thing is we wanted to gamify the process a little bit, so we created challenges for students. Students like to experience this. If you complete a challenge, you get the badge. Then you have like this nice effect that happens when you complete a challenge. And what we found that worked really, really well is competition. So we created leaderboards where we pity school versus school or student versus student. Yeah, so we built all of this in 2 years, and I'm super amazed of the team that we have who push boundaries of perfection every time. If you notice, Coco is right there in the picture. So where does that leave us? The tech world loves to debate frameworks and tools, but at the end of the day, what matters is building something that works, that scales, and that people actually want to use. And sometimes that means wrapping third-party libraries and components you can swap up later. Sometimes it means ditching a fancy router because something new is better. And it means giving us the opportunity to always migrate and keep our app up to date so we can work with the latest technologies. And hey, if you're ever in Barcelona or planning to visit, I organized the React Barcelona meetup. I've got some React Barcelona stickers with me, so find me after the talk and get some free stickers. So if you're sitting here today like I was 2 years ago, wondering whether to take that leap to build something new, to join that startup, my advice is simply do it. Like the punches will come, but you'll figure out how to roll with them. And remember, everyone has a plan until they get punched in the face. But with solid foundations and modular design, at least you'll be standing afterwards. Thank you.
Only in 2 years? That's awesome. Good job, really.
Thank you.
Yes, thanks. It's the last talk before the coffee break. Who's tired? I'm not tired. Are you tired? No, come on. Just stay 25 more minutes for an awesome talk, and then we'll have a nice break with coffee, and then tea or soft drinks if you want. The next speaker is going to talk about TypeScript, type safety, blah, 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 blah. But I bet you didn't know he is an awesome DJ in his free time. Ladies, gentlemen, and Goosey Lucy, please put your hands together for Daniel Piri.
That's not how that should be. Oh my god. There we go. Set? Almost actually. One more. Actually, there's a couple. bit of a setup. Actually, I should. Okay, that's good. Thank you for the. Oh, it did that annoying thing. Okay, I will. Okay, we're good now. Just need to bring this here and wait. Okay. It's like the longest setup ever, but we're good. Thank you. Hello, everybody. Thank you for being here right before the coffee break, one. I'll be talking about something pretty interesting, making search type safe, but not just making it type safe, making search better. Search is a uniquely difficult problem, and I am very lucky to be talking about that. I'm Daniel, as I was introduced, a developer experience engineer at vuejs, which I just found out is actually one of the Netherlands' biggest AI companies. But we have our origins in search. And so that's why I'm giving this talk. So let's get into it. Search is everywhere, right? I think this is something that we literally cannot ignore, right? But why should you care about it? That's a really interesting question. A lot of our lives feel like this would be what they would be like if search was good, if we could find exactly what we wanted when we looked for it. Sadly, this isn't the world we live in, right? Because search is difficult. It's a very messy amalgamation of multiple variables, right? There's so many things that we have to work with. Like this, right? When you're looking through a graph of people on a social media site, like Blue Sky, for example, that's a whole different data set that you have to navigate and look through. Or something like Google Maps, right? When we're looking for a restaurant or one of our favorite co-working spaces, you have to work with geo-coordinates. That's another subset of things that you have to work through, right? Or travel, when we want to find our next holiday, our summer plans, or some festival that we want to go to. Travel is another different subset of problems, right? And then we even go all the way to YouTube. I know some of us really like YouTube, right? That's another subset of things to search over. Text, video, actual video, or metadata from that video. There's so many things, right? Or Pinterest, right? We want to search natively through images outside of that metadata. What does that experience look like? And this sort of gives us an introduction to what the search problem is, right? We're building search in almost every application that we build, but our search looks different from every other search experience everyone's trying to build. Search needs to be bespoke. But that can be really hard, right? Also because a lot of the code that we write is cultural, and culture evolves. At the end of the day, we're solving human problems, right? We're trying to go from, I have this thing that I'm looking for, how do I find it, and how do I present it to this person? But there's millions of people looking for different things in ways that you cannot even imagine, right? And so if we go back and sort of think about how we retrieved information, right? When we started, the thing you tell someone is, go read a book, right? Or look through the yellow pages if you want to find a plumber. And that became Google it. You want to find a restaurant, Google it. You want travel recommendations, Google it, right? And today we're living in a world where it's ask ChatGPT, right? It doesn't have to be ChatGPT, it could be whatever language model you're using. But essentially, all of these things are changing as we move, right? And as developers, this gives us a new responsibility, not just to provide good experiences for what was before, but also for what is to come, right? And a lot of people, depending on who you might ask, might say, this is the evolution that we're going to. A lot of people might say we're actually going backwards, right? We're devolving in how we're having these experiences. But like I said, depending on who you might ask. Now, the thing here is, I like to think I coined this phrase. The birth of a new paradigm doesn't signal the death of an incumbent. Essentially what this means is just because we're enabling ChatGPT-like experiences in our applications doesn't mean we forget about the Google-like search experiences or the read a book-like search experiences. So today we'll be going through a couple of things with TypeScript and search applications, where we'll be discovering fire, but also going to the moon. So let's fix search. Right? A lot of this will be live coding, so let's get into that. I've put together a list of things that make a good search experience. And I want us to think about this as a spectrum, right? We're not necessarily in one or all. So this is where we are, right? Better search looks like functional search, right? It should be good in function. It should be good in context. It should be good in accuracy, and it should be good in discovery. Right. And before we actually get into building applications, I want us to make some assumptions here. So I've indexed a bit of data. I have at least 10K objects from Wikipedia that I downloaded and indexed into my database. So I'm working with a vector database, which enables me to do everything that I'll be showing today. And I have an AI model for some of the more AI-related search. So let's get into function, right? What does function look like? So I will navigate here to Chrome. I think this should be big enough. And we have a search experience here. So we have an input field, a search, and a couple results, right? We display results. So we can't make a search yet. But essentially in function, we want to be able to run keyword search. I feel like this is the most basic search that you could do. So let's actually go do that. I have a client application here that calls an API, excuse me, on localhost. So if we go back here and we type localhost, we can see I have an API running in Hono.js. I think we got a really nice introduction to Hono.js. And so we can see that that's up and running. The next thing we want to do is actually create that route. We look at this index.ts file. And we have a couple files here that we're importing for each of the searches that we'll be exploring today. So a bit of a spoiler, hybrid vector, generative, i.e. AI search, and keyword search. We'll start out with keyword search. So we'll open this file here, search, and open this keyword folder. Now I'm doing a couple things here. The code to this will be shared in some time. And essentially what I'm doing first is interacting with a collection. I did mention that I'm indexing a bit of data from Wikipedia. And what I want to do is actually make a request. So I'll just name this response. And I'll await a query from Wikipedia. And I'll use a special query called BM25. BM25 stands for Best Match 25, which is an algorithm people use to find information with keyword matching. Right, so my first argument here will be search term. And in that, I want to actually limit things to 25. Right, I want only 25 items. Nope, let's make it smaller, only 5. So first of all, you could see that search term that's weird. Is it? That's extremely weird. Sorry, this is really small for me. Here. Okay. We'll do a bit more before we actually go on. So one thing that I also want to introduce is the types, right? So in types.ts, we have an idea of what our data looks like. And we use this vuejs TypeScript client that actually shows us different types of return objects that we can have. And this way, we have some sort of type guard here on our generative return. And if we sort of look at what this is, we have objects, and then we also have a generate object, which is optional. And so this is just to have a bit of type safety on what we're getting back. And let's actually import that. So here you see we have search response that we're importing, as well as a wiki type. I would just use generics here and say wiki. And let's, sorry. So yeah, that is true. I did not have that check. So now it is, VS Code is not screaming at us, so you could already see TypeScript is working. And let's actually go to our application. So we'll go back here. That's a bit too big. And refresh. So I want to search something. I want to search accomplished poets. Accomplished poets over Wikipedia and see what that returns. And so you can see this is our results. When we search accomplished poets, The first result is somewhat relevant, right? We get a list of accomplished poets. But then the next ones sort of start to feel quite weird, right? Polish literature, that has literally no relation, except maybe loosely through some of the people, but we have no way of knowing if they're actually accomplished, right? And so what's happening here is it's basically a keyword match. And let's go back to our slide to sort of understand this a bit better. And so that's what we mean by function. Essentially what we get is when we get all these Wikipedia articles and put them into our database or our index, we create an inverted index. And essentially what this does is it creates ranking functions that account for a distribution of various terms in specific data items or objects, and takes into account things like saturation, how many times this appears, as well as that document length. And then it ranks different things and then sends it back to us. And so essentially what we're watching was we had that search of accomplished poets, and this was the result we got back. And we basically did a keyword match and said, based off the length of this item and the number of times poets appear, this is the most relevant item. And then that's what we got sent back, right? But this isn't necessarily contextual per se. And that's the next thing we want to sort of sort through. We want our applications or our search applications to get the context of things that we're looking for. And so let's actually create a contextual application here. So back here, and we'll now dive into our second file. So I'll just copy this because it will essentially be the same thing. If we go to our keyword search, even better actually. Let's take this a step further. Let's search with an image, right? Let's do an image search because we've only been doing text. And so we'll change our algorithm. I am here from BM25 to near image. So near image, and we'll pass in the search term here, which is a base64 representation. And we'll just console log that out, which is a base64 representation of an image that we'll upload. Now, I haven't even shown you part of what's really interesting. I don't think we have that imported here. So to import, what are we importing? Search term or search response, as well as wiki, which is the type. And that's what we use. Now, really interesting, we can decide what items we want to return. And we have this property here called return, not metadata actually, return properties. Because sometimes our data has so many properties, we only want to return specific ones. And we have this help here with IDE and IntelliSense where we have a string, an array of strings. And because of those generics that we supply to that collections.get method, we have the ability to define exactly what we get back. And so I want to get back the text and the title in my response object. Now, I'll pass in response.objects. That looks good. And we'll go back into our client-side application here. Essentially, when we upload an item, we're making a post request with the base64 string of an image that we upload. And let's actually go do that. So we have search vector, and we are passing data.objects, which means I need to get rid of that just to make it a bit cleaner. Let's refresh this, and I have a picture of a Nobel Peace Prize here. That's what a Nobel Peace Prize looks like, for anyone who's asking. So I'll upload that. And immediately, because of the context that we've given our application, from uploading that image, we're able to see that our search results return text that's related to the image that we uploaded. Let's actually get into how that's possible, right? So the second item I talked about was context. We want our applications to be able to understand the context of the data that we have. Now, what this looks like is getting all the data we have and putting that through a machine learning model. And this isn't something that's new. This has been studied and researched for 10, 20 plus years, right? The idea of vector embeddings. So when you hear the term vector embeddings, this is what that means. We supply data into a machine learning model, we create these embeddings, and these embeddings are sort of a representation of what data looks like. And we put these in our vector database, which I also like to call a vector space. And this is a three-dimensional representation of that. And essentially, once we have that data inside, we take advantage of a property that objects have where similar items cluster next to each other. And I think this is something that we're all familiar with, right? Representing meaning with numbers. We use that for the RGB numbering system, right? Where 255 to 0 ranks how much of a color is in a specific, how much of red, green, and blue, rather, is in a specific color. And so that's exactly what we do with vector embeddings. So when we search accomplished poets, or when we put that image of the Nobel Peace Prize, we create a vector embedding of that, right? So an abstraction of that data, put that into our database, and then send back the most appropriate item. And in that case, that happens to be that. But sometimes this can fall short because you sort of don't always get things that are related. So if you don't have a data item, for example, you might just get something that makes zero sense, right? I think I have an image of 2 beers, for example. And the most relevant item here is tinfoil, because I actually don't have anything about beer, right? That's not necessarily relevant to me. And so here you start to see a few problems arise. And so now you want to tweak the accuracy. And this is where something like hybrid search comes in, right? It's an amalgamation of both keyword that we just saw and vector. So let's get into hybrid. We'll copy this so it's a bit quicker and paste that there. And all we have to do is change this from, oh no, we keep query, but we change near image to hybrid. And all of this stays the same. And let's actually make a hybrid query. So we'll go and change what API route we're calling here. And we'll change this to hybrid. And let's see the best of both worlds here. Oops, too many screens. Anyway, so accomplished poets. Let's see what we get back. So now that we have accomplished poets, you can start to see that we have a bit of a mix between vector and traditional keyword search. And hybrid search is very customizable. We can change how much of each search type we have, because like I said, each search application needs to be tweaked specifically for your use case, right? And so we do that with a property called alpha. And so alpha has a ranking of 0 to 1, right? Where 0 is pure vector, and then 1 is pure keyword. So if we do 0.5 of an alpha, we have a bit of both. And we'll see what happens when we say 1. And make the same query. So, wait, I did not refresh that. So you can start to see here, this is a pure hybrid, or rather semantic response. And if we change this to, if we change that to 0, that will be a pure keyword search. And paste accomplished poets. And then you see we get that old response. That's weird.
Maybe you have saved on the other one?
I think I did save, yes. It's maybe 0.1 instead of 0. That's super weird. Okay. Anyway, that's how you know it's semi-real. Okay, there we are. So we can sort of see results that were pretty similar to the results that we saw when we made a pure keyword search. So this is very customizable for you and whatever your use case is. Anyway, so just to explain a little bit into that, hybrid, like I said, gets the best of both worlds when we look at vector search and we look at keyword/PM25 search. And essentially what that does is it makes 2 searches, gets those results, and then uses a fusion algorithm. We have 2 algorithms, industry standard, reciprocal rank fusion and relative score fusion. And essentially what this does is it gives you a score for each of those, and then has its own way of finding sort of an in-between average, or sort of a median result, and then that result that it comes up with becomes your hybrid search result. And of course, these are all very tweakable. You can change all of these as you use the application, right? So we've looked at all these: function, context, accuracy. But your search now, more so than ever, is also about discovery. What new things are you able to supply to your users that they might not have known, right? And a big part of this has something to do with a technology called RAG, or / Retrieval Augmented Generation. And the idea behind this is you make a search, a really good search, a really accurate search, and then pass those responses to a large language model that can help you sort of expand that knowledge or scope of information that you might have. And a big part of what we're playing here is in the retrieval part. So we're using hybrid search or semantic search to make requests and then pass that to a language model. I'm using a language model here by a company called Cohere, and we'll actually build out what that looks like. So we have that route here, and it looks very similar to what we saw before. So again, response, and we await a query to our Wikipedia collection. And instead of a query, we have the generate namespace, which helps us choose a different type of search. Now, the first attribute should be the search term. We want to make a search. The second is a prompt. Our prompt here will be called a grouped task. And we'll actually give a prompt. Prompting is sort of the way you interact with large language models for anyone who isn't aware. Before we actually build that prompt out, I will, I think I already did that, right? Nope. So we'll set a limit here of 5. So I only want 5 objects. And so in our group task, we'll say, based off all of this, my bad. This should be here, right? So you are a primary school teacher. Which of these is the most relevant? Is the most relevant. Oops. Right, so essentially all the search results we get will be passed to a large language model, and it will be asked the question, or rather given this prompt, and then it has the job of giving us a response with the hope of us discovering something new about our data. We return our response, and very important, we go to our client application, and here, instead of serving our result as is, we'll also, let's do this. We'll have a little p tag that sort of shows the result. Oops. The result dot generated, because we want to see what comes. So are we covering everything? Okay, let's see. Results, my bad. Okay, perfect. So let's run our query. Wrong direction. Okay, so what do we want to search for? Accomplished poets again? Let's see what Wikipedia has to say about this. And I don't think we changed the URL we were calling, so we need to change that to generate. Okay, and now we have a search term, and we're calling the right API. Okay, let's go. And let's see what we get back. Doop, doop, doop. This query takes a bit more time because there's the back and forth between the request to the large language model. Oh, undefined, okay. So, generate, and we're returning response. Let's make this easier and not generate any of the results here, and just have results dot generated. Okay. And double check we have our response. And when we, no, for the sake of time, because I'm super close to my limit, I will do the thing and console log it. So let's rerun that. Where are we? Doop, doop, doop. And then where do we see it? Somewhere here, actually. Yeah, okay. As a primary school teacher, the most relevant topic from the options provided would be Yale series of young poets, blah, 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 blah. Essentially, we've discovered something new about this Yale series of young poets based off those search results that we got, and still undefined. Okay, anyway, so that is discovery. And also, just, did you notice the TypeScript? Probably not. But it was helping us as we were building that out in times where we didn't know what we're looking for, generated when we didn't know the properties, and also just the inference that was happening. Ideally, because the goal of this demo also was your search application should be as minimal as possible, and you don't need huge frameworks to make these things work, right? I have numerous applications in the resources that I'll be sharing where you have type safety between the back end and the front end with validation on your queries or on your bodies for post requests and things like that. But like I said, it was very intentional. This was built with vanilla JS, CSS, JavaScript to see what a sort of modern search experience can look like. And so just to recap really quickly, you can make your search really functional. I think that's the bare minimum with something like keyword search. And you should use something like vector search to give this more context and expand the modalities that you can give your users in their search experiences. And you can improve your accuracy with something like keyword search and, with something like hybrid search. And you can try out discoverability with tools like AI search. And of course, be safe as you do all of that. Be type safe. Thank you very much. I have a couple of resources, so if you liked any of the applications that you saw, or you found any of this interesting, you can check them out, as well as other stacks that have everything set up so you can create JavaScript experiences, JavaScript search experiences. So thank you very much. I'm Daniel, and you can find me anywhere online as Malgamves.
I enjoyed it. It was good. Thank you, Daniel. I have only 2 words to say. Coffee break. Let's go. See you in half an hour.
Creed or the culture now. forward, non-stop. We have a beaten path before us. It was all there in plain sight. Come on, people, we have all seen the signs, so we may never get back to the old school, to the old grounds. It's all about the newfound. We are the newborn. The world know all about us. We are the future, and we're here today. We come a long way since that day, and we will never look back at the faded silhouette. We come a long way since that day, and we will never look back at the faded silhouette. Straight ahead on the path we have before us. Day by day, soon the change will come. Don't you know we took a big step forward? Just lead the way and we pull the trigger, and we will never get back to the old school, to the old grounds. It's all about the newfound. We are the newborn. The world know all about us. We are the future, and we're here today. We come along since that day, and we will never look back at the faded silhouette. We come a long way since that day, We come a long way since that day, and we will never look back at the faded silhouette. We come a long way since that day, and we will never look back at the faded silhouette.
just wants to know that you're well. Oh, in this world, it's just us. You know it's not world, it's just us. You know it's not the same as it was, as it was, as it was. We know it's not the same. Get headlines, feed internet. I don't wanna talk about the way that it was. Leave America to kids follow her. I don't wanna talk about us doing it first. As it was, you know it's not the same as it was, as it was, as it was.
Yeah, let's go. Okay, welcome back.
Hello, hello everybody. Welcome back after this break.
So this is the last segment before, well, with the last talks of the day.
And before we start with our next talk, I would like to announce a sponsor giveaway prize from the Progress booth. We have a winner for the VR.
Wait. Woo, woo, woo! Yes, thank you. More. We have a winner, people. We have a winner.
Yes, I hope he's still here. We have Victor Ruzdenia. So, Victor, please come by the Progress booth to get your prize. It's waiting for you.
Do we have a Victor? I see someone coming. Congrats, man.
Congrats.
Come on, more. Victor, yes.
I will give you high five, and your prize is waiting you at the Progress booth.
Yes, but maybe we can take a picture together. Could we maybe have the light on the audience, if that's possible, for a quick second?
Yes,
to take
we would
a
like a
picture with the
selfie.
winner?
And Jos, come for a selfie with us, please.
Yes,
come on
Jos,
stage. Yes, welcome Jos, one of our organizers.
Jos Gerards. Take a picture. Let's do it. Are you ready? Smile.
I will need some one tower, guys. Sorry.
Woohoo!
Yeah.
Awesome. Thank you, everyone.
Thank you very
Congrats, Victor. So what's happening?
We have a couple of more speakers.
Sounds good to me.
And then we are ready to start Unforgettable Night.
Yes, exactly. We have, I think, a JavaScript game night.
We do, actually, yeah. All right, everyone. I won't take too much of your time. I just wanted to pay gratitude for all of you being here, for making this an incredible 3 days again. We've been doing this for a while, like I said before already, but it amazes me every year that we can fill up this theater with like-minded people, with people that come here with the same mindset, and that just want to bond and have a great time all together. So first of all, give a big applause to yourself, please. Next to that, obviously, without sponsors, without speakers, none of this will be possible. So, sorry, one more time. Applause for the sponsors and the speakers as well. Thank you. And I also want to give a big thank you. She's always standing on the sideline. She never wants to come on stage, but I'm going to do it now for the first time anyway. Nikki, can you come on stage?
Come on!
Nikki is a very important part of the team here. She's been working with us for many, many years. This year she decided to start for herself. She's freelancing at the moment. So big congratulations to you, Nikki. She always does an amazing job. Everything that you see here in the theater, when it comes to screens, when it comes to live stream, all those kind of things, actually a big part of the organization, that's all on Nikki. So I just wanted to say a special thank you to Nikki for this, and after that I'll leave you alone. All right, please have a great time. We see you at the JavaScript game show, and enjoy the last 3 talks, I think it is. Yes. All right, have a great time.
Thank you, Jos.
Thank you. So, okay, folks, we are ready to continue, and I want to present you our next speaker, who is the next generation of the future developers, and they're going to be so awesome.
Look at that,
and
would you look at that?
Yes, they're coming on stage. And the wonderful family of Debbie, who is going to show you some Playwright tricks.
Say hi, everyone. Say hiya. Hiya. Say hiya. Okay, everyone, this is the front-end developer, and here's the back-end developer. There you go.
I'm taking that baby.
Thank you. Big round of applause for Mark and Logan. So, how are you all doing? Good afternoon, everyone. How are you going? You good? Yes. It is so good to be back. As you've seen, I have been busy in the last year and a half, so you haven't seen much of me. Now you understand why. But it's so great to be back on the stage, back giving talks. And the reason why I brought my babies is because I can't just leave my husband alone with 2 babies. That would be a nightmare for a couple of days. But also because I want to show other women speakers that you can still be a speaker and a mother. You can still come to conferences. This conference has been really amazing in just like no problem in bringing babies and in giving, you know, my husband a pass to come in and just making it possible. And I want more conferences to make it possible because we need more female speakers. So thank you. So let's get down to business, because otherwise my time will run out. So for those of you that do not know me, my name is Debbie O'Brien. I'm a Principal Technical PM at Microsoft, and I'm all those other things, and I used to do loads of sport, and now my favorite sport is chasing the twins around the house. We're here to talk about something really important. It's 2025, and none of you are coding. Yes, they're all getting the AI to code. Am I right? Yes, come on, be honest. I mean, it's totally fine. I actually use the AI a lot to code myself. I'm using agent mode in VS Code. If you're using VS Code Insiders, it's experimental, and you can just put agent mode down here. Let me press a button for you and watch this video. This is how I code these days. I basically say pre-populate the form with some fields, and it just goes bang, HTML, done, excellent, yes, done. And I look at the change, it looks pretty good, so I can basically decide, do I want to keep that? I can press the keep button and I get this beautiful form in seconds. Oh my God, why would we code these days, right? And because I'm using agent mode, the agent says, well, you know, I need to add some styles and make it beautiful. So it goes ahead and does that for me. And then I can just basically say to it, you know, can you put the button under the form instead of the side by side? And I can just continuously tell it what I want it to do, and it will continuously iterate over the code and add those kind of things. And this is really, really cool. This is basically how I'm making all my demos these days. It makes my life much easier. It's much quicker. Like, can you improve the button colors? Look at that prompt. Amazing. What does AI know about how to improve the button colors? Well, the colors that I choose are going to be terrible. So anything is an improvement, and it can just go along and do the CSS, just generate those CSS classes in a second. I don't have to think about it. I don't have to write the code. And this is the future. My sons are going to be coding like this. It's just the way it is, right? Now, the problem is with this, and this is great, and I love AI, and I think this is how we are going to continuously build things going forward. But obviously, the problem is that not everything is going to be perfect. And we're going to really now rely more than ever on software testing. Because if you're not going to write the code, who's going to test the code? Who's going to make sure the code is all right? Are we just going to ship the code? Because, I mean, I just ship the demos and it's all fine, but you're working in the real world, right? Are you just shipping the code that AI wrote for you? Or are you actually testing it? Who is testing every single part of the code they write? Okay, that was 7 people out of 1,000, right? So well done, you 7 people. The rest of you are here for a reason to watch this talk, so well done. So I want to talk a little bit about testing, and obviously I work for Playwright, so I'm going to tell you Playwright is the best testing tool out there, and you should all be using Playwright. Are you all using Playwright? Amazing, I love you all. Okay, so for those that are using Playwright, well done. I'm going to show you some things that maybe you don't know about Playwright. For those that are new to Playwright, this is some tips that you can take away with, and if you don't know how it works, you can still follow along, so don't worry too much. Now, what happens when your test fails? Anyone have a test fail and then they just delete the test? Yeah, I know. I was about to do that last night as well. And I was like, I'm just going to delete the test and then I can merge the PR and go to bed. And I was like, no, Deb, you can't do that. You're the person that tells people not to do that. So I didn't delete the test and I didn't merge the PR. But what happens when we get this error, right? We need to fix this. And you can look at this and we might be able to easily understand the error and fix it, and we might not. So we get our friend, the old rubber duck, and we say, how do we fix this error? And the rubber duck doesn't talk back. Rubber ducks have been made redundant. They have no job anymore. We now got this guy. We can call him Gemini, or we can call him Claude, or we can call him Copilot, whatever we want. But we've all got this guy now coding with us these days. So we can say to the AI, you say, can you fix the test for me, right? Now we've got to think of the prompt. Is that enough? Can you fix the test? Can the AI fix the test if you don't give it enough information? Maybe, maybe not. And there's really bad AI prompts, and there's really good AI prompts, and we now are becoming prompt engineers. Like, look at this one. Turn the person into a cat. That's what I'd write. Like, simple and straight, just get a job done. But a good AI prompt was to turn the subject in the photo into a cute tabby cat with brown and black fur on a watercolor-style painting, include starry night sky behind the subject, right? Nobody's going to do that. They're just going to write, turn the person into a cat, bang, done, gone. And the same with testing. Right? We need to give proper instructions to the AI to help us debug those tests. So this is the kind of instruction that you want to give the AI. You want to say, following the Playwright test failed, explain why, use Playwright's best practices. Right? I want to make sure we're using the right locators, etc. The test info, this is the name of the test. Here's the error details. This is what failed. So give it that whole error message. Then the page snapshot. You want to give it a page snapshot so it basically has an idea of the HTML of the page that it's trying to fix, the one that it's actually going to test against. So you're giving it that snapshot. Then you're giving it the whole test source. You're saying, here's all my test code. Right? I want you to find the error. And then I want you to also take the git diff, because maybe I just messed something up in the last git change. That's the prompt you want to give the AI. You give it that prompt, you're pretty much going to get a really good answer to why your test failed and be able to fix it. Any of you going to write a prompt like this? No, one person. Well done, you. You have nothing more to do in your life when you write prompts. Well done. Okay, nobody's going to write that except me, but don't worry, because we've done it all for you. We basically included in Playwright that information into a copy prompt button when you run your tests in UI mode. So this is in the latest release. You basically run your test in UI mode, your test fails, and you press copy prompt, and you're going to get that prompt that I just showed you, but obviously with your test failure, with your test code and source code, etc. Do you think this will be helpful? You're not sure? All right, okay, let me convince you. Don't worry. You've got to see it in action. Right, so you want to copy the prompt. What you do with the copy prompt button, you paste it into your AI provider. Whatever AI you're using, and you can use Google Gemini, you can use Cloud, you can use ChatGPT. I'm using GitHub Copilot, because I actually only found out about this the other day. Did you know about this? You just go to github.com/copilot. It's really cool. Yeah. And then you can basically just paste from that copy prompt. So I showed you all that prompt, and I can go along and check the model. I'm going to use the O3 Mini, but I could use whatever I want. Press Enter. There's all that prompt that I just showed you. And what does Copilot say? Well, it gives me basically a reason why the test failed, right? The test fails because the executed, the order, and the checkbox function does not match the actual order. And it goes through and explains. It's really good to kind of read through this as well, understand what the error message is. And below is a fixed version of the check buttons that reflects the actual order. And then I can basically just copy that snippet. I can go to, I'm using VS Code, with your favorite code editor, and just paste in here the fix. And then obviously run the tests, run them all, make sure it works. And there you go. AI just fixed my test. What do you think of that? Good. Excited. Try it out. It's probably not perfect. We've just literally released it. So we're looking for feedback on, is it useful? What's missing from it? How can we make it better? How can we improve that experience? But for now, that's how we're kind of trying to help you debug your tests and not throw your tests in the bin, but help you debug your tests with the help of AI. So that's our AI story so far. But do let us know how it goes. So let's move away from AI for a second. Well, first of all, if you do want to use this, you need to use in the Playwright config, actually add capture git info diff true into your config to be able to get the diff info. So now you've fixed that out on your local machine, everything's working, and then you come along and you go to CI and your tests runs and the tests failed. Isn't that super annoying when tests fail on CI? And what happens on CI? You don't have that copy prompt button. Well, actually, you do, because you can literally come along into your artifacts, and then you've got the Playwright report, and you can download the Playwright report, and then basically you can just open that Playwright report locally, and you have that same failed test. You can go in there, and you've got that exact same information I just showed you in local in UI mode, now in your HTML report, and you've got that copy prompt button, and you can now take that copy prompt and open whatever AI provider you want, paste in there, and you can even, if you're like a team lead, you can just say to the developer, hey developer, you need to fix your test, here's your fix. And then you can do this on a train, you can do it like from wherever, right? So it does make it a little bit easier in debugging. So what happens, like I said, if your tests are failing on CI, and now you're like, oh, they're failing on CI, they work locally, it's head-wrecking, I hate it, it kills me. It's normally race conditions, right? And how do we fix something like this? Well, we've got to debug it a little bit, and we've got to figure out what's going on. And the best way to do that is to basically run the tests as many times as possible. So we can do this locally. You can put in --repeat each equals 100. So take that test that's failing and make it run and repeat 100 times, and then you're going to see if there's any race conditions. If it passes 100 times, pretty much it's going to pass on CI. Maybe not, but normally 100 is pretty good. But if it's failing, like sometimes it might fail on number 19, and you're like, why? And that's generally race conditions. Could be missing a weight, could be anything, right? You can also stress out your computer even more by setting workers 10. Just 10 is a number. You could put 20, you could put 5, whatever. And -x just means fail straight away, because you might not want to wait for 100 to see what's going on. If it fails, you want to figure out what's going on. So that's just some tips to kind of help you reproduce test failures when they come from CI. And that's just it in action. Of how you do it, and you can see it's running those tests, and because Playwright runs really fast, it's going to run them pretty fast, so you don't have to worry too much, but you can also stress like which project you want. If you only want it to run on Chromium, and then like you don't have to run all of them, and then maybe you could run the WebKit, etc. So again, just some tips to help make things easier. Okay, iframes and Shadow DOM. Anyone working with iframes or Shadow DOM? A good few of you. Okay, did you watch Natalia and Igor's talk on web fragments? Yes. So you're probably thinking, oh my God, but how do we test those kind of things? Well, you can also test that in Playwright. It just works, right? So testing iframes, you've got a frame locator, and then you basically can get the iframe by its class, or by the name attribute, or by the URL, and you can test your iframes. You can also test Shadow DOM or web fragments, and basically Natalia's repo that she just showed you from that talk, they have all those tests are already written in there. I was going to steal them, but I didn't have time, so I just telling you that it works, but it actually does. You could check out her repo. And you can just locate them in the same way as you would as if the Shadow DOM was not there. It just works, so it's really cool. Okay, let's talk a little bit about WebSockets. Were any of you here yesterday, and did you watch Daniel's talk? Anyone watched Daniel's talk yesterday, yeah? So annoying, all those emojis coming up on the screen. I was like, oh my God, Daniel, stop, turn it off, turn it off. Absolutely ridiculous, very cool. So Daniel and then Sebastian copied him as well, and what Daniel created was this. So anyone who wasn't here, they had this, like you go to the website, you click the button, and all these emojis come up, and he just had it going through the whole talk, right? So Daniel created this, Sebastian created this, and then I said to them later, I said, are you testing your WebSockets? And they're like, how do we test WebSockets? I'm like, well, Playwright, duh. Right, so yeah, I know. So I basically went and wrote the tests for them. So this is the test for the WebSocket. So first of all, let's just test Daniel's website. And it's very simple. You get the by the role button, you name, obviously the reaction, the emoji, you click it, and then you expect, he's just using, I have to use a CSS locator here, which shouldn't do, but he didn't have a test ID in there. He didn't have a very good role in there either, so I had to just use CSS, that's why. So that's Daniel, needs to fix that. And basically, you can make sure that that is visible on the page. And then you can go along and you can mock. I can mock Daniel's WebSocket, and I can say, right, I want to mock it, so I'm not actually touching the WebSocket, I'm just mocking it, and I'm sending 4 fire emojis. So that's like testing all your emojis that you're putting in, and then another one, and then I'm just going to his website, and I'm making sure that they are visible on the page, and that one has a 4, the count of 4 is there. And then I can do something even cooler. I can actually intercept his WebSocket, and I can add a Playwright emoji. So I can basically say, go connect to the server, and then if someone clicks on the emoji with the bang head, send the Playwright emoji instead. And then I can go and make sure that that works. So here is me running those tests to make sure, just to prove to you that this works, because I know you don't believe me. And here you go. There's the first test. This is in UI mode, and I can go through each test step there and basically show you how I tested Daniel's emoji. And they're visible on the page. And you can see how Playwright waits for it to be visible, even though it's moving on the page, right? That's something Playwright does out of the box. This is the mocked one. My 4 flames are coming up, and my, I don't know what you call this, the head, the crazy. And you expect that to have the count, and then the intercepted one, right? So let's see if this works. I'm intercepting it. You can see there's no Playwright emoji in Daniel's website, but I can basically go along, click that button, and the Playwright emoji comes up. Isn't that cool? Is that cool? No? Come on, come on. So that's testing WebSockets. So you can totally test WebSockets. This is pretty new, so make sure you've updated to the latest version to get all this. So if you haven't seen this in the past, it's because they've come in some new releases. So a couple of tips. Like I said before, auto-waiting. We've seen like how Playwright will wait for that to come up onto the page and that it's there. You don't have to add timeouts. It just works, auto-waiting. But make sure you're using, and it retries until it's actually there. But make sure you're using the actual right locators and you're prioritizing user-facing attributes. So not using the CSS locators like in Daniel's app. You want to use good locators. You want your HTML to be good. So get by role button, for example. Use test IDs if you want to. And also make sure you're using Playwright's assertions. So they also auto-retry. So don't, for example, use a non-Playwright assertion, because then you'll have race conditions and some problems. I created a video recently about it. It's really important to use the Playwright built-in assertions. Await at the start, really important to not forget the await. If you just write that without the await, the test might pass, and then it might fail, and then it might pass, and you're going to have your head wrecked, and you'll be doing that repeat each 100 to try and figure out what it is, and it's all because of a missing await. So don't forget your await. Playwright is async await, so that's why there's an await. Cool. Match only visible elements. This is like a kind of tip, right? You might have come across a situation where you have 2 buttons and one is hidden. There's a display none for whatever reason. It could be in a hidden menu. It could be in something. And when you're running your tests, some of your tests might fail and you can't figure out what's going on. So what happens is that Playwright, when you use a locator such as getByText, it's going to find every single locator in the HTML. So it's going to find 2. It gives you the strict mode violation, and it's basically saying, right, I don't know which one you want me to click. So it doesn't know, and then you kind of have to try and figure out what's going on, and you're looking at your app, and you're like, I'm only seeing 1 button, but there's actually 2. But if you change and you have get by role button, right, with the name submit, and you run that test passes, and now your head's wrecked. And now you're like, oh my God, what's going on here? So get by role actually has this like filtering of visibility already included, so it's only going to filter what's visible. Get by role is looking for something that's on the page that the screen readers are going to read out, so it's not going to read out something that's hidden. So basically, if you're going to use get by text and you want to only show visible things, you can do .filter visible true, and then it can make it work the same as get by role, and then you're only going to see, or you're going to test what is visible on the page. So again, that's in the latest release of Playwright. So if you ever had those problems and you were trying to solve them, that's how you would solve those. So that's basically how you do that, filter visible true. Cool. Better accessibility testing with snapshots. You've seen a couple of bits of snapshot testing. Is anyone doing snapshot testing? Yes, cool. What do you think of it? Yeah, oh my God. Let's go to the person behind you, yeah? It's great, that's the answer. So this is what snapshot testing is. It's giving you an accessible tree, the snapshot of the accessible tree of your website. So basically here I've got the banner of the website, and the heading is Playwright enables reliable end-to-end testing with a level 1. It's got a link at start. It's got 3 links in there. It might look like a button, but it's actually a link, and it's accessible-wise, it's a link. So as you're testing out on the accessible snapshot, this is what you're getting. Now we can generate all this for you, so you don't have to, you can use CodeGen to generate, so you don't have to go in and try and figure out what it is. So we run this test, it passes obviously because I just generated it with CodeGen. But what happens if we were to go and modify something in the HTML? So I can open up the website locally. And normally what happens is, right, you've got a developer comes in and they go and start modifying the code, and then you've got, these issues and your tests fail and you don't know why. And what's really good with the snapshot testing is it's very like looking always at all the stuff that's important, like your H1, right? The H1 is important. It might not be important to you, but it's very important to a screen reader, whether it's a H1 or a H2. So if someone changes that H1 to H2, visibly on this page, the way the classes are written, nobody could notice the difference. So you would visually, it looks the same. And you might like look at the preview and say, yeah, that works. And then you run your test, and your test is going to pass because it's basically saying, I'm looking for level 1, and you've given me level 2. So that's basically two-match snapshot, and you can basically put in the whole page if you want to, or you can just take out a small section and just test that specific section. And it saves you having to kind of go through each one and put like to have text, expect this one to have text, expect this one to have, etc. So it's kind of a little bit easier to maintain, in my opinion, but do check it out. And if you add something to the HTML and then you go ahead and run that test, will the test pass or fail if you add something to the HTML and then go ahead and run the test? It will fail. You don't know. Well, here's like get started, and here's learn Playwright. I've added an extra button into the HTML, and I'm going along my test. I'm not touching my test. I'm just pressing play, and the test passes. You're like, but you just modified the HTML. Because it doesn't matter if you add more stuff to the HTML. I wanted to test that that is there. That's what's important to me. Okay, so you don't have to test every single thing in the page. You can, but you don't have to. The order does matter, though. So if you change the order of the page and change the buttons around, then the test will fail because that order is important to the accessibility, etc. So that's basically the snapshot testing. And you can easily update the snapshot. So right, if you're having like, oh my God, well, what if something I do change things? You just do npx playwright test -- update snapshots equals changed -- update source method equals 3-way if you want to go through each one or patch. Or you can just do like override and just override everything because maybe you had a whole redesign. So there's ways to easily update them. So you don't have to worry too much. And then you can store snapshots in a separate YAML file as well. So in case you had so much like of this snapshot testing, and it's like messing up your whole test and looking like way too long, you can just shove it into a YAML file, and then you just like can refer to that as well. So that's kind of nice and neat and tidy. Cool. You still following? Yes. Good. Are you learning something? Yes. Good. Amazing. Annotations. Any of you using annotations? No. Oh my God. See, good. You're learning something. This is great. So you can write annotations which go into your HTML reports. You could actually put your issues, so a link to your GitHub issues, for example, or to related issues, and put that in an annotation. Very simple. You just put in annotation and array and put in some objects, type, issues, description, whatever you want, and that will show up in your HTML reports. And you can also use things like fix me, and when you're creating your test, you're not finished it, you can put test.fixme, you can test.skip. So these are called annotations as well. And you'll then see, like in the UI mode, it shows that little circle thing for the fix me tests, and the annotation says fix me, so you can go along and you can kind of check on those. And there's loads of other things that you can do along there. You can add anything you want into annotations. It's really cool. Okay, test steps. Any of you using test steps? Yes, a couple of you, great. So we had some extra additions to test steps. For those of you who don't know what a test step is, it's just a way of extracting some of your test into a step. So it's easier and looks nicer, especially in the HTML report or in the UI mode, and it just kind of like puts it into one area, and you can box now steps, you can add attachments to steps, and you can now skip tests, and you can also add timeout to steps as well, so that's kind of something new we added. In the HTML report, it would look something like this, and then you can just like, open and close it, and it just keeps it neater and tidier. That's all. It just makes it better in a way. Last failed. So if you're running tests on the CI in the CLI, you can basically just run your tests, and then you can basically come along and go npx playwright test -- last failed to run only the last failed test, and that makes it a lot quicker. And then you can run only changed as well, which you can basically just go only run the tests that have changed since the last commit or since the current branch. And I think I'm running out of time, so we are going to basically just tell you one more thing. Anyone sharding tests? sharding just works. So you can basically just run on CI. You can shard your tests across multiple machines. Check out the docs. I'm not going to show you an example. Just go to the docs, copy, paste, put it in, and then you can just merge reports and have it all in the same report. So that's basically all I covered. There's so much more to Playwright. What I wanted to show you was that there's so many cool things. You should all be testing your applications. Do check out our latest release, update the latest version, and make sure you're testing. And I really want to just say Playwright's open source and free. If you're not using it, please use it. If you are using it, give us the feedback and let us know how things are going and what you need, what you're missing, and how we can make it better. Thank you very much, everybody, and I hope you enjoy the rest of the talks.
Thank you, David. Thank you very much. Did you guys enjoy David's talk? Yes, that's right. You are amazing and can't wait.
Are you testing your apps?
Yes, of course. Always testing. Always testing. Safety first.
Oh, the cable. I was going to take the cable with me. I want the cable.
And next year, I hope we see those baby of yours giving us AI talks on the next year on this same.
Yes, for sure. Probably. Who
yes,
knows?
they
AI
will.
might just be giving the talk. We might not be here in person.
Yeah,
no, I hope not.
Yes, maybe yes. Thank you, Debbie. Thank you very much.
Thank you.
Let's give it to Debbie. Okay, guys, so the next speaker up on stage is the lovely Pratim Buzel, and she will tell us about lesson learns. Sorry, I cannot say. Lesson learned from observing a billion API calls. So let's give it for Pratim.
Oh, perfect. It's out there. Hello, everyone. I am Pratim Bhosle, and I am super grateful and glad to be here today. I just moved to the city of Amsterdam. I now get to call this beautiful city my home. Super grateful for that again. And today, I am here to share the lessons that I have learned after observing a billion API requests, what I learned, what are some things that I have decided to do better. So let's get started. But before that, a little bit about me. A few things that I like. I like to cook. I like to travel. I like to do things that monkeys do. I like to climb. I like to work out. And yeah, I recently got married. So I'm pretty... And my husband is somewhere there. He's on recording duty. So yeah, that's all about me. And I work as a developer experience engineer with a company named Treble. I am also a Go GDE. I'm majorly a backend developer, and I use Go as my main language. I know you must be curious, what am I doing here? Overall, my areas of interest are APIs, systems, and databases. That's my thing. That's where I find my best groove at. Again, you must be wondering what I'm doing here. A little bit about my company. So Treble basically helps organizations figure out their APIs, be it observability, be it documentation, be it making sure that there are no errors in your APIs. If you have a public-facing API or if you have internal APIs, everything around APIs is something that Treble takes care of. And finally, so I recently joined the company, and the first thing that I did when I joined a company was write a report. And I was like, OK, this is pretty boring. I am a developer. Why am I writing a report? So it ended up not being a normal report where you're writing how I spent my day. It was an API report, which interestingly involved a lot of database queries. Now, this is where I found it fun, because I had to query a lot of data, figure out what was the results. And I have added a QR code if people are interested in this report. But the report majorly revolves around 4 major pillars, which I think you will all find interesting. The first pillar is API security. The second pillar is API performance. The third pillar is API design. And the fourth pillar is API industry as a whole. So based on this report, we learned a few things. And these data points is what made us question how we all are building APIs as a community. So I'm not going to talk about more details about the report, but the key findings from the report were that most of the big enterprise companies that we are looking at, they have a minimum of 100 APIs that they have on production or internally or externally. And half of these APIs are not tracked. They are a complete mess. It's funny, I was sitting up top on the coffee table, and I was chatting with someone, and I'm like, oh, so how does your API infrastructure look? And the first thing that he mentioned was, oh, they're a mess. So we think, and I don't think having your APIs as a mess is a problem. It's not me, it's you. It's not that kind of an issue. But enterprises, half of the enterprise APIs are not secure. They are not well documented. This was one of the major key findings from the report. I will come to a point where we'll say how am I making these claims. But before that, let's go through more claims. So the whole and sole reason why a Go developer is here talking at a JavaScript conference is because this Go developer learned that JavaScript-based APIs scored lower than average on an API score that we have built, and overall, we studied all APIs based on. I know there are a lot of frameworks, and there are different ways you can do a single thing in JavaScript. And this is where the whole area of why JavaScript APIs must be scoring lower might come up. But for you to understand, for us to understand better what does scoring lower than average mean, we'll go ahead and look what score we are talking about. But yeah, one of the last findings from this report was overall, no matter what framework, what language we are talking about, APIs overall have a low bar for security. And this itself is a very concerning thing, because we're now talking about LLMs. We're talking about new applications being built on LLMs. Twitter is going crazy with this MCP stuff now. But the point is, when we say, oh, I built an AI tool, no. We built an API that connects with an AI tool, and that's with an LLM, and that's how we probably are building AI tools. So everything, all communication currently, when it even comes to LLMs, is happening via APIs. So API security is something that should be of utmost importance to us right now. But unfortunately, because at least in the RESTful world, there are still no standardizations around what is the best way to write an API, what are some basic things that you shouldn't do. We're still here, even though the concept and technology of APIs is very old. We're still at a point where the bar for security is pretty low. And yeah, the final takeaway was APIs are no longer like CRUD, or they're not simple. They are extremely complex. We also had this data point where a single API has a minimum of 70 endpoints at a time. So they are complex. They're getting bigger and bigger. We're finding different ways to query data, we are coming up with different protocols as well. So the moral of the story, or the moral of this whole report, was the fact that APIs are everywhere, and we can't run away from them. This is, no matter what latest AI technology we are there, no matter how LLMs talk to your website, no matter if you don't even need to build a SaaS tomorrow, like APIs are there to stay for a very, very long time, and we need to make sure that we're building them in a better way. Even if it's not standardized, we can do better. So all this data points, like all these things, how did I come across? Like, it's not based on feelings. It's not because I thought, oh, I think this might be an interesting data point to share with the whole conference. It is based on processing more than 2.8 billion requests per month, which is what we do at Treble. And this data is based on what we have learned from the existing SDKs that Treble supports. And yeah, so the point is, none of this data is coming from anything not tracked or something that's out of the industry. This is what we're seeing right now. So coming back to the point, how did we compare and match all of these data points? So we came up with this concept known as an API score. A lot of different, there are a lot of different products and a lot of different other industry standards that also have their own definition of API score. And you can think of an API score as an API report, maybe, like when your teachers, after you're done with your exams, you have a report card, and like you figure out, okay, you've done well on this point, this point, this point, but you've not done well in this domain. That's literally the same thing when you're talking about APIs. And because we are, like, APIs is spread across so many industries and is such a common ground right now, that's why we can come up with some standardization, some understanding of, okay, like, these are the industries they are doing it who have historically done better, so we can learn from them. I want to bring up a very random data point again. Can you guess which is the industry that writes the most well-designed APIs or builds the most well-designed APIs? Can someone from the audience just like scream it out? Like, what do you guess? To my surprise, it's actually the management consulting industry that writes the most that builds the most well-designed APIs. Well, you can read more about that in the report, but coming back to the major areas of this API score. So the first thing that defines if you would have a better API score, the first building pillar of this is design. Now, when we talk about an API, there are multiple ways you can write your requests. There are multiple ways you can name your endpoints. There are multiple ways, there are different protocols you could use. But it all comes to the point that there needs to be a few things that make sure when you're using probably if you're using an API gateway, or if your API is public for other developers to use, it has a consistent naming format. Now, this isn't a rule written in some rule book, but this is something that will probably save time for the development team in future, where a /users is consistently named /users and not some people, because it's a GET request, name it GET user, and because when it's a post, it's post users or something like that. Consistent naming is something that has been seen to help save development time and overall reduce the complexity around APIs. Next one, which is very, very common, but a lot of developing new products forget, is rate limiting. Now, you have rate limiting offered by a lot of API gateways directly, but there is always, you can do still more on an API, in the API code as well, where you can add some more logic around rate limiting. This makes sure that you don't wake up one day and be like, oh my God, like I got attacked, or like, oh my God, why is my API getting hammered? And finally, some structure around versioning and errors is something that could help figure out building a more stronger and a simple way of design, but something which is consistent across all your API landscape. Now, the next pillar of the API score sits on performance. What do I mean by API performance? So now, how fast does your API respond to your errors, or like how fast does it take to process? how big is the amount of data that you're transferring with your APIs? That's one thing to think about. And then finally is like, how many requests? Like the most common one is like, how many requests do you have per minute? These factors then come up to build performance as a pillar for your APIs. So when somebody says, like, how's the performance on your APIs, the first thing that you think about is, OK, how many requests can it handle? What is the kind of data it's handling? And yeah, speed is what we all connect with performance. Now, the most important, according to me, the aspect for this whole API scoring system is security. Now, under security, the most common ones are auth, then what protocol you're using, and again, like, are you putting in rate limits wherever they are needed? So there are different ways to handle security. If you don't want to have to build it in, you don't want to have it inbuilt, you would probably go with a BAS, or you would basically have a framework that does everything for you, and it comes with its own batteries inbuilt, and you don't have to do anything like internally, or you don't have to set up your own auth. So there are different ways to go about security. You choose which is the most favorable way of doing it for your product, for your company, and for your development team. And the last pillar that is very specific to Treble and is very specific to something that we work on as a product is AI readiness. Now, this is a work in progress parameter of scoring an API. But now that we are seeing more LLMs consistently talking to directly APIs, how do we make sure that our APIs are more available there for LLMs to just fetch data faster? How is it making performance better? So it comes out to literally 4 things. One being, are you describing your parameters? Are you having better documentation for your APIs? And what kind of, basically, we all have this thing known as LLM.text now. This is something that could possibly in the future be another metric that could be used for API scoring. But currently, AI readiness is a work in progress metric. So this isn't something that if you don't have anything to do with LLM scraping, which is very rare, everyone's going to have LLMs scrape for their data. Now we come to the crux of the talk. So when we study different SDKs and different APIs, the score that we saw told us one thing, that the JS APIs, the APIs that were built using JS frameworks, were falling behind. Now, what do I mean by they were falling behind? We all know, like, Node.js as a platform is a single-threaded, and we even saw in like last previous talk that when it comes to performance, Node.js has bottlenecks, and there can be problems with scaling. So is this also something related to why APIs are falling back? But what do I mean by falling back? So I think this would probably make it more clear. So the report, based on the 2.8 billion requests, API requests coming from different languages and frameworks, shows that some of the JS frameworks have done comparatively bad when it comes to being the most, I wouldn't say secure, but being the most well-written API. And specifically talking about numbers, so when rated over 100, Express and Fastify, they had a score of 38 and 39. That's how low JS frameworks overall scored. And they overall had like poor standards for design, performance, security, and AI readiness that we are now seeing. We can blame the grapes and say that, oh, the grapes are sour. Or we can actually think of this, is this a problem, an education-based problem for the framework, or is this an education-based problem for the JavaScript as a complete community? Now, I know I might be comparing apples and oranges together, as someone recently reminded me. But let's see how other frameworks and languages have done. So in the report, according to the report and on the data based, Laravel was the one that consistently has shown to build the best APIs, the most design-proof APIs. And when you compare, for example, Express and Laravel, what is the thing that's making them different? Like, the fact that Laravel is more structured, and of course, it is very opinionated. Like, you have a set rule, a set way of doing things, and then it comes with its own built-in tooling for probably caching and ORM and overall security. Is this why it's easier to build better APIs, or it's easier to write better APIs in Laravel? Or is this tooling not available in some JavaScript frameworks is the reason why probably not all APIs should be written in JavaScript frameworks? Or probably you should have a more stricter hand when you're writing APIs? I mean, these are all open-ended questions. One thing for sure, I am not an expert in JavaScript, so probably you folks know more about writing APIs. But the basic problem is, to do a single thing, there are multiple ways available. Like, if I want to write a single router, I can do it in 10 different ways, and I can find different frameworks. I can find different libraries instead to just do a single thing of sending requests, probably. OK, so the one anomaly that we saw, and which was very surprising, was Adonis.js. How many of y'all here use Adonis.js? I see 1, 2, very few hands. Interesting. Adonis.js actually stood out of all JS frameworks to have an extremely good score, literally next to Laravel and other languages. But Adonis.js was one which had a score of 58. Now, on an average, no matter what language you build an API, APIs are still written in a lot of slop code. So average score for all of them was around 60. So Adonis.js performed really well when it was written. And then when we go back and understand why, why would this be? If most of the JS frameworks are scoring lower, why is it Adonis.js is scoring better? Turns out it is because of the same fact that it has Laravel vibes. It is built on the same principles of having internal tooling. You have your own MVC. You can have a structured MVC. You have an ORM and this inbuilt auth and security for that. So it all brings up to the fact that less is better. So another point about Adonis.js is the developer experience with Adonis.js is comparatively better compared to Express and Fastify and other JS frameworks. The reason being, you have to stick to the format of building in the same framework. So yeah, I wanted to test this out live again. OK, we have data points, and everything's fine. The report is there. But let me test it out. So I don't think a lot of us write code by ourselves anymore. We ask LLMs to write it. So if that's the same thing I did, I asked AI to write me an Express.js API. And it did give me an API. So let me just share it with you. OK. Yeah. So yeah, I asked. This is the good one. Sorry. So I asked AI to write one API in Express.js, and then I tested how well its design patterns or the whole way of writing the endpoints was with an API score, and then I fixed it. Just looking at the things that could normally go wrong is the way you name your endpoint. Now, you can have different ways you're naming and post endpoint, or you could literally have, as I mentioned, you could get user, create user, or you could have get all users. I know this is pretty opinionated, how does it matter what I name my endpoint? How does it matter if it works? It works. But having structure and design across your endpoints makes sure that everyone accessing them knows what is the base URL, what endpoints are doing, and then you have different methods over on top of them. Another very common things that we could always miss out on is not having proper error handling and having literally any error handling or any messaging. So a more structured way of having error handling is something that would make sure the design is consistent. And yeah, of course, keys. I personally have done this quite a lot of exposing my keys sometimes in my API code. Now, it's OK. It happens to the best, but it is normal. And data says that this happens more when you're building as a newcomer to a technology, you do these mistakes. And JavaScript framework being so supportive of people getting into tech or people getting into coding, that's why this is one of the issues with the education that we have currently right now. I wouldn't say influencers, but I think it is something that we need to be careful about if we are choosing a framework or if we are choosing a way to do something for our product or a company based on what influencers say maybe. Or probably it should be something based on tests, performance data, and all of that. But yeah, this is, again, an open-ended question. So let's see how it did on when we talk about the, let me check, OK. Just gonna pull up the other one. Yeah. So when I connected the API using the treble middleware, so you basically add 2 lines of code to your API, and then you can see the API score on treble. The overall score came up to be F, and this is the whole study about like what's working, what's not working. And let's just try to see what it's failing on. Like it's failing on a lot of things, but let's see if we can figure out like at least one of them. So let's look at design. Now, content pluralization. As I was saying, having some standard around how you're naming your endpoints is something that could bring in more structure. But this is literally something that could fail your endpoint in terms of having a better API score. Now, why does it even matter? Like, I don't care if I don't get a good API score. It does matter when you're building APIs on a production level for other companies that have GDPR laws, other companies that want your API to be secure and not be opening up any keys or everything. Coming back to the point, let's see how, if we fix a simple thing, how does that change? So then based on this score of like whatever things that were not working well, I decided to rewrite the API again with AI. I put in the report and I asked like, hey, this is what it's failing on, and can we fix this? So of course it did what I asked, but for the new API, what I basically added was more headers, more way to add security headers. Now, this is something that we normally don't do, is adding security headers to your API. At least with Express, you have Helmet, which can help you add all the required headers. And one favorite thing that I've seen affect a lot of API performance is just adding a course a course policy to your headers. Perfect. Finally, and when we checked the score after we set up basic things like, let me just go there. Yeah. Yeah. Once we set up basic things like having more standardization around endpoints, having more structured way of adding documentation, more structured way of how you want your response headers to look, how you want your response messaging to look, that's when the score will improve. Let's see. Now, this is the score I have for the other API. Yeah. So now, but I'm not going to aim for an A because it's actually not that easy to make sure that you can get an A on all the things, but we have done better. We fix things around content policy, we fix things around having the same type of pluralization that we were talking about. This all brings me to conclude that no matter what framework you're using, no matter what language you're using, there are some standardizations that we all can fix and make sure that we're building better APIs, make sure that we're having more secure APIs so that it's easier to, let me just, OK. Oh, let me just, I have a thing to share. OK, 1 minute. Yeah. So it was funny for me. I don't know if you followed this conversation once. Like, I found someone like having this whole conversation around should API endpoints be plural unless the underlying resource is conceptually singular. So this isn't an issue just for this isn't an issue just for smaller products that do not affect a lot of other APIs, but any API which is public-facing should have more standardization around it so that you have a better score and you can probably build better APIs. Finally, I think I am just not able to connect. OK. OK, the presenter view is gone. Anyways, so this was indeed the last part of my talk, where I wanted to demo two different APIs, using both written by AI, one following some standardization around how should be the what kind of design principles you should use, what kind of security checks you should use. And I feel the more standardization we bring to writing APIs, the better and the more secure we will be writing APIs. Coming back to the point, it is not a single framework. It is not a single language that should be an issue. It is more about educating ourselves to write better code, understanding who do we want to choose as an educational point, and if we want to base our research on data points or on just social media. But yeah, this is all from me for today, and thank you very much. I wanted to share the last slide. I had something, but I think I cannot get that up. Hopefully I could, but I think, yeah, that's all. But thank you so much. It's been lovely presenting here, and hope to see you again. Thank you.
Thank you very much, Pratim. Thank you. And last, for today, we have the amazing Sasha Griff, who, by the way, is flying here far from Japan just for you. And he's seriously jet-lagged, guys. So be nice to him. And he will show us the state of the web, not only of the JavaScript. Let's go, Sasha.
Okay. Wow. Okay. Hi, everybody. Yeah, so I just came from Japan, a bit jet-lagged, a bit tired. And I feel like you guys might be tired as well, because you've just sat through like 8 or 9 hours of highly technical talks. So I wanted to keep things a bit light, at least for the beginning, and just talk about myself, introduce myself. So I live in Japan, we know that. I'm a developer, also a bit of a designer. My name is Sasha, by the way. What else? We have 2 kids. And you know what they say about programming? Like, one of the really hard things is naming things. And I think the same is true for children, actually. So we named our first kid Jason. And obviously, for the second one, I picked YAML. My wife didn't really like that. But YAML is a great kid, very sweet. But Jason, we've been having some trouble. Like, he doesn't listen. He just doesn't accept comments. And yeah, I'm a developer. I run a survey called State of JavaScript, State of JS. By a show of hands, has anybody taken the survey before? OK, a few people. Keep your hand up if you had a positive experience and would like to take the survey again. Right, so as you can see, I really do like running surveys. I can't help myself. JavaScript, it's kind of everywhere around us these days. Like, it's crazy. Even on the plane on the way here, I was looking at the information screen, you know, and it said outside temperature NAN degrees. And then the pilot, the captain, came on, and on the speaker thing, he was like, this is your captain speaking, and we will soon be landing in object. So yeah, JavaScript again, it's everywhere. And I like planes because you really meet all kinds of people. Like, I was sitting next to another French guy. Oh, actually, let's try something. I want to involve you guys a little bit. So as I tell this story, if you hear the name of any framework or library that you're using, just make some noise, clap or shout, OK? So I was sitting next to another French guy, good looking, a very angular face, svelte body. And he had his hair up in a bun. And it was weird. He was reading a kid's storybook. And he was using a pen to underscore some parts. So I asked what he was doing. And he said that he was a playwright looking for his next solid idea. So I told him, well, I design websites, you know. And he asked for typography advice because he was working on designing a birthday card. And he told me he was going to use Helvetica. And I said, you know, for a birthday card, I think sans serif are the wrong type. Script is what you want to use. That's a much better way to express yourself. So I wanted to look at the view, so I was sitting next to the window. But I had to go to the toilet, you know, long flight. So I told him, sorry, but I have to go and pee. Could you get up and pee? So it took him a moment to react. So I said vite, which, of course, means quick in French. We had a good tailwind. So the plane landed early. And as he was getting up to leave, I realized I hadn't introduced myself properly. So I'd say, hey, I'm Sasha. And he turned towards me and he said, oh, nice to meet you, Sasha. I'm Webpack. Yeah, sorry, I couldn't fit in that one any other way. So anyway, I think I've wasted enough of everybody's time. So without further ado, let me talk a little bit about today's topic, which is the state of the web. What I've learned about web development through running online surveys. Now, I run 3 surveys, 3 main ones: state of JS, state of CSS, state of HTML. They each get a couple 1,000 respondents, usually. And people often ask me how the whole thing got started. And to understand that, we have to go all the way back to 2016, the beginnings of the modern JavaScript era. So earlier today, we had Evan talk about Vite, and he gave us a really nice overview of, JavaScript history. And 2016, React and Vue were just a couple years old. It was a good time, but also a very confusing time, because there were so many new options around. We were all suffering from JavaScript fatigue. And so that was the initial motivation behind starting those surveys, help make sense of web development for myself, but also for everybody else, because we all had the same issues. And of course, we had access to stats like NPM trends, which could tell us the number of downloads for any given library. But it didn't tell you, for example, if maybe people didn't actually like to use React. Or on the other hand, maybe there were fewer Vue users, but they were very passionate about it. And I'm talking at a React conference next month. I'll just switch around the... So in order to solve that, I wanted to ask not only about people's experience with each frameworks, but also their sentiment, like how they feel about it. And so that's what we did for the first ever survey in 2016, asking people if they would use React, Vue, Angular, and so on again. And it was kind of simple compared to what we're doing today, but still very successful. I think people really liked the data. And so I've kept doing it ever since. In 2019, I added the State of CSS survey, then GraphQL, React, HTML. And with the exception of the State of GraphQL, I've kept doing all of these surveys every year since. And now in 2025, I'm actually working on 2 new surveys, State of Web Dev AI and State of Devs, which I will talk a little bit more at the end of the talk. So before I talk really about the trends and the data, I want to talk a little bit more about the principles that I want to follow, which is using the web to solve survey challenges. Because I feel like a lot of surveys, they're still based on PDF reports or even like actual paper reports, and they don't leverage the web platform as much as they could. For example, we all like looking at nice charts and finding out who's #1, but I wanted to try and make the actual survey-taking experience more enjoyable. So one way we can do that is with something we call the reading list, which is whenever you are going through the survey, if you run into a feature or a library that you don't know about, you can add it to your reading list. And what that does is, at the end of the survey, you have a list of all those things, along with descriptions, links to resources, code examples, and so on. And you can even receive it by email straight to your inbox. So the idea is really to make the survey taking itself a learning experience and something where you don't feel like you're wasting your time. We also show you code examples as you're going through the survey. And we can even implement custom UI controls. So in this case, Leah Veru, a very, very talented and experienced designer and developer, she came up with this control where you can select the experience and your sentiment in one click, going back to that idea of capturing both variables. And we can do all of that, by the way, because we are using our own custom stack. It's not Google Forms or Typeform or some third-party service. It's really a custom-built React app, which is a lot of work, but on the other hand, it lets us do a lot of cool things like that. So another challenge is how do you let people customize the results? Because once the survey is finished and you publish the results, well, we're all different, right? We're different genders, we live in different places, we're interested in different topics. And I wanted the results to reflect that as well. But you can't just, have 200 charts for every possible permutation, every possible interest. What you can do, though, because this is a website, you can have a query builder. So that's what we have. You can, for example, filter the chart by gender is women, and you then get side by side the general income for all respondents on the left, and on the right, that same data, but filtered down to women respondents. And that, by the way, is possible because we have a different approach compared to most surveys. Traditionally, you would compile your data, and then you boil it down to a CSV or JSON file or something static. But we actually have a live GraphQL API that can connect to the database containing all the data, and that's what lets you build these very custom queries and filter the data how you want to. And finally, another example of leveraging the fact that everything is on the web is how we can aggregate trends without drowning out the details. So, typically, in a survey, you have two types of questions, right? You have questions with predefined options where you just click to pick an answer. And you have freeform questions where you type whatever you want. Now, predefined questions are great because they're very fast to answer, and the data you get is very clean. The problem is there's a risk of biasing the data, because if you forget to include an item in those options, then it won't show up in the results as well. On the other hand, here you're not biasing the data, but it's more work for the user, and it's also more work for the person processing the data on the back end, because you then have to normalize all that free text data. And when you normalize, another question is, do you do very broad categories, which will result in a simple chart with a few bars, easy to read, or do you do very granular categories where you have 20, 50 bars, each corresponding to thin slices of the data, and that gets very hard to read. So the solution we came up with is to have like both. So you have the top level bars, very broad categories, but you can also drill down and show the subcategories inside each bar if you want to. And then we can even drill down further than that, because if you click the comment icons on the right, you actually get access to the actual raw answers that people typed in to begin with. And as you can imagine, that wouldn't be possible in a static medium. Like in a PDF, you would have to include like just hundreds and hundreds of raw comments. That wouldn't work. But it is possible on the web if you have an API, and you can leverage that. So these were a few examples of what we're trying to do different from other surveys. But now I'm going to talk about the actual trends and the data that the surveys feature. So starting with the State of CSS survey. Now, the last State of CSS survey took place in August 2024. One thing that's always interesting is showing which features are the most loved. So let me break down this chart. The top level grouping is actually sentiment. So that first group with the green bar is positive sentiment, and then neutral, and at the end, negative. And then within those groups, you then have bars corresponding to people who have used the feature, heard about it, or never heard about it. And here, the most loved, even though it's not the most used, it is the one with the most positive sentiment. It's subgrid, followed by has and aspect ratio. And I know there's, not everybody is a CSS expert, so I'm going to give you a brief overview of each feature. Starting with subgrid. Now, for a while now, we've had CSS grid, which is great. It lets you align things on the grid. The problem, though, is when you go one level down, elements break out of the grid. They're not aligned anymore. And that's exactly the issue that subgrid solves. It lets you, say that the children of the top-level element should be aligned to that same grid. And that's actually extremely useful. And in fact, I use it for the charts in the report. These are actually HTML, CSS charts. And we use grid and subgrid to lay out the bars in the right spots. Now, subgrid is rated as newly available according to the baseline index. If you don't know baseline, it's an index made by the browser vendors, so Chrome, Mozilla, Microsoft, and so on. And it lets you know which features are safe to use or which ones aren't quite supported yet. The next feature was the has selector. By show of hands, who here has used the has selector? So quite a few people, but not everybody yet. So I'll just go over it quickly. Div has p basically translate as select all the divs that contain a p element. And you would think that's something that's been in CSS forever, but actually it hasn't been. It's fairly new, and it's very powerful. Just as a very simple example, if you have an article with sometimes just an H2, sometimes also a H3 subtitle, you can use the has selector to select all the articles that have an H3, and then say that the H2s inside that should not have a margin, which avoids having a double margin problem. And that's a very, very basic example, but you can do much cooler, much more complex things with has. Has is newly available, again, meaning it's supported by all 4 core browsers, and it's newly available for more than a year now. Finally, aspect ratio is a way to define the aspect ratio of an element, especially useful when you want to have square things. And that's actually rated as widely available, which means that 30 months have passed since it was available in all 4 browsers. And I guess one point I want to make here is that we often think that we can't yet use things like CSS grid, CSS subgrid. Even people sometimes think you can't use Flexbox because it's too new and it's not supported. But with things like baseline, you can actually know whether it's safe to use something or not. And it turns out that a lot of these features are actually quite ready to be used in production. Now, moving on to the State of HTML survey, which came out in September of last year. That one features a lot, focuses a lot, on browser interoperability. Because going back to what I was just talking about with baseline, a worry we often have is that things are not supported in all browsers, or maybe are not supported the same way. There might be slight differences, slight incompatibilities that mean we can't yet use those features. And so this chart shows which existing features people are not using because of incompatibilities between browsers. And what's cool is that browser vendors have this initiative called Interop, which is a working group that takes place every year, precisely to decide which feature to focus on next and solve these interoperability issues. And the Interop group actually uses the state of HTML and state of CSS as data points to come up with their list of features to focus on. So since starting those surveys, I've been more involved with the different working groups. And I've been really impressed by the people who just work on browser vendors. They're all very passionate, and they all really care about the open web and the web platform. And so I think it's quite cool that I'm able to help out even just a tiny bit in that effort. Finally, State of JS. Those results were published in last December. And the State of JS, unlike the other two surveys, it focuses a lot on the ecosystem, on frameworks, libraries, and so on. And here, when ranking libraries by most loved, you can see that Vite is #1. I think Evan also mentioned that in his talk. But what I want to point out is that #2, React, and #3, Vue, they've actually been around for like over 10 years at this point. And I feel we often have this image of the JavaScript ecosystem as something that's just constantly changing. And it's not quite true, right? Because React and Vue have been around for a long time, and they are still well-loved, well-maintained. And sure, they are changing internally, that's true. But the teams have been doing a really good job of carrying them along, evolving them, along with the needs of the community. So although as JavaScript developers, we do like to complain, I think when you look at the actual state of things, it's not as bad as we make it out to be. And I think that's also something that surveys can be useful for. It's as a way to show maintainers that actually the community supports their projects and appreciates them. If we look at usage, React is also very dominant, #1 by a lot. What's interesting, though, is that starting in 2023, Vue overtook Angular in terms of usage. I thought you guys would clap for this one. And Angular is gaining ground a little bit, so I think 2025 is going to be very interesting. Svelte is #4, far below the top 3, but at the same time, far ahead of the rest of the pack. So at this point, I think it's fair to say that Svelte is here to stay and has become a really good #4 framework, and it's steadily growing, so in the future, who knows what might happen. Now, another question we ask is about JavaScript versus TypeScript usage. What's clear here, the single biggest bucket is people who write 100% of their code in TypeScript. The vast majority writes more TypeScript than JavaScript. And personally, it took me a long time to get onto the TypeScript bandwagon. But at this point in 2025, I think even if JavaScript still has its place, by all means, I think you do need to know TypeScript. And even though in the beginning it can be a bit tough, it does slow you down, I think it's a worthwhile investment, especially given the direction the ecosystem as a whole is going. I also asked about AI code generation, because I'm sure you guys have all seen, like, on X, on social media, you have all these posts about people creating apps in a weekend using AI. Just type in the prompt and you get an app ready to deploy. And the survey shows that virtually nobody is actually doing that. Only like 18 people are just using AI to write their entire apps. The much more common use case is maybe not using AI at all, or if you do, using it to generate like 10–20% of your code for helper functions, components maybe, but very specific things. So if, like me, you kind of felt behind the times because you're not just printing out whole apps with a single prompt, don't feel bad. We're actually still the majority. And finally, I wanted to talk a little bit about new proposals. So these are all proposals, CC39 proposals that are coming to a browser in the near future, ranked by how excited people are about them. So number one is temporal, which promises to replace the date API. And then decorators, another long-awaited feature. And then some more esoteric stuff like explicit resource management. But yeah, I think this is cool because sometimes it's a bit abstract to know what's coming in the language itself. We're not all checking the CC39 GitHub in the chat rooms and so on. But it's cool to see that there are features that are coming and that the community is very excited about. OK, so I'm going to wrap up, but I want to talk a little bit about upcoming surveys. The State of Web Dev AI is already closed, but the results will be coming soon. And it's a survey about AI, but it's not a survey for AI people, because I wanted to survey just web developers as a whole to know how they're using AI, but also just if they are using AI, because I think there's a lot of hype, and a lot of us are, like I said, still coding a lot of things by hand. So I'm actually working on the results right now, and I think it's going to be very interesting to see which tools people are actually using and how much of their code they are generating through AI. Another survey that's coming this year is going to be the State of Devs. And this one is going to be about everything that's not programming. So things like workplace, career, even health, politics, all the things that make us the people we are when we are not actually just coding. And so this one is going to be live. You're going to be able to take it also in April. But you can go to both URLs right now to sign up for our mailing list and know when new surveys come out or are open for filling out. So with all that said, thank you very much for enduring a whole day of talks and still listening to me. Thank you for taking the surveys. I hope I see you in future surveys as well, because I do think they can provide useful data for the community. And yeah, just also be sure to join our game show very soon. And thank you all for today.
Thank you, Sasha. Thank you very much. Can you say something in Japanese?
Oh. 不好意思，我真的不会说日语。
What is the meaning of that?
I said I don't know how to speak Japanese in Chinese.
Okay. Okay, guys, so it's the end of our day today. I would like to thank every one of you who's been with us for those 3 days or today full day. I would like to say thank you to the speakers. We have amazing speakers. To look at all those guys. Let's give them applause. Of course, I would like to say thank you to our sponsors, amazing sponsors who make this conference with us today. And last but not least, I would like to thank our team for making all this happening today. It's been an honor being your MC, and I'll see you in 10 minutes for the game show. Thank you.
We'll trampoline